Hey everyone, currently you're viewing a free 6-hour preview of the PHP course on YouTube. I hope you enjoy it. If you're interested in the rest of the course, you can check out the link in the description. The entire course is over 20 hours long, diving into other topics, such as MVC frameworks and dependency injection. Without further ado, let's jump into PHP. Welcome to the Modern PHP Developer course. You've taken your first step into becoming a professional web developer. PHP is one of the best languages you can learn. Now, hold on a moment. That's a controversial statement. A quick online search yields hundreds of results declaring PHP a dead language. Over the years, many programmers have developed a misconception about PHP. Let's examine the facts to decide whether PHP is a perfect fit for you. First and foremost, 80% of sites are powered by PHP. Can you believe it? That pretty much means that 8 out of the 10 websites you visit are using PHP under the hood, thus solidifying itself as a reliable language for the web. On top of being a popular language, performance is another strong point. Over the years, maintainers have taken every step to improve the speed of PHP. Without a doubt, those efforts have paid off. Apps have seen significant improvement in performance with each release. Lastly, new features are constantly introduced in the language. Since PHP has wide adoption, the PHP team can tailor and fine-tune the language for the community. They've introduced features that can be found in most modern languages. These features can help us write better, more efficient code. There has to be a catch, right? After all, developers are avoiding PHP for a reason. PHP is one of the most beginner-friendly languages available. Within a weekend, deploying a site from development to production is possible. Unfortunately, this aspect of the language is a double-edged sword. Security vulnerabilities can easily be introduced into a site. As a beginner, you should always take the proper precautions for writing secure code. More often than not, beginners tend to overlook basic security features. Worst of all, terrible programming practices can easily plague an application. Scaling an application should always be one of your top priorities. That's difficult to do when the code is poorly written. Luckily, you're taking this course. My goal for this course is to help you become a proficient PHP developer. Unlike other courses that teach you the basics and send you on your way, this course covers a wide variety of topics, starting from the basics of the language to covering advanced features, such as security and MVC architecture. If you're interested in a complete overview, I highly recommend checking out the course description. As we progress through the course, I'll be sure to point out best practices. This way, you can avoid common pitfalls most beginners fall into during their journey. I know you're antsy to get started, but there's one thing you should know before digging into the course. This course assumes you have knowledge of HTML and CSS. Our focus is primarily going to be on PHP. To save time, I'll provide most of the HTML and CSS without reviewing every single line of code. You're expected to understand basic HTML syntax. In addition, JavaScript would be nice to know, but not required. JavaScript is not a language we'll be using heavily. If you know JavaScript, that'll come in handy. Otherwise, don't worry about it. A lot of content is covered. To get the most out of this course, I have a few tips. First and foremost, download the free ebook. Watching videos can be a great way to learn new topics. Along your PHP journey, you're likely to forget a few things. That's perfectly natural. Scrubbing through a video to refresh your memory is not convenient at all. As humans, we can read a book faster than we can watch a video. For this reason, I've provided a book to act as a supplement to the course. The book summarizes the key points discussed in each lecture. It can be a great way to review specific concepts. You'll get an opportunity to download the ebook in the following lecture. Secondly, I recommend tackling the exercises and quizzes. In the first half of the course, I've provided simple exercises for you to tackle. Of course, solutions to each exercise are provided to compare your code with mine. The best way to learn to program is to write code yourself. These exercises are meant to challenge you. If you're able to solve an exercise successfully, this means you've understood the content of the course. Lastly, use the Q&A section to your advantage. I'm here to answer your questions and doubts. I would be lying if I said you wouldn't encounter problems. If something doesn't make sense or isn't behaving as expected, ask for help. Typically, I'll respond within 24 to 48 hours. With that being said, there are certain things I can't help with. I can only answer questions related to the course. Questions related to personal projects will not be answered, since I don't have enough time to provide consultation. Alright, it's time to start learning. I hope you're excited. It's going to be a long but worthwhile journey. When you're ready, I'll see you in the next lecture. In this lecture, we're going to start preparing an environment for PHP. It's going to be easier than you think. But what is an environment? Why is it important to have one? Let's demystify this concept before taking a step further. Suppose we were gardening. What does a garden need? There needs to be soil, sunlight, and water. Without the proper environment, our plants would not be able to flourish. It's absolutely critical to cultivate land for growing plants and food. The concept of preparing an environment for gardening can be applied to the programming world. Applications need the proper environment for running code. In the programming world, an environment is the machine where the application runs. In most cases, applications rely on additional software. Without the proper tools or programs, our applications won't work. Generally speaking, there are two types of environments, which are local and production environments. A local environment refers to the setup you have on your personal computer or local machine, where you can write, test, and run your code. Local environments are primarily used for development and testing purposes. This allows you, the developer, to break things without disrupting your users. You can freely modify and make changes before shipping a program to the world. On the other hand, a production environment is a live environment where your code is actually deployed and running for end users. A production environment is typically hosted on a remote server. It is designed to handle the demands of real-world usage, including security, scalability, and reliability. The production environment is also monitored, managed, and maintained by a team of professionals to ensure optimal performance. It's not the place to test our code. If we accidentally upload error-prone code, our users will be affected by our actions. As you can imagine, we will be working in a local environment. Setting up an environment can take a bit of time. Luckily, the PHP community has taken the time to provide solutions for quickly stirring up PHP environments. In the resource section of this lecture, I provide links to the most popular solutions. Developers have a plethora of options for installing PHP. There are dozens of programs online to easily prepare an environment for running PHP on a local machine. You may have encountered them, such as XAMPP, MAMP, or Laragon. While these programs are helpful, we're going to take a different approach. One of the links in the resource section takes you to a site called Replit. Replit is a service for creating environments for various programming languages. Best of all, our environments are completely accessible from the browser. We do not need to install programs on our machine to run PHP. I find that Replit is the easiest solution for beginners to get started with PHP. Here's what I want you to do. Create an account on Replit and log in into the dashboard. I'm going to quickly sign into my account. I'll see you in a moment. Alright, after signing up for an account, let's create an environment. Keep in mind, environments created on Replit are meant to be for development purposes. The applications built on this site are not meant to be publicly hosted for the world. In the future, we'll discuss some options for publicly hosting your app. For now, let's shift our focus to creating a new environment. At the top left corner, there's a button called Create. Click on it. A pop-up is going to appear to ask us a few questions. Firstly, we must select a template. As I mentioned earlier, Replit supports multiple programming languages. From the template option, we can search for PHP. A few options may appear. The option we're interested in is called PHP Web Server. Make sure to select this option. Otherwise, you may encounter errors when going through the course. Next, we must provide a name for our new project. Let's call it PHP Fundamentals. Lastly, let's create the project. Replit starts preparing our environment on our behalf. This process may take a few moments. Just be patient. After all has been said and done, our environment is ready. Let's make a few tweaks before writing code. At the bottom left corner, there's a list of tools available. From this section, there's an option to modify the settings of the project's code editor. In my opinion, the font size is too small. You may feel the same. On the Settings tab, there's an option for enlarging the font. Select a font size that's suitable for your needs. Hopefully, you can read the code on my screen. Great, we're ready to run the project. At the top of the page, click the Run button. Behind the scenes, Replit takes the time to launch our PHP application. After a few moments, a new tab appears for previewing our application. The message "Hello World" renders on our screens. Isn't that awesome? With a few clicks, we've got a working environment. Below the preview, there's a section called Console. The console is a feature we don't need to worry about. It's taking up unnecessary room on our screens. Fortunately, we can click on the Web View portion to drag it around. If we hover this section of the editor with the console, it'll get merged with the console as a tab. I recommend moving things around to reduce clutter. All we need is the file tree, code editor, and preview. Everything else will be explored as we learn more about PHP. If you have experience with PHP, you may be curious as to why I haven't mentioned Docker. Docker is a tool for managing environments on your machine. Professional PHP developers use Docker for their projects. So, why aren't we using it? The reason is simple. Docker is very complicated for beginners. I want us to focus on the basics of PHP before diving into larger, more complex tools. I consider Docker to be a great option. For now, Replit will suffice. It's time to finally start coding. For the rest of this course, I'm going to assume you have the PHP server running unless I state otherwise. When you're ready, I'll see you in the next section. In this lecture, we're going to dive into programming theory. More precisely, we're going to talk about what PHP is doing when we write code. To kick this discussion off, I think we should take the time to define PHP. That's going to make sure we're all on the same page. Here's the best definition of PHP available. PHP is an open-source, general-purpose scripting language for developing web applications. Whoa, what does all that mean? Let's slowly unpack that definition to fully grasp PHP. First and foremost, open-source software, OSS for short, refers to code that has been freely released to the public. Anyone can study, modify, and redistribute the software. Collaborators from all over the world have voluntarily contributed their time to improving PHP. It's one of the largest open-source software projects in the world. You may be curious, does this mean that you can download the original code for PHP and modify it? The answer is yes, you can. In the resource section of this lecture, I provide a link to the official PHP GitHub account. On this page, you're going to find various links related to the PHP project. Everything is available to the public free of charge. If you don't like where PHP is heading, you're more than welcome to modify the language to your heart's content. However, most people are happy with PHP, so that probably won't be necessary. Regardless, it's still good to know where PHP is discussed and maintained. Moving forward, let's keep dissecting the definition of PHP. I mentioned that PHP is a general-purpose language. A general-purpose language is a programming language that can be utilized to develop different kinds of programs. Originally, PHP was introduced as a language for developing web applications. As time passed, developers discovered it could be used for other things. It's possible to develop command-line scripts, desktop applications, image processing libraries, and so much more. Programming languages are considered to be general purpose when they can be used to solve a wide array of problems. For all intents and purposes, this course primarily focuses on web development with PHP. Other areas of software development aren't explored. You're more likely to be hired as a PHP web developer than a PHP desktop application developer. Lastly, PHP is considered to be a scripting language because it's interpreted. Technically, it's not wrong to call it a programming language. After all scripting languages are programming languages, but the reverse isn't true. Not all programming languages are scripting languages. That leads us to the question, what does it mean when a programming language is interpreted? If you've ever watched a movie or TV show about computers, you may have seen something like this. What you're being shown is called binary code or machine code. Binary code is the only language that computers can understand. As you can imagine, reading binary code is not the most ideal situation to find yourself in. For this reason, programming languages were introduced to improve readability. On the other hand, a new problem arises from using programming languages. Since computers can't understand programming languages, code must be transformed into machine code. This is where a program called a compiler comes into play. The job of a compiler is to transform our code into machine code. After our code has been transformed, the instructions written from our program can be executed by a machine. This concept is not exclusive to PHP. Other programming languages share this feature, whether it's Python, C++, or Rust. So, what does this have to do with an interpreter? There are two main approaches to generating machine code. You can use either a compiler or an interpreter. A compiler and an interpreter are tools used to translate computer code into a form that a computer can execute. The main difference between the two is how they do it. A compiler translates the entire code of a program into machine code in one go and saves it as an executable file. This file can then be run as many times as needed without recompiling it. An interpreter, on the other hand, executes the code line by line, translating each line of code into machine code and then executing it immediately. It does not generate an executable file. Here's another way of thinking about it. A compiler is like a translator who translates a book into another language and then gives you the translated book to read. An interpreter is like a translator who translates a sentence and then reads it to you immediately. So, you may be wondering, is PHP compiled or interpreted? PHP is interpreted. Programming languages that are interpreted are considered to be scripting languages. Therefore, PHP is a scripting language. With that being said, there are debates about which approach is better. Should programmers use compiled languages or interpreted languages? Those discussions are beyond the scope of this course. All you need to know is that PHP is interpreted. By installing PHP, we have access to the PHP interpreter for transforming our code into machine code. The next step in our journey is to start using the PHP interpreter. In the next lecture, let's start writing our first PHP script to run it through the PHP interpreter. In this lecture, we're going to execute our first PHP script. This means we'll create a PHP file, run it through the PHP interpreter, and view the output. The question is, how can we use the PHP interpreter? We're going to use a server for performing this job. Oftentimes, I find that beginners confuse web servers and the PHP interpreter. The job of the PHP interpreter is to transform our code into machine code. On the other hand, the job of a web server is to deliver files. To better understand, let's look at an example. In a real environment, we may have dozens of files. Servers may contain a mixture of HTML, CSS, and image files. In our browsers, we have the power to request specific files from a server. For example, let's say we wanted the about.html file. A request from the browser is sent to the web server. The job of the web server is to find the file specified in the URL. If a file is found, the file gets sent back to the browser. Lastly, the browser renders the file on the screen. Overall, it's a straightforward process. However, there's one problem with this process. Websites that deliver the same files to the browser are known as static websites. It doesn't matter how many times visitors refresh the page. They're delivered the same files. Nowadays, most websites are dynamic. Rather than delivering the same page, pages can be tailored to our users to provide a unique experience. Websites that generate unique content are known as dynamic websites. Web servers can be configured to process PHP files. For example, let's say our server has PHP files. In the browser, we can request a PHP file from the server. Our server searches for the file to deliver to the browser. So far, the process is very similar to static websites. Afterward, things begin to take an alternative route. Web servers don't immediately send the PHP file back to the browser. Instead, servers are capable of running the file through the PHP interpreter. We'll wait for the interpreter to generate HTML. Once an HTML page has been created, the file gets sent to the browser to be rendered on the visitor's machine. Understanding this process is absolutely crucial. PHP does not run in the browser. Servers are meant to execute and handle the output of a PHP file. Fortunately for us, we're using Replit. Behind the scenes, a server has been configured to deliver files. At the same time, if we request a PHP file, it'll be processed through the PHP interpreter. Let's try demoing this process. In the file tree, open the index.php file. PHP files must have the PHP extension. Otherwise, web servers will not run the file through the PHP interpreter. If the server encounters a non-PHP file, it'll automatically get sent to the browser without further processing. Inside this file, there may be initial code. It's completely fine to leave the file empty. We're not going to need the starter code provided by Replit. Now the question is, what kind of code can be written from within a PHP file? Believe it or not, we can write valid HTML code. All HTML features are completely supported in PHP files. After all, PHP files get transformed into HTML files. It only makes sense that HTML syntax is supported. For example, let's try adding a pair of h1 tags with the message, "Hello World." Original, I know, but just keep following along. After adding the h1 tag, we must refresh the preview by pressing the refresh icon. Make sure you're refreshing the preview, not the browser. If you were to refresh the browser, the entire editor gets reloaded. I know it can be annoying to have to constantly refresh the preview. There's a shortcut for forcing a refresh. On your keyboard, you can press Ctrl+S shortcut to save the file. For Mac users, this command would be Command-S. By default, Replit auto-saves your files. If you were to trigger the save action, the preview automatically refreshes. It's a simple trick that you should remember going forward. As you can see, our message appears in the preview. Cool, right? As a simple exercise, let's try creating another PHP file. In the file tree, create a new file called about.php. Once again, make sure the file has the PHP extension. Otherwise, our code won't be processed through the PHP interpreter. Next, inside the about.php file, let's write a simple message to help us identify the file in the browser. So far, so good. Now the question is, how can we preview the contents of the about.php file? Our preview continues to display the message from the index.php file. To view the contents of the about file, we must update the URL. Unfortunately, this isn't possible directly from the preview. We must open a new tab to view this information. On the right side of the Web View tab, there's a button for opening the site in a new tab. Click on it. As you can see, Replit provides a free URL for previewing our site. At the end of the URL, add the following, about.php. After inputting this path, the contents of the about file are rendered. Voila! We've successfully created another page. You may be wondering, how does the server know to deliver the index.php file when a file is not specified? If I were to remove the file name from the path, the contents of the index.php appear. Strange, right? Well, not really. By default, most web servers are configured to deliver an index.php or index.html file to the browser if a file is not specified. This is why we're able to view the contents of the index.php file. That's about it. So far, PHP doesn't seem all that different from HTML. Don't worry, in the next set of lectures, we're going to get an opportunity to generate dynamic content. When you're ready, I'll see you in the next one. In this lecture, we're going to start entering PHP mode from our files. Starting from where we left off in the previous lecture, we're going to continue modifying the index.php file. Actually, we're not going to need to view other files for a while. To reduce distraction, I recommend closing the sidebar by pressing the button in the top left corner. Closing the sidebar leaves us with the code editor and preview. Awesome. Now, what am I talking about when I say PHP mode? Well, if we were to write HTML inside a PHP file, the PHP interpreter does not process the HTML portion of our file. That's not exactly what we want. We want the PHP interpreter to execute instructions written from our file. In order to do so, a pair of PHP tags must be added to the file. Follow along with me. At the top of the file, add the following characters: less than, question mark, PHP, space, question mark, greater than. Congrats! You've created your first pair of PHP tags. By adding these tags, we're entering PHP mode. Entering PHP mode allows our machines to begin executing instructions. These instructions can vary from sending an email, processing a transaction, or registering a new user into our system. PHP tags are always necessary. We must always tell the PHP interpreter which portion of the PHP file contains instructions and which portion contains regular HTML. As you might have already guessed, multiple PHP tags can be inserted into the file. For example, let's add another pair at the end of the file. Refreshing the page results in the same output as before. That's to be expected, since we haven't written instructions from within the PHP tags. Before we do, there are a few more things worth mentioning. Firstly, PHP tags can be written from within HTML tags. As an example, let's replace the text inside the h1 tags with a pair of PHP tags. The text disappears from the preview. This is considered completely valid PHP code. Being able to write PHP inside HTML gives us the power to generate dynamic content in various locations of our HTML page. The second thing I wanted to mention was being unable to do the reverse. This time, let's move the h1 tags inside the PHP tags. A different result gets produced. In the preview, an error gets rendered by the PHP interpreter. But why? This is because the rules of PHP mode are different from HTML mode. Inside PHP tags, we must write valid code. In the English language, there are rules for how English is read and written. There's a specific structure we must follow for writing English, such as ending a sentence with a period or capitalizing the first word of a sentence. The rules for human languages are referred to as grammar. In a similar sense, programming languages have rules for how they're read and written. These rules are referred to as a programming language's syntax. This is why we're getting an error. We're not following PHP's syntax rules. As a result, the PHP interpreter is unhappy. In the next lecture, let's start learning PHP's syntax rules. In this lecture, we're going to start writing PHP code by learning about the echo keyword. First off, what is a keyword? Keywords are a feature in PHP for performing specific actions. If we type a keyword, the PHP interpreter understands that we're trying to perform a specific action based on that keyword. PHP offers various keywords. In the resource section of this lecture, I provide a link to an official list of keywords from the PHP documentation. Throughout this course, we're going to explore most of these keywords, starting with the echo keyword. Let's head over to our editors. Previously, we added a few PHP tags. I think this is a bit excessive. Let's remove all of the tags except the opening tag. But why are we leaving just the opening tag? Don't we need a closing tag too? Here's the cool thing about PHP. If we don't plan on exiting PHP mode, we don't need to add a closing PHP tag. A closing PHP tag becomes optional when we only intend to write PHP code. In most cases, developers often omit the closing PHP tags for files that only contain PHP code for readability. After removing the tags, let's write the echo keyword. So, what does the echo keyword do? The echo keyword instructs the interpreter to output content. Developers like using this keyword to output text. For example, let's add the following: space, quote, hello world, quote, semicolon. Pay close attention to the types of quotes I'm using. I'm writing the message with double quotes, not single quotes. After adding this text, we can refresh the page to view the output. The message written after the echo keyword appears on the page. Pretty cool, but what's up with the strange syntax after the echo keyword? Let's break it down. Firstly, our message must be wrapped with quotes. This is how PHP is able to understand that we're trying to write raw text. Do you remember the last time we wrote HTML inside our PHP tags? PHP didn't like that. Previously, we had to adhere to the syntax rules of PHP. By using quotes, we're allowed to write whatever we want without PHP complaining. In this case, we're writing hello world. Lastly, we're adding a semicolon character. This character denotes the end of a statement. In my opinion, one of the hardest aspects of programming is learning the terminology. It's half the battle. A statement is another way of describing a single instruction given to a machine. In most cases, statements can be a single line of code. Programming languages give us the ability to communicate with a machine. Instructions can be given to a machine to perform various tasks, from sending an email to processing a transaction. You can think of a statement as a single sentence in the English language. Multiple sentences can be combined to create a book. In a similar sense, multiple statements can be combined to create an application. So, what's the difference between a keyword and a statement? A keyword refers to a single word in a line of code, whereas a statement describes the entire line of code. Back to the task at hand. We added a semicolon character to tell the PHP interpreter that we're finished with this line of code. PHP doesn't know when you're finished with a specific instruction. You must explicitly inform PHP when you're finished with an instruction. Once you've added the semicolon character, PHP moves on to the next instruction. So, for example, let's write another echo statement. This time, I'm going to write the following message. My name is John. In the preview, our new message gets rendered. You may have noticed, but PHP executes our code in the order the instructions are written. Statements are executed from top to bottom, similar to how books are read from top to bottom. The order of your code does matter. Alright, I think it's time for an exercise. This exercise is fairly straightforward. I want you to wrap the echo statements we've written with a pair of H1 tags. That's it. Pause the video and give the exercise a try. Good luck! Welcome back. Hopefully, you were able to tackle the exercise. If not, that's fine. Let's walk through the solution together. First, let's close the PHP tag since we're going to write HTML. Next, wrap the PHP tags with a pair of H1 tags. That's it. The preview shows us that the text has been wrapped with H1 tags because the text is enlarged. Now, you may have come up with an alternative solution, which is just as valid. An alternative solution would have been to write the H1 tags from within the quotes. I'll quickly undo the changes I made to my file. Next, I'll wrap the Hello World message with H1 tags. These tags should be inserted from within the quotes, not outside. This time, only the first message gets enlarged. So, which solution is better? In our case, it doesn't matter. You're going to see both solutions in the real world. It's not uncommon to write PHP inside HTML tags or to write HTML tags from within an echo statement. Either solution is valid. Let's continue our journey in the next lecture. I'll see you there. In this lecture, we're going to learn another feature of PHP, which are comments. As you already know, comments in HTML were designed for adding notes in our code. They serve the same purpose in PHP. The main difference is how they're written. PHP supports 3 variations for comments. The first syntax for comments is 2 / characters. After these characters, we can write whatever we want. We can even type gibberish. Comments are not processed by the PHP interpreter. Therefore, anything can be written inside a comment. Let's add a comment above the first echo statement. The comment we've written is considered a single-line comment. As the name implies, only the code on this line is affected by the comment. If I were to attempt to write more text on a new line, errors would get thrown. In some cases, you may want to write a long comment. Technically, we could write a comment on a single line, but that would be harder to read. This dilemma leads us to the following type of comment, called a multi-line comment. They're written with the following characters, /**, ***/. In between these characters, we're allowed to break our comments into multiple lines. As long as our text falls between these characters, they're considered to be within the bounds of the comment. This type of comment is called a multi-line comment. They were designed for longer comments. There's one more syntax I want to show you. There's an alternative syntax for writing a single line comment. Rather than using / characters, you can use a hash character. This character also denotes a single line comment. It's not as popular as other solutions, but you may come across it. In the preview, nothing appears aside from the messages in the echo statements. Comments are completely ignored by the PHP interpreter. Overall, comments are a feature for documenting our application. Throughout the course, I'll be using comments to add additional notes to our code. In the next lecture, let's start talking about variables. In this lecture, we're going to start using variables for storing data. So far, we've written comments. They're nice and all, but they're not all PHP has to offer. Programmers are often dealing with data. Data can range from addresses to the price of a product. Often, most pages on the web rely on data. Otherwise, we'd be staring at the same page. PHP has a feature called variables for storing data. A common analogy for variables is boxes. We can use boxes for storing physical items. If you're moving, it's common to label boxes to describe the contents of the box. For instance, if a box contains dishes and utensils, you may label the box as kitchen. The inner contents of the box can be considered the value. Variables are similar to boxes from the real world. Unlike boxes, variables don't store physical items. Instead, they can store file data, form data, or data from a database. They're extremely flexible for storing any kind of data. Let's try creating a variable. In the index file, I'm going to clear the contents of the file except for the opening PHP tag. Everything else isn't necessary. After doing so, type the following, $age, semicolon. There are a few rules for writing variables in PHP. Variables must begin with a $sign character. By typing this character, PHP allocates memory on a user's machine to store data. This symbol is followed by the name of the variable. Variable names follow strict rules. Firstly, names are allowed to contain alphabetic characters, numbers, and underscores. Secondly, special characters are not allowed. For example, the @ symbol can't be used as a variable name. Lastly, the first character of a variable name may be a letter or underscore. While numbers are allowed in variable names, they cannot be the first character. Besides these rules, PHP gives us a lot of freedom in naming our variables. There are a few good practices worth mentioning. Firstly, variable names should be descriptive. For example, let's say we had a variable for storing the total price of a user's purchase. The name of the variable could be called total price. That name is short, clear, and concise. A bad example would be an abbreviation called TP. We might understand what that means, but what would our coworkers think of the name? If you're working on a team, your team members may not be able to understand the purpose of the variable. Descriptive names provide clarity. In some cases, you may need to use abbreviations for variables with long names. If that's the case, your abbreviations should be easily recognizable. For example, we may need to store the name of a customer. A good abbreviation would be CUST name, where CUST is short for customer. However, using the name cust_n is harder to recognize. Another useful tip is to avoid using single letters as variable names. This circles back to the first tip. Using a single letter doesn't describe the type of data stored in a variable. With that being said, some developers will use a single letter when dealing with loops. That's the only scenario where using single letters is fine. In most cases, you should stick to using longer, descriptive names. Being consistent is another good habit to pick up. Your variable names should have consistent spelling. Mixing the casing of your variables can result in confusing and unreadable code. Last but not least, you should avoid generic names. For example, you may need to store user data in a variable. It may be tempting to call the variable data, but that doesn't exactly describe what type of data you're storing. Are you storing file data, database data, or maybe you're storing product data? The more precise you are, the better. Overall, these tips should help you with naming your variables. What if you need to write multiple words from within a variable name? As mentioned before, we can't use special characters, such as spaces. Developers have come up with 3 naming conventions for these scenarios. The first naming convention is called camel casing. In this format, every word is capitalized except for the first word. By doing so, it's easier to read the words in a variable name. Up next, we have a format called Pascal casing, which is similar to camel casing. Every word is capitalized, including the first word. Lastly, snake casing is another format that uses lowercase letters. Instead of capitalizing each word, words are separated with underscores. You're allowed to use whatever naming convention suits your application. Generally speaking, most PHP developers prefer camel casing for variables. However, if you decide to use a different naming convention, that's perfectly fine. The most important thing is to be consistent. For this course, I'll be sticking with camel casing for multi-worded variable names. We've successfully created our first variable. Currently, it doesn't store anything. In the next set of lectures, let's start storing data. In this lecture, we're going to store a value inside the variable we created from the previous lecture. We can accomplish this task by using an operator. To be more specific, the assignment operator. But what is an operator? An operator is a symbol or character that accepts a value. This value then gets produced into an entirely new value. This is important to understand. Operators always create a brand new value from an existing value. In the resource section of this lecture, I provide a link to PHP's documentation page for its operators. Out of the box, dozens of operators are available for various actions. We're going to be exploring most of them throughout the course. To get started, let's take a look at the assignment operator. The job of the assignment operator is to store a value in a variable. Back in our project, we have a variable called age, which doesn't store anything. Let's update the variable by typing the following after the name of the variable. Space equals space 29. In this example, we're storing a number. Unlike raw text, we don't have to wrap numbers with quotes. They're optional whenever we're dealing with numbers. Next, let's try echoing the age. In the preview, the age gets displayed. Perfect. We've got a variable for storing the age, but how is it working? The equal sign character is known as the assignment operator. This operator can be used to store a value inside a variable. The variable name must always appear to the left of the operator. The value must appear to the right. Creating variables allows us to reference a value anywhere in our script. In our case, we're referencing the value from the echo statement. Previously, we would type the value immediately after the echo keyword. This time, we're referencing the variable by typing its name. Whenever variables are created, PHP stores the value in its memory. Afterward, if PHP encounters a reference to a variable, it'll replace the reference with the value stored within the variable. In a nutshell, typing echo age is the same as typing echo 29. Hopefully, you can see the benefits of variables. Storing values in variables is more efficient, as we can reference the value multiple times anywhere in our script. Things get even more interesting when trying to update a variable. For example, let's say my birthday pops up. This means my age should change. Variables can be updated the same way they're created. On a new line, type the following: $age equals 30 semicolon. PHP is smart enough to update the existing variable to the new value. We don't have to worry about our programs hogging resources whenever a variable needs to be updated. Isn't that awesome? PHP is capable of being efficient with our program's variables. The number 30 appears in the preview, thus proving that our variable was updated. Before I end this lecture, there's one warning I want to put out there. As we know, variables are case sensitive. It can be easy to create a variable when you originally intended to update a variable. For example, let's say I typed the word age with a capital A. In our preview, the original number gets rendered. Despite being spelled the same, PHP interprets these definitions as completely different variables. A single typo like this can cause issues. Worst of all, PHP does not throw errors for simple variable typos. If you ever run into a problem where your program is not behaving as expected, the problem may have to do with a typo. Typos are more of a common problem than you think, so just be aware of that when working with variables. I'm going to remove the second age variable. We don't need it anymore. After removing that variable, let's get into data types. In this lecture, we're going to briefly discuss data types. Applications can store various types of data. Variables are the most common solution for storing data. For the best performance possible, programming languages categorize data. Categories for data are known as data types. For example, if you're working with numbers, the data type will be an integer. If you're working with a file, the data type should be for a file, so on and so forth. But why? Why is it important to categorize our data? Categorizing data allows programming languages to optimize your applications. If a variable stores a number, the program never has to worry about working with dates or random text. In addition, it provides clarity as to the type of data you're working with, which can be helpful with debugging an application. Data types are important in PHP because they determine the type of data that a variable can store and how it can be used in your code. By specifying the data type of a variable, you can ensure that it can only be used in a certain way and prevent unexpected errors from occurring when the code is executed. For example, consider a scenario where you need to calculate the average of a set of numbers. If you store these numbers with the incorrect data type, you will not be able to perform mathematical operations on them. Any calculations would produce inaccurate results. However, if you store these numbers correctly, you can perform the calculation as expected. Here's an analogy to help understand the importance of data types. Imagine you are cooking a meal and need to measure ingredients. If you were to use a cup to measure salt instead of a teaspoon, the amount you would use would be significantly different, and the meal would not turn out as expected. This is similar to how using the wrong data type in your code can result in unexpected results. By specifying the correct data type, you can ensure that your code produces the correct results, thus preventing bugs and errors from occurring. With that being said, programming languages tackle data types differently. The concept of a data type is not unique to PHP. Most modern programming languages have data types. Generally speaking, there are two types of languages, which are statically typed languages and dynamically typed languages. Statically typed languages require developers to be explicit with their data types. A variable cannot be declared without a type. After setting the type, the variable's type may never change for the lifetime of the program. In contrast, dynamically typed languages do not require developers to set the type. The programming language can automatically determine the type for you. Flexibility is another component of dynamically typed languages. We're allowed to change the type at any time. For example, initially, we may want to store a number in a variable. In the future, we have the option of storing a file in the same variable. This action will be acceptable under a dynamically typed language. So, where does PHP land? PHP is a dynamically typed language. Dynamically typed languages are considered to be beginner-friendly. It's one less step you must take to write an application. Unfortunately, there are downsides to dynamically typed languages. First and foremost, they can be slightly slower than statically typed languages. By shifting the responsibility of assigning a type to the programming language, languages must work harder to categorize your data. Secondly, you're not guaranteed a variable may remain the same type for the lifetime of a program. Suddenly, a variable can change from being a number to a string. Inconsistencies can cause a program to behave unexpectedly. Fortunately, PHP has grown to address the shortcomings of a dynamically typed language. As we progress through the course, we'll come across proper debugging techniques and best practices to avoid errors. First, let's start by exploring the data types available from PHP. In total, PHP has 9 data types. They're called null, Boolean, integer, float, string, array, object, callable, and resource. We're not going to be able to explore all data types, as some of them are for advanced use cases. Let's focus on the simpler data types. In the next set of lectures, let's try viewing the data type of a variable. In this lecture, we're going to start using functions. Functions are another commonly used feature of PHP. So, what is a function? Functions are a feature for performing a specific set of instructions. Hold on a moment. Isn't that the same as keywords? As we know, keywords are also used for giving the machine instructions to perform. So, what are the differences? There are actually a lot of differences, but for the sake of simplicity, I'm going to summarize it into one key difference. Keywords are considered to be a core feature of the PHP language. We can't disable or remove keywords from PHP. On the other hand, functions can be disabled from the language, but why would someone want to do that? PHP has a few questionable functions in its repertoire. There are developers who believe these functions should be cautiously used by the community. To prevent developers from accidentally using a dangerous function, it's advisable to disable them. Keywords can't be disabled, whereas functions can be disabled. We're not going to need to disable any function for this course. However, it is something you should be aware of when dealing with functions. In the resource section of this lecture, I provide a link to an official list of functions available from PHP. Almost immediately, you're going to notice another difference between keywords and functions. PHP has hundreds of functions, whereas there are only a handful of keywords. Scrolling through this page, you'll find a function for just about anything. You can perform actions from reading a file to encrypting data. I know it can feel overwhelming at first, but don't feel stressed about the enormous list of functions. It's highly unlikely you're ever going to need all of them. I myself haven't even used more than 20% of the functions listed on this page. So, what functions are we going to use? For starters, we're going to use a function called variable dump. Let's head over to our project. Inside the script, I'm going to replace the existing code with a function called variable dump. Functions are easy to write. A function can be executed by typing the name of the function followed by a pair of parentheses. But what are the parentheses for, you may ask? Well, we can pass on data to the function. The question is, what kind of data? That'll vary from function to function. The job of the variable dump function is to output a value onto the screen. It's very similar to the echo keyword. However, there's one critical difference. The variable dump function also outputs the data type of the value. For example, let's type 29 into the parentheses. This time, the page displays the value, but the data type as well. The variable dump function was introduced to help developers debug their programs. It can be useful to view the data type of your values. In the next set of lectures, we're going to start using this function to help us inspect the various data types offered by the PHP language. In this lecture, we're going to explore our first data type called null. The null data type represents nothing. If your variable does not store a value, it's considered to be null. Seems strange, but it's not uncommon to have variables that store nothing. In the real world, you may have a mailbox for storing your mail. However, your mailbox is not always full. From time to time, it'll be empty. Just because it's empty doesn't mean you should get rid of your mailbox. Eventually, you're going to receive mail. This same idea can apply to programming. For example, you may want to create a login form for users. It's common for login forms to require a user's email. This information would be stored in a variable. Initially, the form may not be filled in. Therefore, you may have a variable in your application without a value. Let's look at an example by creating a variable called data. I know what you're thinking. Didn't I say earlier that our variable names should be descriptive? That's correct. But for this example, the data variable is going to store various types of data. It's going to be a generic variable for experimenting with data types. After creating the variable, set the value to null. And that's it. We've created a variable that doesn't store anything. Let's replace the number inside the variable dump function with the data variable. After doing so, the value gets rendered on the screen. Now you may be thinking, why should we take the time to set the variable to null? If it doesn't contain a value, is there a point in defining one? The answer to that question is yes. Let me show you why. In our script, apply a comment to the data variable. There are two things worth noting about the output. Firstly, PHP throws a warning at us. The warning states the following: undefined variable data. Undefined warnings are one of the most common errors to receive in PHP. The interpreter is trying to tell us that we're trying to use a variable that doesn't exist in our program. Makes sense, right? PHP can't use a variable that hasn't been created in the first place. The second noteworthy thing is the text after the warning. The value null gets outputted. By default, if PHP can't find a variable, it'll fall back to null. Undefined variables are considered to be null. While it's great that undefined variables have a default value, the warning should be avoided. If we were to explicitly create the variable with an initial value of null, we can avoid the warning altogether. I'm going to uncomment the data variable. There's one more thing I want to mention about the null data type. The null keyword is case insensitive. Most developers prefer to use lowercase letters. From time to time, you may come across a different format that uses all uppercase letters like so. There isn't a difference between the spellings. Both formatting solutions result in the same thing. Personally, I prefer to use lowercase letters. Alright, that's about it for the null data type. In the next lecture, let's continue exploring other data types. In this lecture, we're going to explore another data type called Boolean. Booleans are a data type for storing truthy or falsy values. That may seem strange. Why would we want to use this data type? It can be useful for determining whether an action can be performed. For example, let's say visitors must be logged in to perform a purchase. If a visitor is not logged in, they will not be able to check out. Storing the user's currently authenticated status as a variable is a common task. Using the Boolean type for this scenario would be perfect. In fact, let's give that a try. In the script, define a variable below the data variable called isLoggedIn. Set the value to true. Boolean values can either be true or false. The names are case insensitive. Sometimes developers will use all uppercase letters. There isn't a difference in the formatting. It all boils down to personal preference. For this course, I'll be using lowercase letters. There's something worth pointing out about the name. The name of the variable is a question. For variables that store Boolean values, it's common practice to format the name of the variable in the form of a question. For example, let's say we were displaying a list of blog posts. If the user has not written any blog posts, we should display a message to inform them of the absence of blog posts. Storing this information as a variable would make sense. In this scenario, the variable could be called hasBlogPosts. Throughout the course, we'll try our best to follow this practice. It's not required, but recommended. You're going to see it all the time in your programming career. Let's update the value passed into the variable dump function to the isLoggedIn variable. In the preview, the data type is Boolean, or bool for short. Wrapped inside parentheses is the value. For demonstration purposes, I'll update the variable to false. As you can see, the value has been updated to reflect the new value. Booleans are one of the most memory-efficient data types. They're perfect for scenarios that require a yes or no answer. In the next lecture, let's start exploring data types for numbers. In this lecture, we're going to start exploring two data types for numbers, called integers and floats. Initially, that may seem strange. Why are there two data types for numbers? The reason has to do with memory efficiency. Storing numbers with decimal values requires additional work. They're not easy to store. Therefore, it's efficient to have a data type dedicated to whole numbers and another data type for numbers with decimal values. Most of the complexities are handled for you. It's not something you'll have to worry about. Regardless, it can be beneficial to know the differences. Let's start with integers. The integer data type was designed for storing whole numbers. In our script, let's set the data variable to a random whole number. Next, let's update the variable dump function to output the data variable. As you can see, the data type has been set to integer. PHP supports negative numbers too. For example, let's add the negative symbol before the number. Despite adding this symbol, the value continues to be an integer. What if we're dealing with large numbers? For example, I'm going to set the value to 5 million. If you're like me, you may have difficulty reading this number. Unfortunately, PHP does not support commas in our numbers. Instead of using commas, we can use underscore characters. Underscore characters can be inserted anywhere inside the number. It's common practice to insert these characters for every 3 numbers. I'm going to quickly add them in. These characters don't affect the number. PHP removes them during runtime. The purpose of these characters was to help with readability for large numbers. They're completely optional. If you can read large numbers without these characters, don't feel pressured to add them. After updating the script, the large number appears normally in the preview. PHP strips away the underscore characters from the numbers. We never have to worry about them affecting our program. Let's shift our focus to floats. A float is the data type for numbers with decimals. Similar to integers, floats support negative numbers and underscore characters for large numbers. Let's create our first float. Set the data variable to the following value, 123.45. You may be wondering, why is it called a float? The reason has to do with the placement of the decimal separator. The dot can be positioned anywhere in the number. We can position it at the beginning of the number. Alternatively, we can position it between the second and third numbers. You can think of it as a character that can float anywhere around the entirety of the number. If you think that's strange, I would agree with you. There's a joke among the community that programmers are terrible at naming things. It would have been simpler to use the word decimal as the name for the type. Regardless, it's been established that numbers with decimal values are considered to be floats. In the preview, the data type has been marked as a float. Perfect. Integers and floats are two data types for storing numbers. However, PHP is doing us a favor by optimizing the memory for our program. Numbers with decimals require more memory than numbers without decimal values. Overall, we benefit from this behavior. In the next lecture, let's continue exploring data types. In this lecture, we're going to explore another data type called strings. Strings are the data type for storing text. Sounds like a strange name. Why would developers call it a string? Text is a combination of multiple characters that are strung together, hence the name string. It's a weird naming convention, but that's what the community has settled on. Regardless, if you're working with text, the data type is considered to be a string. Let's try creating a string. For the data variable, let's replace the existing value with the following value, John. Text must be wrapped with quotes. Single quotes and double quotes are completely valid. In this example, I'm using single quotes. For demonstration purposes, I'll use double quotes for a different variable. Below, create another variable called last name with a value of Smith. This time, I'm using double quotes. Inside the quotes, we're allowed to write anything we'd like. Blog posts, product names, addresses, or anything represented as text can be stored in a string. It's important to note that code inside a string won't be executed. For example, inside the data variable's value, let's call the variable dump function. As you can see, the contents of the value do not get executed. PHP does not run the variable dump function from within the string. It's interpreted as plain text. If we shift our focus to the data type, it's been recognized as a string. Looking closely at the output, PHP has taken the time to count the number of characters from within the string. Overall, strings are simple to create. As long as you're wrapping text with quotes, you're good to go. The question is, what's the difference between single quotes and double quotes? Most developers prefer single quotes for readability. There's less clutter. However, double quotes offer one advantage over single quotes. PHP supports string interpolation. I know that looks like a scary, complicated word, but I promise it's not. String interpolation is the process of replacing a placeholder with a value. It's as simple as that. For example, let's say we had the following sentence. Hello, my name is X. The letter X is a placeholder. We can swap this placeholder with an actual value. String interpolation is a common feature you'll be using in your programs. This feature is only available with strings that are wrapped with double quotes. Inside the last name variable, let's inject the data variable by adding it at the beginning of the string. We're allowed to inject variables into a string. PHP replaces this portion of the string with the value stored in the data variable. Before testing our work, let's remove the variable dump function from the data variable. Next, update the variable dump function to output the last name variable. The entire name has been rendered in the preview. String interpolation is a simple yet handy feature. There's one thing I should mention. In some cases, you may want to append text immediately after a variable. For example, in the last name variable, I'll add the trademark symbol after the data variable. Adding this symbol produces an error. The reason is simple. PHP assumes that the trademark symbol is part of the variable name. It'll attempt to search for a variable with this name, which doesn't exist. So, how do we output the variable while keeping the symbol? We can wrap the variable with curly brackets like so. Curly brackets are optional. However, if they're added, PHP ignores text written outside of it. You don't have to worry about the curly brackets appearing within the string. PHP removes them during output. In the output, the full name gets outputted. Perfect. There's one more thing I want to show you before ending the lecture. So far, we've been rendering the entire string. In some cases, you may want to output a specific character. It turns out that PHP allows us to access specific characters from a string. In the variable dump function, let's add a pair of square brackets. If we're dealing with a string, we can access a specific character by adding these brackets. Within these brackets, we must add a number. Behind the scenes, PHP indexes our string. It'll assign a number to each character. The first character is assigned an index of 0. The second character is assigned an index of 1, so on and so forth. As an exercise, what number do you think is assigned to the fourth character? I'll give you a moment to think about this. The answer is 3. Let's try testing our theory. In the square brackets, type the number 3. Cool. As you can see, the fourth character gets outputted. It might seem strange. Programming languages commonly count at 0 instead of 1. It's a strange habit you'll have to get used to. Don't worry. As we progress through the course, counting from 0 will become natural. We're not limited to accessing a character. We can also update a specific character from a string. Above the variable dump function, let's set the last name 3 variable to X. Once again, I'm using the square bracket syntax. This time, we're directly updating this character. PHP won't update the entire string. The fourth character has been changed to X. There's one thing worth highlighting. We're updating the character before running the function. The order of our code does matter. PHP executes code from top to bottom. If we updated the character after calling the variable dump function, the function would output the original value of the string. Not taking the time to arrange your code can result in unexpected behavior. I think it's time for an exercise. In the next lecture, let's tackle an exercise to reinforce what we've learned about data types. Hey everyone! If you're watching this course on YouTube, you probably don't have access to the exercise tool on Udemy. If that's the case, you can check out the exercise for this lecture from the free ebook. Alternatively, I have another link with just the resources. The exercise for this lecture is called Exercise Data Type. Once again, check out the description for these links. Good luck. In this lecture, we're going to explore another data type called arrays. Arrays were designed for storing a collection of values. For example, let's say we were hired to develop a food tracking application. Users may want to store a list of their favorite foods. One solution would be to store the foods in a variable. In our script, let's create a variable called food1 with a value of salad. Afterward, I'll create another variable called food2 with a value of burger. I can continuously create variables for each of my favorite foods. However, this process can be cumbersome. Creating a unique variable for each food item is not scalable. What if we need to remove an item from our list? What if we need to add more foods or replace existing foods? Managing the variable names is tedious as the list grows. Arrays can simplify the process. PHP allows developers to store a list of values from within a single variable. Let's try creating an array by completely removing these variables except the data variable. Next, let's update the data variable's value to a pair of square brackets. Arrays are created with a pair of square brackets. Inside these brackets, we can start writing a list of values. Strings, booleans, integers, and floats can be inserted within an array. In addition, arrays are not constrained to a single data type. We can insert a number followed by a string. Let's add our list of favorite foods as strings. To separate each item in an array, we can use a comma. I've added 3 items to my array. Feel free to use different values. After adding our values, we can access a specific value using square brackets. Below the variable, update the variable dump function with the following value, data1. You're already familiar with the syntax. Items in arrays can be accessed via their index. Behind the scenes, PHP assigns a number to each item in our array. As mentioned before, PHP starts counting at 0. Therefore, the first item in the array has an index of 0. The second item has an index of 1, so on and so forth. In this example, we're accessing the second item from the array. As you can see, the second item has appeared as the output. What if we want to view the entire array? In that case, we can omit the square brackets from the variable dump function like so. This time, the entire array gets rendered. There are a few things worth mentioning. Firstly, the number of items in the array is rendered from within the parentheses. Secondly, the data types for the items in the array are presented. Lastly, the index of each item starts from 0 and increments by 1 for each item in the array. We're not limited to creating an array. Sometimes you may want to update items. Specific items can be updated through the square bracket syntax. Back in our script, let's update the second item in the array. Type the following with me, data1 equals chicken. Once again, we're accessing a specific item from an array. This time, we're updating the value that has been assigned an index of 1. Before testing our code, there's one more thing I want to show you. New items can be added to an array by writing a pair of empty square brackets. For demonstration purposes, let's add a new item to our array. By not accessing a specific index, PHP adds the value at the end of the array. Looking at the output, the new item has an index of 3. In addition, the array size has changed from 3 to 4. adding a new item to the array has increased its size. PHP was able to successfully add a new item to our array. Overall, arrays can be a powerful feature for storing a collection or list of data. If you think about it, most applications deal with lists. A list of users, posts, settings, and images are examples of data that can be stored in an array. Arrays have so much more to offer. In the next lecture, let's continue exploring other features of arrays. In this lecture, we're going to explore an optional feature of arrays called named keys. As we know, PHP assigns numbers to each item in an array. You can refer to these numbers as indexes. However, there's another name you can use, which is keys. Regardless of what you call it, we're not forced to use the number system. In some cases, we may want to add a name to describe the value in an array. Names are considered to be more memorable. In addition, they can be useful for better describing the data stored in an array. PHP supports this feature, which is referred to as an associative array. Associative arrays use names for keys instead of numbers. Let's look at an example. In our array, we're storing a list of food. What if we want to associate each food with a specific user? It could be presented as a user's favorite food. Before the first value, add the following: John equals greater than. A named key can be assigned by adding the double arrow operator. To the left of this operator, we can assign a name to our key. In this case, we're using the name John. To the right of this operator, we must specify the value to associate with the key. By adding a name, PHP does not add a numeric index to this value. Our array outputs the values, including the value with the named key. Looking closely, the key does not hold a number. Rather, it holds the name we assigned it during the variable declaration. It's completely optional to add named keys to all values. If we do not set a name for a key, PHP automatically defaults to a number. However, this practice is uncommon. Developers will often stick to numbers or named keys in a single array. It's better to be consistent. For that reason, let's update the array by adding names to each item in the array. You can use whatever names you'd like. I'll quickly update the array. In the array, the first 3 items have a name. There's just one problem. 2 additional items have been added. If we look back at our code, we're adding 2 items called chicken and tomato soup. Previously, we were updating the item with an index of 1. However, since we have an associative array, there isn't an item with this index. If a value doesn't exist at a specific index, PHP creates the index. That's not what we want. We should update the item in the array with the key called Jane. Luckily, that's easy. Inside the brackets, replace the number with the key name. This update should effectively update an existing item. Below this line of code, we're adding a new item to the array. Currently, we're not assigning a name. Therefore, PHP assigns a number. Let's add a name in the square brackets. After making those changes, all items in the array have names. We can reference a specific item in the array by a user's name. Associative arrays can be helpful when dealing with arrays that have limited data. Adding names can be a great way to describe the data stored at a specific index. In the following lecture, let's look at one more feature related to arrays. In this lecture, we're going to explore a feature called multidimensional arrays. Sounds like a complicated feature, but I promise it's not. A multidimensional array is when an array stores another array. Thus, you end up having a nested array structure. Nested arrays are very common in programming. Let's look at an example. In our array, each user has one favorite food. But what if they have multiple? It would make sense to use arrays instead of strings for storing this information. This way, users can have multiple favorite foods. For the first item in the array, let's wrap the string with square brackets. Voila! We have a multi-dimensional array. It's an array from within an array. There's no limit as to how many nested arrays can be created. This feature can be handy for creating a complex structure of data. I'm going to add a second item to the array. In the preview, our array has 4 items. The first item stores another array. The question is, what if we want to access a specific item from a nested array? That's simple. We can use square bracket syntax. Back in the variable dump function, add a pair of square brackets to access the item called John. Let's try accessing the second item in the array by adding an additional pair of square brackets. Inside these brackets, type the number 1. Look at that. The second item from the nested array has been outputted. That's exactly what we were looking for. What do you think would happen if we tried accessing a nested item from an array that doesn't exist? Let's find out. In the variable dump function, change the value from within the first pair of square brackets to Bob. Currently, we don't have an item in our array with a key called Bob. As expected, an error gets produced. Typically, one error would appear. This time, PHP is rendering 2 errors. Let's dissect them. The first error is an undefined error. Whenever you see the word undefined, it means that a variable does not exist. Your script is attempting to access a variable that hasn't been defined or is inaccessible. This error makes complete sense. In the variable dump function, we're attempting to access an item with a key called Bob, which doesn't exist. As for the second error, the description states the following: trying to access array offset on value of type null. The error states that we're trying to access an array. If we look at our code, we're trying to access the second item from an array called Bob. However, this array doesn't exist. If an array doesn't exist, square bracket syntax does not work. PHP states that we're trying to use an array that doesn't exist. Hopefully, that makes sense. It's a possible error you might encounter whenever working with multidimensional arrays. You can't access a nested array if an incorrect item from the list is selected. That wraps up multidimensional arrays. Actually, that wraps up our discussion on the various data types. There are other data types worth exploring, but we'll get to those in the future. For now, I think it's time we start shifting our focus to another subject. In the next lecture, let's start talking about typecasting. In this lecture, we're going to explore typecasting. From time to time, you may need to change the data type of an existing value. It's not uncommon to perform this type of action. PHP refers to this type of behavior as typecasting. Typecasting is the process of converting the data type of a value to a different data type. Overall, PHP makes it extremely simple to change data types. Typecasting can be performed by wrapping the new type with parentheses. Afterward, you must provide the value to change. In this example, I'm demonstrating typecasting on a single variable. It's cast into a Boolean, integer, float, string, and an array. While typecasting is powerful, the results can be unexpected. In the resource section of this lecture, I provide a link to a gist. If you're not familiar with GitHub, that's perfectly fine. GitHub is a resource for sharing code with others. In a future lecture, we're going to have an opportunity to learn more about GitHub. For now, all you need to know is that I'll be using it to share code with you. To prevent the lecture from becoming repetitive, I've decided to provide an entire example of typecasting of various types and values. Copy this entire piece of code to your clipboard. Next, switch over to our project. Inside the index.php file, replace the current contents of the file with the code in your clipboard. Be sure not to replace the opening PHP tags. Otherwise, this code would not work. Alright, let's take the time to understand what's going on. If we look through the code, we are repeatedly calling the variable dump function. The main difference is the value passed into the function. Various values are being typecast. Let's start from the top and work our way down. The first set of examples is non-Boolean values being casted into Boolean values. We can use the bool keyword to perform this operation. Alternatively, we can type Boolean. As an example, The second variable dump function uses the Boolean keyword instead of the bool keyword. I prefer to use the shorter version. Let's go through these examples one by one. Strings can be typecasted into Booleans. However, that doesn't mean all strings are converted to the same value. Empty strings are considered to be false. If the string contains text, the value becomes true. The exception to this rule is the third example, which is a string with the number 0. On the other hand, if the text says false, the value is casted into true. Moving on to integers and floats. Numbers are set to true when the number is not 0. This includes negative numbers too. If the number is 0, the value becomes false. Even though these examples are integers, the same rules apply to floats. Up next, null and empty arrays are considered to be false. On the other hand, if the array contains one or more items, the value becomes true. It doesn't matter what the contents of the array are. As long as the array has values, the array is converted into true. You can confirm these values in the preview. They should match the values written in the comments. If it's hard to read these values, feel free to add break lines into the output using HTML. Let's move on to typecasting values to integers. Just so that the preview doesn't get cluttered with a bunch of values, I've applied comments to the other examples. I'm going to comment the Boolean examples and uncomment the integer examples. Here's a cool trick to instantly apply or remove comments from multiple lines of code. If you were to select multiple lines of code and then press the keyboard shortcut Ctrl/, comments are toggled on the selected lines. For Mac users, this shortcut would be Command/. Alright, values can be typecasted to integers with the int keyword. Alternatively, you can use the integer keyword, which is shown in the second example. However, like the Boolean example, I prefer the shorter version. In the first few examples, Boolean values are casted into integers. A false Boolean is set to 0, whereas a true Boolean value is set to 1. If we're updating strings, PHP removes non-numeric characters from the string. For example, a string with the number -1 is set to -1. However, if our string doesn't contain numbers, the default value is 0. What if we have a combination of numbers or characters? Non-numeric characters are removed, leaving us with the number. If we convert a float to an integer, the decimal value is wholly removed. This is important to understand. PHP does not round the value. Numbers to the right of the dot character are removed. If we were to round this value, the result would be 13. However, if you look at the output, the value is 12. Understanding this behavior can be a small gotcha if you're not aware of it. Lastly, a null value is set to 0. Let's move on to the float examples. Similar to before, comment the integer examples and uncomment the float examples. Values can be typecasted to a float with the float keyword. Most of the conversions are similar to integers. If I'm being completely honest, there's nothing new to share. So, let's just move on to the next data type. Comment the float examples, and then uncomment the string examples. Typecasting to strings can be performed with the string keyword. Let's go through the examples. Firstly, a false value is set to an empty string. On the other hand, a true value is set to 1. Integers and floats are converted to strings without stripping numbers from the original value. Basically, PHP just wraps your numbers with quotes. Arrays are a special case. They can be converted, but PHP does throw a warning during this process. It's not able to completely convert an array to a string. All you'll get is the word array. Values inside the array are entirely removed. If you look at the preview, you'll be able to see how they're treated in our script. The word array appears, but a warning is accompanied with the value. Just be aware of this behavior when typecasting arrays. Lastly, a null value is converted into an empty string. That's about it for strings. Let's move on to the last set of examples. Comment the string examples and uncomment the array examples. A value can be typecasted into an array with the array keyword. Array typecasting is straightforward. The value is always inserted as the first item in the array. It doesn't matter if we're working with booleans, strings, integers, or floats. The one exception to this rule is null values. An empty array gets produced for null values. That's about it. You can look at the preview for the final results of typecasting these values. Understanding typecasting is essential. Believe it or not, PHP can automatically typecast your variables without your consent. In the following lecture, let's discuss this feature. In this lecture, we're going to look at a feature called type juggling. From time to time, you may hear this feature referred to as type coercion. They mean the same thing. So, what is type juggling, and why should you care about it? There are specific situations where PHP attempts to change the data type of your values without your explicit permission. Even if you're not performing typecasting, PHP may perform typecasting automatically. This behavior is known as type juggling. Believe it or not, we've experienced type juggling before. In the resource section of this course, I provide a link to the echo keyword documentation page. Under the description section, there's a code example of the echo keyword. I didn't mention this before, but you can wrap the value with a pair of parentheses. However, these characters are completely optional. Most developers prefer to skip them. The most important part of this example is the data type of the value. Looking closely, the value after the echo keyword should be a string. Isn't that strange? We've been able to pass in other values, such as integers and floats. So, why does PHP state we must pass in a string? Do you remember the discussion we had on data types? PHP is a dynamically typed language, which is considered to be beginner-friendly. One of the reasons is because of type juggling. If we pass in a value with the wrong data type, PHP attempts to rectify the situation on our behalf by typecasting the value. In this case, non-strings are typecasted into strings. Let's look at an example by heading over to our project. I'm going to remove all the code except the opening PHP tag. Next, I'm going to echo a random number. Despite echoing an integer, the preview displays the number perfectly without a problem. Once again, PHP is automatically typecasting the value, which is known as type juggling or type coercion. It's the same as writing echo string. At times, this feature can feel convenient. It means less code to write. On the other hand, it can cause unexpected results in your codebase. Throughout the course, I'll be sure to point out when type juggling can be a nuisance. For now, just be aware of this feature when working with data. In the next lecture, let's shift our focus to operators. In this lecture, we're going to explore arithmetic operators for numbers. In the resource section of this lecture, I provide a link to a documentation page on arithmetic operators. PHP supports basic mathematical operations. Addition, subtraction, multiplication, and division can be performed with PHP. This documentation page displays a complete list of operators for performing these operations. Let's give them a try by heading over to our project. I'm going to replace the echo statement with a variable called data. It'll hold the following value: 1 plus 2 minus 3 asterisk 4 slash 5. In this example, I'm using some of the arithmetic operators. The other operators will be introduced in a moment. Most of the operators are self-explanatory. The plus character performs addition. The minus character performs subtraction. The asterisk character performs multiplication. And lastly, the slash character performs division. Similar to math, the order of operations is applicable to our equation. PHP performs multiplication, followed by division, addition, and subtraction. The result will be stored in the variable. This is important to understand. PHP always executes mathematical operations before assigning a value to a variable. Take a moment to figure out the value that will be computed by this equation. Let's log the value with the variable dump function. As you can see, the data type has been set to float with a value of 0.6. The value is abnormal. Technically, the result should be 0.6. There shouldn't be a chain of zeros after the number. So, why are we receiving an abnormal value? First, let's revisit the concept of machine code. Machine code is a low-level language understood by machines. Everything is written with zeros and ones. As you can probably guess, machine code can be a nightmare to read and write. While it's possible to create applications with machine code, it would take a lot of work to create a simple app. For this reason, programming languages were introduced. Readability is the goal of most languages on the web. At the end of the day, our computers can't understand any programming language except machine code. It doesn't matter if you're using PHP, C++, or JavaScript. All programming languages cannot be understood by a machine. Converting a language to another language is known as compilation. Programming languages can use a compiler or interpreter to perform this process. In the case of PHP, an interpreter is used to perform this process. While there are differences between a compiler and an interpreter, those differences don't matter to us for the time being. The result is the same. Our PHP code is being compiled into machine code. After it's been compiled into machine code, our machines can execute the instructions written from our script. So, you may be wondering, why is this process important to know? Unfortunately, the compilation process is not perfect. PHP struggles with decimal values. Whenever working with decimal numbers, PHP tends to round your values incorrectly. In the resource section of this lecture, I provide a link to a site called Floating Point Guide. Issues with floating numbers are not specific to PHP. If you decide to switch to another language, you're likely to encounter this issue. This site is a helpful resource for developers to understand why floats are a problem. You don't have to read it. My explanation is more than enough to understand why this behavior occurs. However, if you're curious for more information, this resource can provide additional details. In the future, we're going to explore solutions for addressing these issues. For now, we'll leave the results alone. Back in our project, let's explore the other arithmetic operators. For the data variable, replace the value with the following equation: 11% 2. The percent character is known as the modulo operator. Sometimes, you may not be able to divide numbers perfectly. It's always possible that you may have a remainder. The modulo operator performs division, but it doesn't return the result. It returns the remainder. In this example, the remainder is 1, which is shown in the preview. It seems like a strange operator, but this operator is useful when trying to check if numbers are evenly divisible or detecting odd numbers. The last operator that I want to show you is the exponentiation operator. As the name suggests, it allows us to perform exponentiation with numbers. Let's replace the data variable's value once more with the following value: 10 asterisk asterisk 2. The exponentiation operator is performed with 2 asterisk characters. It's not to be confused with the multiplication operator, which is just 1 asterisk. The number on the left side of the operator is considered to be the base, whereas the number on the right is the exponent. If we look at the preview, we get 100. Perfect. There's one more thing I want to discuss before moving on. I'm going to revert the value of the data operator to the first equation we had at the beginning of the lecture. As we learned earlier, the order of operations is applied to our equation. We have the option of changing the order of operations by using parentheses. For example, let's wrap the middle numbers with a pair of parentheses. By doing so, PHP calculates the value from within the parentheses before executing the other portions of the equation. By adding these parentheses, a completely different result gets produced. You can fine-tune your equations with this simple syntax. As long as you know basic math operations, you shouldn't have a problem with them in PHP. In the next lecture, let's continue exploring other operators. In this lecture, we're going to continue our exploration of operators. In the resource section of this lecture, I provide a link to the documentation page for a complete list of assignment operators. Thus far, we've looked at a single assignment operator, which is written with the equals character. However, this is not the only assignment operator offered by PHP. Other assignment operators are available that can be thought of as shorthand syntax for common operations. Let's look at a few examples. In our project, let's assign the data variable to 10. As we know, arithmetic operators allow us to perform mathematical operations from within our script. It's not uncommon to update a variable's value throughout the script. For example, let's say the data variable stores the total cost of a user's purchase. If users remove or add items, the data variable should be updated to reflect those changes. After setting the data variable, let's update the variable to the following value, data plus 4. In this example, we're referencing the variable from within the value. PHP takes the current value and adds 4, resulting in 14. There's actually a shorter way of writing this line of code. PHP introduces variations of the assignment operator for each of the arithmetic operators. There's a shorter way of writing this equation by adding the addition operator to the left side of the assignment operator. After adding this operator, we can remove the data variable from the equation. The results are the same. By adding the addition operator to the left of the assignment operator, PHP takes the existing value of the data variable and adds the value to the operator's right. This feature applies to all arithmetic operators. We can use subtraction, multiplication, division, modulo, and finally, exponentiation. These assignment operators can help make your code look more readable. It's up to you if you want to use them. In the next lecture, let's keep exploring other operators offered by PHP. In this lecture, we're going to explore another set of operators called comparison operators. As the name implies, comparison operators are capable of comparing values. In the resource section of this lecture, I provide a link to a complete list of comparison operators. One thing to keep in mind is the results of the comparison operators. Arithmetic operators produced integers and floats, whereas comparison operators produce Boolean values. Under the results column, take notice of the data type. It's all Booleans. So, let's try using some of these operators. Inside our script, we're going to use the operators from within the variable dump function. We don't need the data variable anymore. PHP introduces two operators for comparing values. The first operator is written with two equals characters. This operator compares two values and returns a Boolean. For example, let's try comparing 1 with 1. It's important to note that we're using two equals characters. A common mistake among beginners is to use a single equals character, which, as we know, is the assignment operator. We don't want to assign a value, but compare two values. In the preview, the operator has produced a true Boolean value. Now there's something worth noting about the equal operator, which is what this operator is called. Behind the scenes, PHP may perform type juggling. As a reminder, type juggling is a feature where PHP performs typecasting automatically. If we attempt to compare two values with different data types, PHP performs typecasting before comparing them. For example, let's dump another value by adding a comma. The variable dump function is not limited to rendering a single value. Multiple values can be rendered by separating them with commas. For the second value, let's compare 1 with a string that contains 1. Technically, these are different values because of their data types. However, looking over the output, the value has been set to true. This result confirms the PHP's type juggling behavior. Otherwise, these values would not be comparable. While it may seem convenient, unexpected results may be produced. In most cases, developers prefer to compare values with the same data types. This produces the most reliable results. PHP allows us to compare values and data types by using three equals characters. Let's add an extra equals character to both values dumped into the output. This operator is more strict than the previous operator. The data types must match. Otherwise, a false value is evaluated. In the preview, the results are different. This time, the second Boolean value is false. Despite having similar values, the data types don't match. meaning that PHP considers them to be different values. I always recommend strictly comparing values. Trust me, you'll save yourself a headache. Type juggling in these scenarios is better left off avoided. Up next, we have operators for comparing values that don't match. In our examples, I'm going to replace the first equals character with an exclamation point character. These operators are referred to as the not equal and not identical operators, respectively. Unlike before, these operators attempt to check that the values don't match. If they don't match, the operator produces a true Boolean value. Otherwise, we'll get false. The main difference between them is that the not equal operator may perform type juggling, whereas the not identical operator does not perform type juggling. In the preview, the first comparison produces false because 1 and 1 completely match. However, the second comparison produces true since the values are different data types. One thing I want to mention is that there's an alternative syntax for the not equal operator. You can use the exclamation point equals characters or the less than greater than characters. There isn't a clear difference between these variations. However, the exclamation point equals characters are the most common combination. Let's keep going. Inside the variable dump function, we can compare values that are less than or greater than each other. Add the following values: 2 less than 3, 2 greater than 3, 2 less than equals 3, 2 greater than equals 3. The first two examples are self-explanatory. The less than character is used for checking if one value is less than another, whereas the greater than character is used for checking if one value is greater than another. But what about the other two operators? They're similar to the first two examples. However, they will also check if two values are equal to one another. In the third example, we're checking if 2 is less than or equal to 3. As long as the number on the left is less than or equal to 3, PHP produces a true Boolean value. The same idea applies to the fourth example, but with a greater than comparison. You can play around with these operators and check out the results to understand how they work. For now, that about does it for the comparison operators. Let's keep going in the next lecture. In this lecture, we're going to explore another operator for suppressing errors. Errors are a common occurrence in programming. You should always try your best to resolve an error. However, you may find yourself short on time. If that's the case, it's possible to suppress errors with the error control operator. Let's look at an example we're already familiar with. In the variable dump function, replace the value passed into the function with the following code: string, left bracket, 1, right bracket. In this example, we're typecasting an array to a string. PHP doesn't like this. As you can see from the preview, we get a warning from our code. Despite the warning, PHP has typecasted the array into the word array. If we're short on time, we may not have time to properly address this error. PHP gives us the option of suppressing the error by adding the @ character at the beginning of the line of code. If an error gets thrown, PHP ignores it. In this example, I'm converting an array into a string, which is not allowed. Typically, this line of code throws an error. Thanks to the error control operator, nothing will be output onto the screen. I really want to emphasize that you should use this operator sparingly. PHP has plenty of features to help you avoid errors in your code. This operator should almost never be necessary. Despite that, it may come in handy one day. In the next lecture, let's keep exploring other operators. In this lecture, we're going to learn about the increment and decrement operators. These operators were introduced for updating integers by 1. Let's look at an example to understand how they work. In our script, let's set the data variable to a random number like 5. In some cases, we may want to update this number by 1. For example, you may want to keep track of the items in a user's cart. If they add an item, you may want to update the cart's size by 1. A possible solution would be to do the following: data equals data plus 1. That works, but we can shorten this code even further by using the addition assignment operator like so. However, there's an even shorter solution, which is the increment operator. If your goal is to update a number by 1, you can do the following: data plus plus. The plus plus characters are known as the increment operator. It'll update a value by 1. Let's update the variable dump function to output the data variable. In the preview, the new value is 6. Numbers can be decremented too, which is subtracting the current value by 1. Instead of using the plus plus characters, they can be replaced with the minus minus characters. This time, the page displays 4. These operators are a useful shortcut. There's one thing to keep in mind when using these operators. The location of the operator does affect the behavior of the operator. If we add the operators after the value, PHP returns the value. After doing so, it'll increment the value. These steps are not performed together. You might want the value to be updated before it's returned. For example, we may want to increment the value while dumping it. In the preview, the value remains 5 despite incrementing it in our code. This is because PHP is passing on the value to the function before incrementing it. Therefore, the original value gets rendered on the screen. If we want to wait for the value to be incremented before outputting it, we can position the increment operator before the variable like so. Now the value has been incremented before being displayed. This same behavior applies to the decrement operator. Immediately using a variable after it's been updated is common. If the variable is not updated properly, you may want to consider moving it to the other side of the variable. So, that's the increment and decrement operators. Let's keep exploring other operators in the next lecture. In this lecture, we're going to start exploring logical operators. Comparing values is a common action within PHP. However, you may want to perform multiple comparisons. At the moment, we're limited to a single comparison. Logical operators were introduced to allow developers to perform multiple comparisons. In our script, let's say we wanted to limit our user base to users between the ages of 18 and 65. Above the data variable, define a variable called age with a value of 29. Notice how I said the word define. Sometimes, developers refer to the creation of a variable as a variable declaration. You may hear developers say, define a variable, or declare a variable. They all mean the same thing. Just thought you should be aware of that. Alright, moving along, let's set the data variable to the following: age greater than 18 and age less than 65. In addition, let's replace the operator from within the variable dump function. So, the AND operator allows us to add an additional comparison instead of one. This operator requires that both comparisons evaluate to true. If both comparisons are truthy, the value of the data variable becomes a Boolean true. Otherwise, the value becomes false. For example, let's set the age variable to 15. Technically, the age is under 65, but the age is not ever 18. Therefore, the data variable evaluates to false. There's another thing worth mentioning about the AND operator. The AND operator can be written with 2 ampersand characters or the word AND. Both solutions are viable. However, most developers prefer the ampersand variation. While the AND operator is great, you may want either condition to be true. For example, let's create a variable called permission with a value of admin. Restricting access to specific pages is a common practice. You may not want users to view the settings of a site unless they have administrative or moderation powers. It's unlikely that users are going to have both permissions, so we might just want to check for one of these permissions. For the data variable, let's use the following value: permission equals admin or permission equals mod. The OR operator can be written with the word or with 2 pipe characters. The pipe variation is more common and preferred. If one condition evaluates to true and the other condition evaluates to false, the entire value evaluates to true. Overall, the OR operator allows for either comparison to be truthy for the entire line of code to evaluate to a truthy value. There's one more logical operator variable called the NOT operator. Thus far, everything checks for a truthy value. What if you want to test for a false value instead of a true value? You can do so with the NOT operator, which is written with the exclamation point character. You can add this character to the beginning of the value. For example, let's use the following value for the data variable, not permission. Next, let's leave the permission variable as an empty string. By using the NOT operator, PHP transforms a value into a Boolean before checking the value. After doing so, PHP checks for a false value instead of a true value. If the value is false, the operator evaluates a true Boolean value. As you can see in the preview, the value of the data variable is true. Technically, empty strings are considered to be false, but by using the NOT operator, that'll allow us to check for a false value. That's it for logical operators. In the next lecture, we're going to continue our discussion of operators. In this lecture, we're going to start focusing on operator precedence. PHP offers dozens of operators. Best of all, we can use various operators together. However, that can potentially be an issue. If we're not careful, we may receive unexpected results. How does PHP know which operator to use over the other? In the resource section of this lecture, I provide a link to a documentation page called Operator Precedence. On this page, we're presented with a table of operators. Operators listed at the top of the table have higher precedence than operators listed lower on the table. If we have a value with multiple operators, PHP executes the operators according to their precedence. For example, the multiplication and division operators have higher priority than the addition and subtraction operators. In our script, let's clear the contents of the file. In its place, define a variable called a with the following value, 5 plus 2 asterisk 10. In this example, we have three operators, which are the assignment, addition, and multiplication operators. As we know, the multiplication operator has the higher precedence. Therefore, this part of the code is evaluated first. This is followed by the addition operator. If you were to look through the table, the assignment operator is listed at the bottom of the table. It's safe to conclude that the assignment operator gets executed last. Hopefully, things are making sense on how PHP deals with multiple operators. Let's take things a step further. What if we have operators with the same precedence? For example, let's replace the addition operator with the division operator. How does PHP handle these scenarios? It turns out PHP has an answer for us. Back at the table, there's a column called Associativity. If operators have the same precedence, PHP executes them in the order specified under this column. For instance, PHP executes these operators from left to right. Therefore, we can safely assume PHP starts with division. After division has been performed, multiplication is performed. In some cases, you may want the opposite to occur. What if we want multiplication to be performed first? In that case, we can wrap this portion of the value with parentheses. Parentheses give us the option to refine the order of operations for all operators. You should consider using parentheses when you aren't getting the desired results. On the other hand, not all operators support associativity. Let's head back to the table. According to the table, comparison operators do not have associativity. If a group of operators don't have associativity, this means they can't be used from within a single value. For example, let's head back to our code. Update the variable's value to the following: 5 less than 2 greater than 8. We can't use the greater than and less than operators within a single expression. PHP would throw an error at us. Keep this in mind when working with these operators. There's one last thing I want to mention about operator precedence. From time to time, PHP offers two operators for performing the same thing. For example, let's set the variable to the following: true and false. In this scenario, I'm using the ampersand characters for the AND operator. As we know, the alternative syntax for the AND operator is the word AND. Both operators allow us to write multiple conditions. However, there is a difference. The difference stems from the operator's precedence. After setting the variable, let's log the variable with the variable dump function. As expected, a false value gets evaluated. Both conditions must be true for a true value to be produced. Since the second value is false, we'll receive false. What do you think would happen if we switched operators? Let's find out. Change the operator to AND. This time, the variable has been set to true. Isn't that strange? Both operators perform the same logical operation. So, why does the variable have a different value? The answer can be found in the table. The AND operator has a lower precedence than the assignment operator. Since that's the case, PHP sets the variable to true before checking the second value. After the variable has been set, PHP throws away the second portion of the expression. This behavior can be a gotcha. To avoid this scenario from occurring, you can always use the original variation of the operator. This variation has a higher precedence than the assignment operator. In most cases, you should avoid the and, or keywords. You should use their other variations, since these operators have higher precedence, therefore guaranteed to run before a value is assigned. For the rest of this course, I'll use variations with higher precedence. In this lecture, we're going to explore another type of variable called a constant. Variables are flexible. We have the option of overriding the value of a variable after it's been declared. Let me give an example. First, I'm going to comment the code we've written thus far. It's starting to get cluttered. Now that our PHP file has been commented, let's define a new variable called full name. The value for this variable will be John Smith. After defining a variable, it can be updated to a different value. For example, let's update the variable to 100. After updating the variable, call the variable dump function with the full name variable. The value of the variable has been updated correctly. PHP makes it extremely easy to update variables. On the other hand, this behavior can be problematic. Variables can be accessed through multiple PHP files. At the moment, we're working on a singular PHP file. For larger projects, it's common practice to split your codebase into multiple files. That can lead to issues. Variables can be used across multiple files. What if you accidentally update a variable? An accidental update can lead to errors in other files. In some cases, you may want your variables to contain the same value throughout the lifetime of a program. PHP has a feature for creating a variable that can't have its value changed, called a constant. If we were to attempt to update a constant after it's been created, an error would get thrown. Constants are treated as read-only. Let's try creating a constant. Below the full name variable, add a keyword called const. Using the const keyword instructs PHP to create a constant. After the const keyword, we must provide a name for our variable. Unlike before, we do not need to start the variable name with the $ character. The other rules for creating a variable still apply. We can use alphanumeric and underscore characters. Special characters are not allowed. Lastly, we can't use reserved keywords. For example, we can't set the name to const. By typing this keyword, we're given an error. PHP assumes that we're trying to create a constant while attempting to create a constant. This code leaves the language confused. Let's set the name to full name. The name of the variable uses all uppercase letters. This step is completely optional. We could have used camel casing, Pascal casing, or snake casing. However, constants behave differently than regular variables. For this reason, developers like to use all uppercase letters for constants. It helps other developers identify the variable as a constant. More often than not, this naming convention is widely adopted by the community. This includes the PHP language. In the resource section of this lecture, I provide a link to PHP's official list of predefined constants. You should avoid using the same names listed on this page. Otherwise, you may get an error stating that you're attempting to update an existing constant. Luckily, most of PHP's constants start with the word PHP. As long as you avoid starting your constant name with this word, you're good to go. Let's head back to our editors. We're going to be using all uppercase letters for our constant names. Once again, not required, but recommended. Let's set the value of this constant to John Smith. Next, we can output the variable by updating the variable dump function to use the constant. To read a value from a constant, we can type its name as is. We do not need to include the $sign character. The value of the constant has been outputted. As stated before, we cannot change the value after it's been declared. For example, I'm going to try updating the full name constant to a different name. An error gets outputted from the program. According to PHP, the full name constant has already been created. We're not allowed to update its value. This is the benefit of using a constant. We're restricted to the same value for the rest of the program. If we attempt to update it, our program will stop working. PHP will always notify us when a constant is already defined. We'll be using constants to help us secure our script. Once we start working on a real project, you'll find out why they can be incredibly useful. In the next lecture, let's keep exploring more PHP features. In this lecture, we're going to look at an alternative solution to injecting variables into strings called String Concatenation. As we learned from a previous lecture, string interpolation can be a great solution to inserting a variable into a string. However, string interpolation is only available for regular variables. Constants are not supported in string interpolation. What if we need to insert a constant into a string? There's an alternative solution called String Concatenation. In our script, we have two constants called full name. Let's remove the second copy. Next, let's add the following string inside the variable dump function. Hello, my name is. At the end of this string, we may want to insert the full name constant. A constant can be added using string concatenation. String concatenation is the process of combining two strings into a single string. We can perform string concatenation with the concatenation operator. This operator can be written with the dot character. After the string, add this character. PHP will combine both strings into a single string. The output contains both strings. However, there's one problem. Space does not separate both strings, which makes the sentence look awkward. This behavior makes sense when you think about it. In the first string, we don't have a space at the end of the string. The constant does not contain a space at the beginning of the string. If we were to add a space at the end of the first string, this update should resolve our errors. As you can see, the space has been added. It's a common mistake to forget to add spaces when concatenating things. String concatenation and string interpolation are powerful features for inserting variables into a string. Whenever possible, I prefer to use string interpolation. In my opinion, it's easier to read. If I'm dealing with constants, I'll use concatenation since interpolation does not support constants. You may prefer concatenation because it can support strings with single or double quotes. Other than that, it all comes down to preference. Just like arithmetic operators, the concatenation operator can be used with the assignment operator. For example, let's outsource the first portion of the string to a variable called message. Next, let's type the following after defining the variable. Message dot equals full name. Similar to arithmetic operators, we can add the concatenation operator to the left of the assignment operator. PHP will add the string to the existing string. This results in the same thing as before. Let's update the variable dump function to output the message variable. Perfect. Our message works like before. The concatenation assignment operator can be useful when you're trying to add to an existing string. That is about it for this section. We've spent a lot of time talking about variables and data types. Data is an essential component of any application you're building. But how can we use this data to create dynamic pages? That's going to be the focus of the next section. When you're ready, I'll see you there. In this lecture, we're going to quickly discuss an important word called expressions. Programming can be challenging to grasp because of the terminology. Learning the terminology of a language is half the battle. If you're able to understand the lingo used by developers, you're well on your way to learning a new language. The word expression is going to come up a lot throughout the course. So, what are expressions? An expression is a line of code that evaluates to a value. It's as simple as that. Believe it or not, we've been writing expressions for most of this course. For example, when we create a variable, PHP doesn't immediately assign the value to the variable. Before it does, it'll attempt to evaluate the value on the right of the assignment operator. In this example, this process happens immediately because the value is ready as is. The number 5 evaluates to 5. After the expression has been evaluated, the value is assigned to the variable. The same behavior occurs for mathematical operations. In this example, PHP doesn't immediately assign a value to the variable. It'll notice that we're performing addition. This expression gets evaluated before anything else happens. After a value has been produced, the value gets assigned to the variable. Now, you may be thinking, what would be the difference between operators and expressions? They have similar definitions. Both terms are used to describe operations that produce a value. Well, an operator refers to characters or symbols that perform an operation. As we know, we can have multiple operators from a single line of code. In comparison, expressions refer to the entire line of code that produces a value. This includes the operators. This behavior is important to understand. A lot of code is going to contain expressions. Anytime you write code that produces a value, you've written an expression. In the resource section of this lecture, I provide a link to the echo keyword. Previously, we talked about the data type of the value expected by this keyword. Now, I want to shift our focus to the name of the variable. Do you notice anything? The variable is referred to as an expression. PHP's documentation heavily uses the word expression, which makes sense, right? After all, PHP expects some kind of value to be written after the echo keyword. We have the freedom to calculate a value after the echo keyword. Therefore, the code written after the echo keyword can be considered an expression. Whenever you see the word expression in the documentation, just know that PHP is saying that you can write code that produces a value. In the next lecture, let's start using this knowledge to help us learn new features of PHP. In this lecture, we're going to learn how to control the flow of a program. Thus far, every line of code we've written has been executed. We don't have control over the flow of logic in our program. What if we want to execute code when a condition is true? For example, specific pages should be locked unless a user is logged in. Another example would be displaying administration features for users with specific privileges. There are hundreds of use cases for performing logic based on a condition. Luckily, PHP provides a solution for controlling the flow of logic called conditional statements. In the resource section of this lecture, I provide a link to the if keyword. This feature allows us to perform logic based on a condition. Let's read the documentation together. In the second paragraph, the following is stated. As described in the section about expressions, expression is evaluated to its Boolean value. If expression evaluates to true, PHP will execute statement, and if it evaluates to false, it'll ignore it. As we learned, expressions are lines of code that evaluate to a value. The if keyword expects a Boolean value. This is important to understand. PHP does not use integers, floats, or strings. Booleans are used to determine whether a block of code is executed. In a nutshell, PHP performs type juggling on expressions that aren't Booleans to convert the value into a Boolean. Let's dive into the code to understand this feature. Switch over to our project. In the PHP file, I'm going to remove the existing code. As always, be sure to leave the opening PHP tag intact. Next, imagine a scenario of an application that displays a student's grade based on their score. In the file, define a variable called score with an initial value of 95. In America, the grading system can contain values between 0 and 100. 100 is considered passing. 0 is considered failing. Our goal is to inform the student that they've passed or failed based on their score. After the variable, add the if keyword. Adding this keyword instructs our program to check a condition. The condition can be written by adding a pair of parentheses. Within these parentheses, we must provide an expression that evaluates to a Boolean value. Let's pass in the score variable. The score variable has the integer data type. Regardless, this is considered a valid expression for the if statement. The reason is simple. Behind the scenes, PHP performs type juggling for values passed into the condition. As we know, integers are converted into true if the number is not 0. Since 95 is not 0, the expression evaluates to true. If the expression evaluates to true, PHP executes a block of code. The block of code can be written inside a pair of curly brackets. Let's add these characters after the parentheses. Inside the brackets, call the variable dump function with the following value, a. As a side note, the code inside the conditional statement is indented. This formatting is not required but recommended. It adds clarity that this section of code belongs to the conditional statement. It's a common practice adopted by developers. We'll be following it too. To recap, if the expression evaluates to true, the letter A should appear. In the preview, the letter has been dumped. While that's great, it's not exactly what we were aiming for. The same grade gets outputted regardless of the number. For example, let's set the score to 1. An appropriate letter grade for this score would be an F. As it stands, the same letter grade appears on the page. By itself, using the score as the condition produces undesirable results. Luckily, we know how to resolve this issue. We can use comparison operators. They're perfect for our scenario. Instead of using the score, we're going to compare the score with a specific number. If the score lands above a threshold, the appropriate letter grade should appear. PHP offers various comparison operators. Best of all comparison operators produce a Boolean value, which is what the if keyword expects. In the conditional statement, update the expression to the following, score greater than 90. Let's look at the preview. This time, nothing appears. It's because the condition was evaluated to false. If the if statement receives a false value, the block of code nested inside is not executed. But what if we want to output an alternative message? After the closing curly bracket, we can add an else block. The else keyword is optional. If it's added, PHP will execute code inside the else block when the condition from the if block fails. There is one rule we must follow. The else block must be added at the end of the if condition. If we were to attempt to write code between these keywords, PHP would throw an error. Inside the else block, let's call the variable dump function with the following value, f. We can take this solution further by adding an else if statement. In between these blocks of code, add the else if keyword. So far, we have one condition. In some cases, we may want to write multiple conditions. PHP allows developers to chain multiple conditions with the else if keyword. Unlike the if and else keywords, we can repeat the else if keyword as many times as we'd like. However, we may only write this keyword after an if statement and before an else statement. Inside the parentheses, we can write a condition. Let's write the following condition, score greater than 80. Inside the block of code, call the variable dump function with the following value, b. Just for fun, let's add another else if statement. This time, the condition will be score greater than 70. Lastly, let's output the letter C with the variable dump function. Believe it or not, there are variations of the else if keyword. It's completely optional to add a space between the words else and if. I'll remove the space as a demonstration. For most projects, you should stick with consistent formatting instead of mixing and matching keywords. Let's check out our preview. As you can see, the letter F has appeared. That's to be expected since the score is too low for each condition. PHP defaults to the code from the else block, which doesn't require a condition. Let's try updating the score to 95. Unlike before, the letter A has been outputted. But what about the letters B and C? PHP always starts from the top. If the first condition fails, it'll move on to the next condition. It'll continue this process in the order the conditions are written. Once it finds a condition that evaluates to true, it will not bother checking other conditions. Technically, the other conditions evaluate to true. However, since the first condition evaluates to true, the other conditional blocks of code are never executed, hence why we're getting a single letter. Conditional statements are extremely powerful. They allow us to control the logic flow by executing code based on a condition. There's one more thing I want to mention before moving on. Unlike before, we're not adding the semicolon character at the end of each block of code. If we're ever using curly brackets for blocks of code, the semicolon character is not required. Using the closing curly bracket will suffice. Just thought you should know in case you notice that we're omitting the semicolon. In the next lecture, let's continue exploring other features for controlling logic flow. In this lecture, we're going to look at an alternative solution for controlling logic flow. Switch statements are another feature of PHP for performing a condition. There are a few differences, so let's get into them. In the PHP file, let's clear the contents. Next, add the switch keyword with a pair of parentheses. The biggest difference between if statements and switch statements are the condition. Conditions for if statements are flexible. We can compare values any way we'd like. For example, we can check if one value is greater than another. Alternatively, we can check for things like the length of a string or if the user is logged in. On the other hand, switch statements compare values for equality. If two values match, a portion of the code will be executed. Let's look at an example. Above the switch keyword, create a variable called payment status with a value of 1. It's common for developers to use numbers to represent the status of an action. In this example, we may want to store a user's payment status. The problem with this value is that numbers aren't descriptive. We wouldn't output a number to the user. Instead, we may want to output a friendlier message. This is the perfect case for a switch statement. Inside the parentheses, add the payment status variable. The switch statement accepts a value. The value does not need to be a Boolean. It can be an integer, float, or string. Next, inside a pair of curly brackets, we must add a keyword called case. After the case keyword, we must add a value to compare it with a value from the switch statements. Let's add 1. Afterward, we can add a colon character. Code written after this character will be executed whenever the value from this case matches the value passed into the switch statement. Let's call the variable dump function with the following value, success. If the values match, this means the payment was a success. Let's add another case. This time, we'll compare the variable with the number 2. If the values match, we'll call the variable dump function with the following value, pending. You'll notice I'm indenting the code. This is not necessary but recommended. It helps with readability. Indenting your code helps associate lines of code with a specific case. What if the variable doesn't match our cases? We can add a default case by adding the default keyword. Similar to before, we can add a colon character after this keyword. Any code written after this character will be executed when the other cases fail. Let's output the following message: unknown. To recap, switch statements attempt to compare values for equality. It doesn't try to compare values that are less than or greater than each other. Within the switch statement, we must provide a value to match within its various cases. We can add as many case statements as we'd like. If a match can't be found, the default case is executed. Here's where things become slightly bizarre. All messages from our cases have been executed. But why? Whenever PHP comes across a match with a case, it'll execute all lines of code written after it. This includes lines of code written after the case. PHP refers to this feature as a fall-through strategy. We're responsible for instructing PHP to start running code. This process can be interrupted by adding a keyword called break. After each variable dump function, add this keyword. We don't have to add the break keyword to the default case. It's redundant to add it in, since it's the end of the switch statement. After adding this keyword, things are different. Only the success message appears. I know this might seem strange, but there's a good reason for this behavior. Currently, we're limited to matching a single value with the expression from the switch statement. What if we want multiple values to trigger a block of code? That's completely possible thanks to the fall-through strategy implemented in switch statements. For example, after the second case, add another case for the number 3. Next, let's update the payment status variable to 2. As you can see, the payment was denied. Under the second case, there isn't any code to execute. However, we're not breaking the case either. PHP continues to fall through the next line of code. By not doing so, the message from the third case gets executed. This behavior allows us to add multiple cases to produce the same outcome, which may come in handy. In my opinion, I prefer to use if statements. It's completely possible to compare two values. However, from time to time, you may come across switch statements. It's good to know how they work. Before moving on, there's one more thing I want to mention. The types don't have to match. For example, I'll wrap the variable's value with a pair of quotes to create a string. Believe it or not, our code will work as before. The same message gets outputted. PHP performs type juggling before comparing values. The values do not have to be the same type. As long as they loosely match, the case will pass. That's something you should know when working with switch statements. If you require strict comparisons, you might want to consider using if statements. It isn't possible with switch statements. In the next lecture, let's look at one more feature of performing conditions. In this lecture, we're going to explore a feature of PHP called match expressions. This feature is relatively new with version 8 of PHP. If you're on an older version of PHP, this feature will not be available to you. So, what are match expressions? A match expression is similar to a switch statement. It's a feature that compares two values. The main difference is that the match keyword is treated as an expression. Let me give an example. In our script, we added a switch statement. Let's wrap the switch statement with the variable dump function. Almost immediately, an error gets thrown by PHP. According to the error, the switch statement is unexpected. This is because the switch statement is not an expression. A value does not get produced by switch statements. Understanding this behavior is crucial. Not all lines of code produce values. Technically, the switch statement can contain expressions, but the switch statement itself is not an expression. The variable dump function wants an expression. Otherwise, it won't be able to output the value into the page. Let's switch the keywords from switch to match. Unlike the switch statement, a match expression produces a value. Match expressions can be written with the match keyword. Inside the parentheses, we may provide a value to compare with the values written inside the curly brackets. I'm fine sticking with the payment status variable. I'll leave it as is. Inside the match expression, The syntax for adding a list of values is slightly different. We don't have to use the case keyword. Match expressions use a similar syntax to associative arrays. For example, we can write the following: 1 equals greater than success. The value on the left is the value to compare with the value passed into the match expression. If the values match, the value on the right is returned as the result of the expression. Multiple values can be added by separating them with commas. Let's add the number 2 with the following result: denied. Before we test our work, I think it would be a good idea to extract the expression. It may be difficult to read. Values produced by match expressions can be stored in a variable. After all, it's an expression. I'm going to extract the expression to a variable called message. Next, I'll pass this variable on to the variable dump function. After running the script, we were given an error. Let's dissect the error to understand the problem. The error states the following: uncaught, unhandled match error, unhandled match case. Match expressions must always produce a value. If we look at our logic, the value stored in the variable is a string. However, the values in the expressions are integers. Unlike switch statements, PHP does not perform type juggling on any of the values. Comparisons are strict. This means that the values must match and have matching data types. With that in mind, it makes sense why we're getting an error. PHP can't find a match. In these cases, we must provide a default value. In the expression, add the default keyword with the following value: unknown. This time, the error goes away. Instead, we're given the default value. That makes sense since the data types don't match. Let's remove the quotes from the variable's value. After doing so, let's run the script. Our payment has been denied. Match expressions can be easier to read than switch and if statements. However, you may not like match expressions. Here's an example of the same result, but with an if statement. In programming, there isn't always one solution for producing the desired results. Different solutions can be used to tackle the same problem. Some developers may not like match expressions. In that case, you can stick to if statements. Throughout this course, there will be examples of how to use features in practical scenarios. For now, let's keep moving on with our PHP journey. In the next lecture, let's move on to functions. In this lecture, we're going to start writing reusable code by using functions. So far, we've been using the variable dump function to output data into the page. It's a function defined by the PHP language. PHP has dozens of functions. However, we're not limited to PHP's functions. Custom functions can be defined by us. Let's look at an example. In our script, we've written a chunk of code to generate the status of a payment based on a number. This solution works, but it could be improved further. We may want to generate the payment status for various places in an application. For example, we may want to output this information on a dashboard. If the buyer wants an invoice, this information could be rendered in a PDF file. Lastly, we may want to display this information after a buyer submits payment information. In total, we have 3 different locations where this information could appear. As it stands, we would have to copy and paste this code for the information to be displayed. It would be convenient if we could write the code once and use it anywhere. That's the purpose of a function. Functions allow us to write logic once. This logic can be repeatedly executed anywhere in our code base. Let's try defining a custom function. The goal of this function will be to provide the status of a payment. Above the current code, write the following: function getStatus. Custom functions can be written by typing the function keyword. This keyword is followed by the name of the function. Function names follow the same rules as variable names. Unlike variable names, we don't have to start the name with a $ character. It's common practice to use camel casing for function names. After the name, we can add a pair of parentheses and curly brackets. We're going to ignore the parentheses. It's something we'll circle back to. Inside the curly brackets, we can write the body of the function. Let's move our logic into the function. similar to before. We're indenting the code for readability. This is always true for code written in curly brackets. Next, we must invoke the function. Invoking a function is another way of saying running the code from within the body of a function. By default, PHP does not execute code inside a function. We must explicitly invoke the code. Oftentimes, you may hear developers say call a function or run a function. It means the same thing. A function can be called by typing the name of the function followed by a pair of parentheses. Let's call the getStatus function after defining it. After making those changes, the same output has been rendered. That's perfect. We've successfully defined a custom function. This function can be called an unlimited number of times. There are a few things worth mentioning. Firstly, the function can be defined anywhere. At the moment, we've defined the function first and called it afterward. In this instance, the order does not matter. We can move the function definition below the invocation like so. The same result occurs. As long as the function is defined without interference, our code should work. So, what do I mean by interference? Let's wrap our function with an if statement. For the condition, use the following value, true. As you might guess, the code inside the conditional statement will always execute. However, that doesn't mean the function is immediately available like before. An undefined error gets produced from our script. Functions inside conditional statements are not immediately available. The conditional statement must execute before the function is defined. However, we can move the conditional statement above the invocation to make the code work. If we run the script again, things should work. Everything is back to normal. This can be a gotcha with PHP. I always recommend defining your functions before executing additional logic. By doing so, your functions should be readily available. It's a common practice among developers. I'm going to remove the conditional statement wrapped around the function. There's one last thing I want to mention. Functions cannot be defined twice. They're like constants. If we attempt to define a function twice, PHP will complain. That's something to be aware of. In the next lecture, let's keep exploring additional features of functions. In this lecture, we're going to improve our function by using parameters. Let's take a moment to understand our function. While our solution works, it can be improved. The biggest issue with our function is the message. No matter how many times the function is called, the same message appears on the page. Our function should be flexible. This is possible with a feature called parameters. A parameter is a variable that can be updated outside the function. Customizing the variables in a function adds flexibility. Inside our function, remove the payment status variable. Next, inside the parentheses of the function, add a variable called payment status. Parameters can be added inside the function's parentheses. Unlike variables, values do not need to be assigned. After adding this parameter, our script will break. In the preview, the error states that there are too few arguments. It's not the responsibility of the function to assign a value to the payment status parameter. Instead, the value must be provided when the function is called. This is why we're getting an error. We're not providing a value. A value can be sent to the function by writing it in parentheses. Let's pass in 1. This value will be the value of the payment status variable. Let's try testing our code by running the script. Everything is functioning as before. By using parameters, we can avoid hard coding a value into the function. Functions can be fed data to alter the output. We're not limited to a single parameter. Multiple parameters can be added by separating them with a comma. For example, let's add a parameter called showMessage. Let's use this parameter to toggle the variable dump function. We may not always want to output the payment status into the console. Wrap the function with an if statement. The condition will be the showMessage parameter. Next, in the invocation of the getStatus message, let's pass in true. The values passed into the function must correspond with the parameter list. The number will be assigned to the payment status parameter. The Boolean will be assigned to the show message parameter. If we reverse these values, the values for the parameters will change. The order does matter. In some cases, you may want to assign default values to your parameters. What if we had 5 parameters? Constantly passing in 5 values to a function can be annoying. It's optional to add default values for a parameter. We can do so from the parameter list. Let's set the show message parameter to true. Next, we can remove the true value from the invocation. PHP won't throw an error. If we don't pass on a value for a specific parameter, PHP checks the parameter for a default value. If there is a default value, it'll be used. Values passed into a function will override the default value of a parameter. We're getting the same output as before. That's awesome. There's one last thing I want to mention before moving on. In the programming world, you're going to hear 2 words called parameters and arguments. Oftentimes, developers use these words interchangeably, but there's a difference. A parameter refers to the variable in the function's parameter list, whereas an argument refers to the value of the parameter. In our case, the payment status and show message variables are parameters. No one's going to yell at you for using the wrong term. However, it's always good to know the difference. Throughout the course, you'll see me using both terms to describe a function's parameters. In the next lecture, let's continue improving our function by exploring return values. In this lecture, we're going to expose data from a function to the outside world. The getStatus function takes in a value. Based on this value, it'll produce a readable message for the payment status. This information is not available outside of the function. Exposing information outside of a function is a common practice for developers. What if we want to change the language of the text? Alternatively, we may want to change the formatting by wrapping the text with HTML tags. Not all pages may render text the same. For the most flexibility, we should expose the payment status to outside sources. This behavior is possible by returning the value. At the bottom of the function, add the return keyword followed by the message variable. By returning a value from the function, a few things happen. Firstly, the code inside the function stops executing. If we were to continue writing code after the return statement, nothing would happen. PHP won't execute the code written after this statement. This is why we've written the statement at the end of the function. Now the question is, how do we access this information? Returning a value from a function can be stored when it's called. Below our function, we're invoking the getStatus function. By returning a value, we can store this information in a variable. Let's set a variable called statusMessage to the function's return value. Next, call the variable dump function with the statusMessage variable. The message gets rendered twice, once from inside the function and another time from outside the function. Returning data is optional, but it can be useful to use data from a function after it's been executed. Not all functions need to return data. It's completely optional. The variable dump function is an example of a function that doesn't return data. Overall, functions are a powerful feature for reusing logic. In a few lectures, we've created a function that can convert a status from a number to a human-readable message. It's very flexible and gives us the power to customize its behavior. Functions have so much more to offer. For the next set of lectures, we're going to explore these features. I'll see you in the next one. In this lecture, we're going to apply type hinting to our function. At the moment, our function returns a string. PHP gives us the flexibility to return any type of value. It doesn't know the return type of our functions. It guesses the type during runtime. It's entirely possible to inform PHP of the return type of our function. There are many benefits to doing so. The main advantage is debugging an application. We've talked about this before. PHP is a dynamically typed language. It's capable of changing the data type of a variable at a moment's notice. We do not need to set the types of our variables. While convenient, that doesn't mean there aren't drawbacks. It's possible to use the wrong data type for a specific situation. Rather than deal with the headaches of a dynamically typed language, we can enforce types. By doing so, if we attempt to use a type incompatible with our code, we can be informed of the problem before testing our code. It's an incredibly valuable feature that'll save us hours of debugging. Return types can be enforced by adding a colon character after the parentheses. After this character, we can specify a type. Let's use the string type. Adding this type can help PHP understand the type of value returned by the function. In some cases, we may not always return a type. For example, in our function, we're conditionally dumping the message. I don't think we should return the message from the function if the showMessage parameter is set to true. At the end of the conditional statement, let's return null. As you can imagine, returning a value causes the message to never be returned. This will only occur if the showMessage parameter is true. Returning a null will break our function. It's because we're returning null instead of a string. If we didn't have type hinting in our function, everything would be fine. In these cases, we can update our function by adding a question mark character before the return type. Adding this character allows a null value to be returned by the function. Thus, our function can return a string or null. In some cases, your function may not return anything at all. It's optional to return a value. If your function doesn't return a value, you can set the return type to void. The void data type is a special data type for functions. It was introduced for functions that never return data. In our case, we don't need this type. Regardless, it's good to know. Type hinting is not just available for return types. We can add type hinting to parameters. For example, let's add the integer type to the payment status parameter. Types must be added before the parameter name. Let's add the Boolean type to the second parameter. We're not limited to a single type. PHP supports union types. Unions types are for variables that support different data types. For example, the status variable accepts a number. What if we want to accept the float data type? It's not uncommon to support integers and floats. An additional type can be supported by adding the pipe character followed by the new type. Let's add the float type. We can add as many types as we'd like. Alternatively, you can use a type called mixed. You may have parameters that accept all data types. Rather than listing each possible data type, you can use the mixed data type as a shortcut. This data type was designed to accept all data types for a parameter. For our function, it's not necessary. I'll revert it to the previous union type. Type hinting is the power to explicitly set the data type of our parameters and return values. Enforcing data types reduces the likelihood of errors. However, we're not fully benefiting from type hinting. In the next lecture, let's discuss why this is the case. In this lecture, we're going to enable strict typing for our files. At the moment, our function has type hinting. However, type hinting isn't enforced. For example, I'm going to update the argument passed into the getStatus function by wrapping it with quotes. After doing so, nothing happens. In the preview, everything is perfectly functional. Things become more bizarre when we look at the results. As we know, match expressions compare values based on the value and data type. In our expression, we're using integers, but we're passing in a string. Regardless, it was able to find a match. This behavior occurs because PHP is performing type juggling. By adding type hinting, PHP casts the argument into the correct type before the block of code is executed. Therefore, our parameter is going to have the correct type. That's not exactly what we want. We shouldn't be passing in the wrong data type to begin with. A better approach would be to receive an error from PHP. This way, we can adjust the data type. Type juggling would be skipped entirely. PHP is more than capable of detecting types. However, this feature is not enabled. We must manually enable it from the top of the file. At the top of the file, add the following: declare strict types equals 1. The declare keyword allows us to configure PHP's behavior. In this example, we're enabling the strict types option by setting it to 1. After enabling this feature, the page throws an error. If I look at the error states I'm using the string type when the function accepts a value with the integer or float type. PHP is not allowing our script to execute normally. Enabling strict mode prevents our script from passing in a value with the wrong data type. If we were to remove the quotes, the error should go away. By enabling strict mode, we're guaranteed to always be working with the correct data type. Weakly typed languages can introduce unintended behavior in your application. These types of bugs can be hard to fix. I always recommend enabling strict typing to avoid bugs. There is a catch. The declare statement is only applicable to the current file. If we had another PHP file, we must add the same statement to the file. Otherwise, strict mode won't be enabled. It can be annoying to type the same line of code, but it is worth the effort. In the next lecture, let's continue our PHP journey. In this lecture, we're going to discuss a small gotcha with logical operators. I know this might seem strange because we spent a lot of time talking about operators from the previous section. However, we couldn't discuss this feature until we talked about functions. Let's circle back to operators just for this lecture. PHP is lazy when it comes to conditional expressions. Believe it or not, it's completely possible for PHP to skip an expression when evaluating conditions with logical operators. Let me show you what I mean. In the PHP file, clear the contents of the file. Next, we're going to call the variable dump function with the following expression, true and true. PHP executes the expression in the order of the conditions. Firstly, it'll check if the first condition evaluates to true. If it does, the second expression is checked. Nothing complicated so far. But what if the first expression evaluates to false? In this case, it doesn't make sense for PHP to check the second condition. The entire expression will evaluate as false, regardless of the value from the second condition. Both conditions must be true for the entire expression to return true. This behavior can potentially cause a problem. Define a custom function called example. In this function, let's echo a message to indicate the function called. Next, let's return true. Lastly, let's replace the second condition with an invocation of the example function. What do you think will happen? Do you think the message from the example function will appear on the page? Let's find out. Inside the page, only the variable has been logged. A message never gets echoed from our function. This is because PHP does not bother executing our function. Since the first condition was false, the entire expression was false. This behavior is beneficial. It prevents PHP from executing unnecessary logic. Applications should always be optimized for performance. This feature is known as short-circuiting, which is common in most programming languages. Let's try updating the first condition to true. As you can see, the message from our function has been echoed. You should always be aware of this feature. If you have a function that's expensive to run, you may want to consider adding it to the end of a condition. This way, you don't waste precious resources. That's all I wanted to mention for operators. In the next lecture, let's get back into controlling logic flow. In this lecture, we're going to start exploring loops. Looping is the process of repeating the same actions. A loop can be performed with conditions or a collection of values. We're going to explore both options. To get started, we'll perform a loop based on a condition. In the script, I'm going to remove all the code. Next, let's create a variable called a with an initial value of 1. This lecture will aim to output the numbers 1 through 15. This variable will be updated with each number. As we do so, we'll output the number into the page. This is the perfect use case for a while loop. A while loop allows us to repeat actions based on a condition. Let's look at an example. Below the variable, add the while keyword with a pair of parentheses and curly brackets. Inside the parentheses, we must provide an expression that evaluates to a Boolean value. If we don't provide a Boolean value, PHP type juggles the value into a Boolean. Expressions that evaluate to true will cause the code inside the curly brackets to execute. Otherwise, nothing happens. Let's use the following condition: a less than equals 15. In this example, the a variable must be less than or equal to the number 15. Since our variable stores the number 1, this condition evaluates to true. Thus, our loop will be executed. PHP always checks the condition before executing the block of code. Inside our block of code, let's write the following: echo a.br. In this example, we're echoing the number along with the break tag. This is so that our numbers aren't cluttered. We're almost finished. At the moment, we have an infinite loop. Infinite loops are considered to be highly dangerous. After a block of code has been executed, PHP evaluates the expression written from within the parentheses again. If the expression evaluates to true, the block of code is executed once more. This process repeats until the condition evaluates to false. A false value causes PHP to move on to the next line of code written after the loop. Our condition always evaluates to true. We are never updating the a variable. It's always considered good practice to avoid infinite loops. Otherwise, a block of code runs endlessly. Resources are consumed to the point that a system will crash. After echoing the value, let's write the following: a++. We could have used the addition operator to accomplish this task. However, it's not uncommon to increment a value by 1 from within a loop. For this reason, PHP introduces the increment operator to add 1 to a value. It's cleaner to read than the other solution. On each iteration, the number will increment. Eventually, the variable will be greater than 15. Thus, our loop stops running. The numbers 1 through 15 appear on the page. The while loop is a powerful feature. PHP has an alternative syntax for writing while loops called do while. Let's convert our while loop into a do while loop. First, move the while portion of the code from the beginning to the end of the loop. Next, add a semicolon. Lastly, add the do keyword at the beginning of the loop. There's one major difference between a while and do while loop. A do while loop executes code from within the curly brackets at least once. This section of code is guaranteed to run once. After executing the block of code, PHP checks the conditions. Previously, the while loop would perform the condition check first. It's uncommon to use the do while loop, but it can be helpful when you need to run code at least once. In addition, a semicolon is necessary for the while keyword. Typically, PHP does not require the semicolon for blocks of code. However, since we're writing additional code after the closing bracket, we must manually end the statement. The same results are outputted into the page. That's to be expected since the condition doesn't change. To prove the block of code executes, let's change the condition by setting the number to 0. If we run the script again, only a single number appears. Despite the condition evaluating to false, PHP has executed our block of code before checking the condition. In most cases, you probably won't need the do while loop, but it is nice to know. In the next lecture, let's keep exploring loops. In this lecture, we're going to explore the for loop. The for loop was designed for repeating actions based on a condition. The code is going to be similar to the while loop. A few parts are going to be in different locations. Let's look at an example. In the PHP file, replace the contents of the file with the for keyword. This keyword is followed by a pair of parentheses and curly brackets. Inside the for keyword, we must provide 3 pieces of information. First, we must initialize a variable. Let's create a variable called I with an initial value of 1. Previously, the while loop accepted a condition. Other pieces of information had to be managed in external areas. The for loop is different. Instead of being able to freely define variables outside of the loop, they can be written within the parentheses. This adds more clarity to our loop. The second piece of information required by the loop is the condition. Let's use the same condition as before, which was the following: I less than equals 15. Lastly, we must provide an expression to increment the I variable. Let's use the increment operator. The syntax may feel strange. When PHP encounters a for loop, it'll execute the first portion of the loop, which is initializing a variable. The variable is never initialized again. It doesn't matter if the loop runs several times. This bit of code runs once. Next, PHP executes the second piece of code. If the expression evaluates to true, the block of code gets executed. Inside the block of code, let's echo the I variable with a break element. After the block of code has been executed, PHP executes the expression from the third section of the loop. After doing so, it'll execute the second condition. This process repeats until the condition evaluates to false. Essentially, we have the same thing as before. The main difference is that the logic has been centralized into a single location, which may be easier to read. On the page, the numbers 1 through 15 have been rendered. That's great. So, why do we have two loops for performing the same thing? When would we use a while loop over a for loop? Vice versa, why would we use a for loop over a while loop? The for loop was introduced performing a loop based on a specific number. If you want to perform a loop 10 times, you can tailor the expressions to this scenario, whereas while loops are not restricted to a count. In some cases, we may want to perform a loop based on strings, arrays, or other types of values. We're not restricted to numbers. It's completely possible to stick to one loop. You don't have to use both loops in your programs. Most developers prefer the while loop. It's simpler than a for loop. Before moving on, there's one more thing I want to mention. PHP gives us the power to control loops with additional keywords. For example, we may want to skip a number. Inside the for loop, let's add an if statement. The condition will be the following: I equals 6. It's perfectly valid to nest blocks of code. In this case, we're performing a condition before echoing the value. The equals operator is a comparison operator. It'll check if the values are equal to each other. If they are, we should skip the current iteration of the loop by using the continue keyword. The continue keyword can be used in any loop. This keyword instructs PHP to stop executing the block of code. It should immediately recheck the condition. You don't have to wait for the entire block of code to run. If you need to stop the current iteration from running, you can do so with the continue keyword. As you can see, the number 6 has been skipped. It does not appear in the output. Numbers after 6 appear. The continue keyword does not completely stop the loop. What if you want to end the loop completely? That's possible by replacing the continue keyword with the break keyword. By using the break keyword, the loop can be stopped earlier than intended. These keywords are not exclusive to the for loop. You can use them for any loop. In the next lecture, let's explore one more type of loop. In this lecture, we're going to explore one more feature for loops called a Foreach loop. So far, we've been performing a loop based on a condition. We're not limited to conditions. In some cases, we may need to loop through an array. It's a very common practice. PHP offers the Foreach loop for this specific purpose. Let's give it a try. First, let's create an array. In the script, clear the contents of the file. Next, define an array called names. Inside this array, add a list of random names. Lastly, add the Foreach keyword with a pair of parentheses and curly brackets. Our goal is to loop through each item in the array. During each iteration, we'll output the name. The Foreach keyword accepts a specific format. Type the following: names as name. First, we must provide the array. Afterward, we can use the as keyword to create a reference for each item in the array. As PHP loops through the items in the array, the current item in the iteration will be stored in the variable after the as keyword. It's common practice to use the plural version of a word when defining arrays. Items in an array use the singular form of a word. You don't have to follow this practice, but it's commonly adopted among developers. PHP handles going through each item in the array. Inside the loop, let's call the variable dump function with the name variable. All three items from the array are listed. PHP goes through each item from first to last. Overall, the Foreach loop makes it easy to loop through items in the array. There are a few things I want to mention. Sometimes you may want to grab the key of the item in the array. It's completely optional to grab this information from the current iteration. In the parentheses, let's update the expression by adding the following after the as keyword. Key equals greater than. The syntax is similar to associative arrays. To the left of the arrow, we must provide a variable for storing the key of the item. You don't have to use these variable names. You can use whatever name you'd like. Generally, developers will use the word key for clarity. Inside our function, call the variable dump function with the key variable. Looking at the preview, the key is accessible via the variable. This concludes our discussion on loops. So far, we've explored 4 features for writing loops. PHP offers us the power to loop through an array or to write a condition to power the loop. Hopefully, it's clear why you would use each loop. In this section of this course, I've provided 3 programming challenges. Before you start jumping into them, there's one point I want to make. These programming challenges are going to be different from the programming challenges I've given you thus far. To understand what I mean, let's look at the challenge you'll encounter in the following lecture. The challenge is called Resistor Colors. If you're watching the free preview of this course on YouTube, you can find the exercise in the resource section. All challenges and solutions can be found in the book too. Check the description for a link. Alright, let's read the first paragraph together. If you want to build something using a Raspberry Pi, you'll probably use resistors. For this exercise, you need to know 2 things about them. Each resistor has a resistance value. Resistors are small, so small, in fact, that if you printed the resistance value on them, it would be hard to read. If you were to continue reading the rest of the challenge, you're going to notice one thing. I'm not providing a lot of programming instructions. There's a good reason for this. In the real world, your clients aren't going to know programming lingo. They aren't going to tell you to create a constant or a function. A clear step-by-step guide won't always be provided. As a programmer, your job is to break down a problem into programmable steps. The best way to prepare yourself for these types of scenarios is to take on these challenges. I'm going to give you a challenge with all the information you'll need. From there, you should take the time to dissect the information given to you. You must decide what PHP features you'll need to achieve a feasible solution. Of course, you're not going to be left alone. After each exercise, there will be a video walking through the challenge. You'll get an opportunity to hear my thought process when approaching a problem. There's one thing to remember when viewing my solution and comparing it to yours. There are different ways to tackle a problem. Your solutions may not always be 100% identical to mine. That's perfectly fine. For example, your variable names may be different from mine. In some cases, your solution may be using switch statements when I use if statements. As long as your solution works, that's great. The most important skill to pick up is problem solving. Being able to think critically about problems is an invaluable skill. Hopefully, these challenges will help improve your problem-solving skills. To give you an idea of what this looks like, I'm going to partially walk through my solution for the first challenge. Let's continue reading the prompt. To get around this problem, manufacturers print color-coded bands onto the resistors to denote their resistance values. Each band has a position and a numeric value. The first 2 bands of a resistor have a simple encoding scheme. Each color maps to a single number. In this exercise, you are going to create a helpful program so that you don't have to remember the values of the bands. Based on this information, we can deduce that we'll be working with a color and its respective code. Our job is to return a numeric code based on a given color. Below this description, we're given an official list of colors along with the code. The last part of the description says the following. The goal of this exercise is to create a way to look up the numerical value associated with a particular color band. Alright, I think we have a general idea of what we need to do. As a tip, I recommend using PHP comments to write notes within your files. Writing down steps can be a great way to tackle a solution before writing a single line of code. To save time, I've already prepared the comments for this challenge. You shouldn't expect comments for subsequent challenges. I think the first step should be to create a function that accepts the name of the color. Within this function, we should create an array of colors with their respective code. Lastly, we should search the array for a specific code based on the name of the color. Below our comment, I've provided you with the function for handling this logic. I don't recommend changing the name of the function. Otherwise, your solution will not pass the test. Your goal is to update this function to return a color code when given a color name. If you ever get stuck with a challenge, check out the Solution Explanation tab. This tab will contain a complete solution, but don't cheat. Make sure you put in the effort to solve the challenge. With this information in hand, I wish you the best of luck. Try your best to solve the challenge. Afterward, I'll discuss the challenge with you in the following video. Good luck. In this lecture, we're going to walk through the solution from the previous challenge. We left off with writing the steps for implementing a solution. As noted by the first comment, we must create a function. I've already defined a function for you for this exercise. However, I think it could be improved. This step is optional, but enabling strict typing can be beneficial for debugging. Let's quickly add it. At the top of the file, add the declare keyword with the following value, strict types equals 1. Next, let's add type hinting to the parameter of the color code function. Before we can add a type, we must choose an appropriate type. Let's look at the prompt again. The prompt states that our function must provide a numeric code from a color's name. We don't know the type of the color parameter. However, we can make an assumption. Storing the name of the color must use the string type. In our parameter list, let's add the string type to the color parameter. Next, our function should return the color code. Once again, we can look at the prompt for the best type. The numeric code for each color is an integer. There aren't decimal values, so it's safe to assume we can use the integer type. Let's set the return type to integer. Great. If you didn't add the types, that's perfectly fine. Our function would work without them. I like to add them as a precaution. It's a good habit to get into. Let's move on to step 2. According to step 2, we must create an array to store the array of colors and their codes. Storing 2 pieces of information for each item sounds like a good opportunity for an associative array. In this array, the key name can represent the color name. The value of the item would be the numeric code. For example, let's create an array called colors. Next, add an item called black with a value of 0. Black is the first color on the list. The value can be found in the prompt. I'm going to add the rest of the items from the prompt. You should do the same. Pause the video if you need to. Our array is ready. Back in our comment, the last step is to return the code from the array. This step should be easy. Back in our function, let's return the following. Colors, color. So far, we've been hard-coding the key name inside the square brackets. We're not limited to hard-coding the key. PHP accepts an expression that evaluates to a string or integer. In this case, we're using the color parameter to evaluate the key name. That's it. We've successfully finished our function. Let's try testing our work by submitting the code. If you're on YouTube, you can try echoing various values by calling the function. If we did everything right, the tests should pass. The tests I've written will check most of the colors for the correct codes. If you get an error, chances are you have a number assigned to the wrong color. Be sure to go over the list of colors carefully. We're finished with the challenge. Hopefully, you have an idea of how to tackle a real-world problem with code. Good luck with the next challenge. In this lecture, we're going to solve the second challenge of this section together. Before writing code, we should read the prompt. It says the following. 2 for is short for 2 for 1. 1 for you and 1 for me. Given a name, return a string with a message. 1 for name, 1 for me. Where name is the given name. However, if the name is missing, return the string 1 for you, 1 for me. Overall, it's a simple exercise. Everything we need to know is given in the prompt. Below the description, I've provided examples of what the outcome should be based on a given value. As always, we should write down our steps. First, let's look at the code I've given. We have a function called 2for. I've decided to include strict typing in this file to help you understand what you must do. The function accepts a string, which is called name. The return value must be a string too. That makes our job easy. All we have to do is complete the function. Firstly, we must set a default value. Above the function, add a comment to write down your steps. First, we must set a default value when a value is not passed into the function. Adding a default value allows a parameter to be optional. Next, we must return a string. String concatenation or string interpolation can be used. Either solution is valid. For this example, I'll be using string interpolation. In my opinion, it's easier to read. That should be it. Let's try updating our function with these steps. In the parameter list, set the name parameter to you. Default values can be added to parameters. If a value is not passed into the function, PHP defaults to this value. Thus, our parameter is optional. Next, let's return the following. 1 for name, 1 for me. String interpolation requires double quotes. If you're using string concatenation, you can use single or double quotes. The formatting does matter. Make sure your string matches mine. The tests I've written are case sensitive. I'm surrounding the variable with curly brackets to prevent the comma from being inserted into the variable name. Great, we're finished. There are a few improvements we could make. Overall, I'm satisfied with this solution. Let's run our code through the solution. Our test has passed. Awesome. We can move on to the final challenge for this section. I wish you the best of luck. In this lecture, let's try walking through the solution for the leap year challenge. First things first, let's read through the challenge. It's straightforward. The goal is to write a function that tells us if a specific year is a leap year. We're given a list of rules to follow. The year must be evenly divisible by 4. The exceptions to this rule are years evenly divisible by 100, unless the year is evenly divisible by 400. If a year follows these rules, we have a leap year. In addition, I've decided to include a YouTube video with interesting information on the concept of leap years. Below, I've given you a function called isLeap. This function accepts the year as an integer. The return value is a Boolean. If the year is a leap year, let's return true. Otherwise, we'll return false. There are different ways of tackling this challenge. In my opinion, conditional statements are a great option. As always, let's write a few comments to help us write down our thoughts. Firstly, we should check if the year isn't evenly divisible by 4. Next, we should check that the year is evenly divisible by 100. Unless the year isn't evenly divisible by 400. If both conditions are truthy, we should return false from the function. Lastly, we should return true when the conditions fail. At this point of the function, it's safe to assume we have a leap year. I think this should cover our bases. By the way, in some situations, you may not have every step figured out. That's perfectly fine. The purpose of writing down steps is to have a general idea of what you need to do. Sometimes you may need to include additional steps or use a completely different solution. Either way, it can be a great way to collect your thoughts before writing a single line of code. Let's get started. Inside our function, add a conditional statement with the following condition. Year %4 does not equal 0. I'm using the modulo operator to divide the year by 4. Values that are evenly divisible produce a remainder of 0. Keep in mind, arithmetic operators have higher precedence than comparison operators. Therefore, this portion of the expression is evaluated before the values are compared. If this equation produces a remainder, the value will not be equal to 0. Thus, we do not have a leap year. Inside the conditional statement, return false. Let's start working on the second step. Add a second conditional statement. In this conditional statement, let's write the following condition. Year percent 100 equals 0, and year percent 400 does not equal 0. The condition we've written is slightly complex. We're checking for two conditions to be true. Firstly, we're checking that the year is evenly divisible by 100. If it is, this year is not considered a valid leap year. On the other hand, if it's evenly divisible by 400, it is considered a valid leap year. The second condition is checking for a remainder. If both conditions evaluate to true, the year is invalid. Inside the conditional statement, return false. Let's assume the year is valid. In that case, we should return true. Return this value at the end of the function. We're finished. Let's try testing our code to verify that it passes all tests. If you receive a success message, you should be good to go. For those of you who don't have access to tests, you can try calling the function with the years I provided in the description. There are a few examples you can use to verify a leap year. Before moving on, I want to discuss alternative solutions. As I mentioned before, multiple solutions can be presented for solving a single problem. There is no wrong answer. Here are some solutions you might come up with. Firstly, we can condense the conditions into a single expression like so. It's less code to write, but there is one potential problem. We're sacrificing readability for cleverness. If you're a senior developer, you may prefer this solution. Deciphering this line of code may be easier for programmers with experience. If you're a beginner, you may have difficulty reading this line of code. As I said before, there is no right or wrong answer. If you prefer a single line of code, that's fine. I decided not to use this solution so that it's easier to understand our solution. Here's another solution. It's completely acceptable to nest conditional statements. I'll be candid with you. There are a lot of developers who strongly dislike nested code. The more nested code you have, the harder it becomes to read your code. Of course, it's all preference. In my opinion, I prefer to avoid nested code whenever possible. That wraps up the final challenge. In the next section, let's continue learning new features of PHP. In this lecture, we will explore a few of PHP's predefined constants. They may come in handy from time to time. In the resource section of this lecture, I provide a link to an official list of predefined constants. These constants are defined by the PHP language. You don't have to do anything to include them in your project. They are readily accessible. Let's go over some of them. Before we start using these constants, I'm going to clear the contents of the PHP file except for the opening PHP tag. Alright, let's echo out a constant called PHP version. As you might suspect, this constant outputs the current PHP version on your server. This constant might come in handy if you're developing a script that will be deployed on multiple servers. Verifying the PHP version is a common action taken amongst PHP developers. If a server has an outdated PHP version, you can use this opportunity to notify an administrator to update the version. Older versions of PHP may have security bugs or flaws. In addition, you may be using a feature in PHP unavailable to previous versions. As you can see from the preview, I'm using PHP 8. You may have a newer version depending on when you're watching this video. Alright, let's try echoing a different constant called PHP int max. I'll concatenate a break element to echo another constant called PHP int min. Technically, there's an infinite set of numbers. However, That doesn't mean that most computers are able to handle those numbers. In most cases, there's a maximum and minimum set of numbers that PHP can handle. Luckily, the range of numbers is extremely vast. It's uncommon to exceed these thresholds. If you're ever curious as to what those thresholds are, PHP stores the minimum and maximum integer values in those constants. The same goes for float values. For example, I'll replace the word integer with float. If we look at the preview, the format of the numbers may appear strange. There's a letter E in the middle of the number. PHP uses scientific notation for numbers that are too large to display. It's not something you'll ever have to worry about, since most developers never exceed these limits. However, they're still good to know just in case. Alright, those are some of the simpler constants offered by PHP. There's another subset of constants that are bizarre to say the least. In the resource section of this lecture, I provide a link to a page of magic constants. Magic constants defy the very concept of a constant. Unlike most constants, the value of a magic constant can change. Out of the box, PHP offers 9 magic constants. So, what are they, and why can they change? To understand how magic constants work, let's try using one. Back in our project, let's echo a constant called underscore underscore line underscore underscore. So, one thing worth noting about magic constants is that they all start and end with 2 underscores. This naming convention is how you can identify a magic constant. The line constant outputs the current line it's on, which can feel strange. However, it gets even more bizarre. If I were to add a few lines before the echo statement, the value can change. As you can see, the new value reflects the new line number. To take things a step further, we can output the constant again to get a completely different value. I'll add a break element to the first echo statement for readability. Once again, the correct line numbers get outputted, which is strange. The idea of a constant is that the value can never change. That's still partially true. Developers are not allowed to update constants. If we were to attempt to update a magic constant, PHP would throw an error. Only PHP is allowed to override the values of a magic constant. Magic constants are a feature for accessing information about the current file. Conveniently, PHP manages these variables on our behalf. What makes them unique is that their values can change based on where we use them. To give another example, I'm going to replace both constants with a constant called file and directory. Be sure to include 2 underscore characters before and after their names. The file constant contains the full system path to the current file. Notice how I said system path. It's not the HTTP URL to the file, but the path to the file on the current machine. Since we're using Replit, the path points to the file on Replit's servers. As for the directory constant, it points to the directory where the file can be found. Both constants are completely useful. More often than not, you're likely to use them a few times in each of your PHP applications. I highly recommend familiarizing yourself with them. That's about it for magic constants. In the next lecture, let's continue filling in the gaps of PHP. In this lecture, we're going to explore an alternative syntax for creating constants. PHP has 2 features for creating constants. So far, we've been using the const keyword. The other solution is to use the define function. Let's look at an example. In our script, let's replace the current code with a function called define. The define function has 2 parameters. The first parameter is the name of the constant. Unlike before, we must pass in the name as a string. Other than that, the same rules and conventions apply to constants. Let's set the name of the constant to foo. Next, the second parameter must contain the value of the constant. Let's set the value to hello world. Lastly, we can access the value of the constant by its name like any other constant. After defining the constant, let's echo the value. In the preview, the value from the constant appears. That's great, but what are the differences between the define function and const keyword? Well, the const keyword was introduced for defining constants from within a class. Classes are a feature of PHP we haven't had the opportunity to discuss yet. They are going to be a prominent topic in an upcoming lecture. However, when we get to classes, the define function cannot be used from within a class, whereas the const keyword can. Another difference between both solutions is being able to use the define function from within a conditional statement. For example, I'm going to wrap the define function in an if statement. The condition for this statement will be true. If we run the script, PHP doesn't have a problem with our code. It's completely acceptable to define constants from within a conditional statement. However, this behavior is not possible with the const keyword. I'm going to quickly convert the constant from the define function to the const keyword. This time, an error gets produced by PHP. If we use the const keyword, PHP is unable to create the constant from within a conditional statement. But the question is, why would we want to define a constant from within a conditional statement? The most common use case is to avoid redefining a constant. For example, I'm going to revert the constant definition to the define function. Afterward, instead of passing in true, let's use a function called defined. The defined function is not to be confused with the define function. They have similar names, but the function we're using has the letter D at the end. This function can be used to check that a constant has been defined. If you're developing a large application, you may have dozens of files. It's not uncommon to define the same constant from within multiple files. This is especially true if you have an application that can support plugins. In these cases, you may end up defining a constant twice. As we know, PHP does not allow a constant to be redefined after one has been created. To avoid errors, it's common practice to check that the constant has been created, which is what the defined function can do. This function accepts the name of the constant. Let's pass in foo. A true Boolean value is returned by this function only if the constant has been defined. However, we want to check that the constant hasn't been defined, because if it hasn't, we can go ahead with creating it. Luckily, we know an operator that can check for a false value. Do you remember what it is? I'll give you a moment to think about this. It's the not operator. We can add it to the beginning of the condition like so. Essentially, we're checking that the constant hasn't been created. If we look at the preview, everything is working as before. So, that's the define function. It's an alternative solution to using the const keyword. You can use whatever you prefer. In my personal preference, I like using the const keyword because it's easier to read. It's also easy to distinguish from the defined function, which checks for a constant. However, you're more than welcome to continue using the define function. In the next lecture, let's move away from constants to talk about other features of PHP. In this lecture, we're going to learn about a function called unset. Whenever we define a variable, servers allocate memory for that variable. Memory is not released until the script has finished executing. However, we may want to free memory before that happens. PHP gives us the power to delete a variable after it's been created by using a function called unset. Let's give it a try. In our script, let's replace the current code with a variable called name. Its value will be John. Next, let's try echoing the variable. So far, nothing new. After echoing the variable, we may not need it anymore. That's going to be a common thing in your code. Sometimes, you won't need your variables to stick around after they've served their use. We can unset the variable by calling the unset function with the variable passed in. Calling the unset function doesn't cause anything to happen on the screen. Behind the scenes, it's deleting the variable. To prove this, we can try echoing the name again. This time, we got an error from PHP. Despite defining it earlier, the variable becomes undefined because we've deleted it from memory. We're not limited to deleting an entire variable. What if we have an array? Individual items from an array can be deleted. For example, let's try updating the name variable by converting it into an array. Wrap the value with a pair of square brackets. Next, let's add an additional set of random names. Lastly, I'm going to update the variable name from name to names. Not a necessary step, but recommended. As I stated before, it's considered good practice to use the plural version of a word for variables that store arrays. After updating the variable, I'm going to update the next few lines of code to echo and unset the second item in the array. As a reminder, the second item of the array has an index of 1. PHP starts counting at 0. Therefore, the second item's index is 1. If we run the code, we get the same behavior as before. The name appears in the preview, gets unset, and then PHP throws an error because the item doesn't exist anymore. But what about the rest of the array? To find out, we should try rendering the entire array. One option is to use the variable dump function. On the other hand, I think this is a great opportunity to introduce you to another function for viewing the contents of the array. Replace the echo statements with a function called printr. While you're doing that, make sure that you're passing in the entire array instead of a specific item. The printr function was designed for outputting an entire array. The main difference between the printr function and variable dump function is that the printr function does not print the data types. There's less information in the output, only the values appear in the preview. You're not always going to be interested in the data type of each item in the array. As you can see, the array continues to persist. Let's take a closer look at the array. The first array has 3 items, whereas the second array has 2 items. In the second array, the item with an index of 1 is completely missing. PHP goes from 0 to 2, skipping 1. This confirms that the item was deleted. Now, with that being said, you may want to reindex the array. It can be awkward to have missing indexes. PHP does not automatically reindex an array after an item has been unset. We can manually reindex the array by updating the names variable to a function called ArrayValues. The ArrayValues function accepts the array to reindex. Let's pass that in. It'll return the reindexed array as a result. Looking at the preview, the second array is no longer missing the 1 index. The last item in the array got reindexed into the correct number. Overall, unsetting variables is incredibly easy. With one line of code, you can release memory from your script. In the next lecture, let's take a moment to talk about PHP's documentation. In this lecture, we're going to take a moment to talk about PHP's documentation. For the past few lectures, I've introduced a few functions to you, but didn't show you how I found them. As mentioned before, PHP has hundreds of functions. It's impossible to cover every single one. But how do you know which functions are worth remembering and which aren't? That isn't an easy question to answer. There isn't an official list of recommended functions to remember. However, not all hope is lost. Learning to read the documentation is one of the most crucial skills you can pick up as a developer. That's my goal for this lecture. In the resource section of this lecture, I provide a link to PHP's manual. On this page, PHP provides information on various topics, from syntax to security practices. There's a wealth of knowledge to be found in the manual. One of the sections you may find yourself interested in is the functions reference. Search for it and click the link. The functions reference provides a complete list of functions available in PHP. You can perform various actions, from interacting with a database to creating files on a server. I highly recommend bookmarking this page as you may need it in the future. Regardless of what function you plan on using, the structure of a functions documentation page is the same. Let's look at an example. In the top right, search for a function called ArrayValues. We learned about this function from the previous lecture. Before using a function, you should always take the time to view the documentation. But how do you read a function's documentation page? Let's try going through each section one by one. First and foremost, a list of supported PHP versions is provided under the function name. Not all functions are available in every version of PHP. Some functions have been around since the early days of PHP. Other functions were introduced in newer versions. If a function is not behaving as expected, you should check that it's available in your current version of PHP. Luckily, we're using the latest version of PHP, which is version 8. The array values function is available in this version. Below the version list, we're given a short description of the function. In my opinion, the most important portion of the description is the function definition. This portion of the description has two critical pieces of information. Firstly, the function's parameters are listed in the definition. Pay close attention to the data type. If you pass in the incorrect data type, PHP may attempt type juggling. Whenever possible, you should avoid that behavior by passing in the correct data type. Otherwise, you might encounter errors or unexpected behavior. The second critical piece of information is the return type, which is always written after the colon character in the function definition. According to the documentation, we can expect the function to return an array. It's a great summary, but we may require more information. Luckily, PHP has us covered. Below the description, the parameters and return values sections provide additional context. Honestly, there's not much to this function. It just accepts an array and returns a re-indexed array. Regardless, you're most likely to check out these sections of the documentation page. Most functions have these sections. PHP is very good at being consistent. There are more sections worth looking at. Afterward, there's a section with an example. This section gives you the opportunity to look at how to use a function. Sometimes, you may find multiple examples. In this case, we have a single example of re-indexing an array. Moving along, we have a section called See Also. You may come across a function that doesn't really solve the problem you're facing. If that's the case, you might want to check out this section of a function's documentation page. This section provides an alternative list of functions that you can use. Oftentimes, they're similar to the function you're looking at currently. For example, PHP recommends the ArrayKeys function for grabbing an array of keys instead of the array's values. If you need the keys of an array, this function is a great alternative. Let's keep moving forward. One of the last sections is user-contributed notes. As mentioned before, PHP is an open source language. Volunteers from all over the world contribute to PHP's growth and maintenance. Part of that effort is improving the documentation. This section has notes from other developers of PHP. Developers can freely submit additional pieces of information about a function that is missing from the current documentation. If you ever need more examples or information, this section is worth checking out. There's actually one more section that I want to show you that isn't available on this function's documentation page. We'll need to look at a different function. In the search bar, search for the define function. Like usual, we're going to encounter the same sections from the previous function. However, there's one additional section you may discover. Scrolling through the page, there's a section called changelog. PHP is an evolving language. Not all functions remain the same across different versions. The PHP team may take the time to improve some functions. If a function changes, those changes are documented in this section. For example, since PHP 7, the define function allows developers to use arrays as values. Prior to this version, arrays were not supported in constants. This is important to understand. Just because a function works in one version doesn't mean it'll work the same way in another version. Occasionally, you may find yourself using a function that behaves differently in older projects. Checking out this section of the page can help you find out why. Alright, so that's about it for the documentation of PHP. Throughout the course, I'll be sure to mention other helpful information worth looking at. For now, this information should suffice. Let's get back into programming in the following lecture. In this lecture, we will learn how to round numbers with PHP. Not only that, we're going to build upon our reading comprehension of PHP's documentation. Check out the resource section of this lecture for links to 3 functions. We're going to be exploring 3 functions called ceil, floor, and round. Starting with the floor function, let's check out the documentation page. Most of the information is self-explanatory. However, there's one piece of information I want to highlight from the page. In the description, the data type for the number parameter is a union type. You can identify union types by the pipe character. As you can see from this example, the ceil function accepts an integer or float. Just wanted to point this out, as you may come across union types in the documentation. Alright, let's try using this function. Switch over to your Replit project. In the script, we're going to echo the following number, 5.454. So far, we've learned that casting a float to an integer causes PHP to round the number. However, it's not truly rounding the number. It just strips out the decimal values. For example, let's try typecasting the number into an integer like so. In the preview, we've given the number without the decimal values. But, once again, PHP is not rounding the values. If we want to round the value, we can use one of three functions. One of the functions is called floor. This function always rounds a number down. As you can see, we get the same result. But what if the number was something like 5.9? Regardless, the number gets rounded down. Now, you may be thinking, how is this any different from typecasting the value into an integer? It seems like we get the same results. However, that's not entirely true. PHP is attempting to round the number when we use the floor function. To prove this, let me show you a different example. Instead of echoing the floor function, let's typecast a negative number like minus 0.1. Typecasting this value into an integer produces 0. But what do you think would happen if we were to use the floor function instead? Let's find out. Upon replacing the typecast with the floor function, we get minus 1. That makes sense, right? When we typecast a number, PHP strips the 0.1 decimal, which leaves us with 0. I always encourage students to use these functions to round values instead of typecasting the value, as it'll always produce reliable results. Let's keep exploring the other rounding functions. Another function that I linked to was the ceil function. This function behaves similarly to the floor function. It'll round a number, but the number will be rounded up. For example, let's try rounding a number like 5.454 with the ceil function. This time, we got 6. PHP gives us the option of rounding down or up. But what if we don't want to round to a whole number? Sometimes, we may want to round with better precision. Well, it turns out there is such a function called round. Let's check out the documentation for this function. Unlike the other two functions, there are more parameters. The round function was introduced for customizing the rounding functionality offered by PHP. To understand how this function works, let's go through the documentation. In the description, the function's parameters have default values. Looking closely, the assignment operator is present in the definition. Whenever you see the assignment operator, the documentation is telling you two things. Firstly, the parameter is optional. Secondly, it tells you what the default value of that parameter is. The first parameter is the number to round. The second parameter is called precision, with a default value of 0. The last parameter is called mode, with a default value of constant. But how do I know it's a constant? I don't know for sure because we haven't read the description from the parameter section of the documentation. However, two signs lead me to believe this is a constant. Firstly, the value is written in all uppercase letters. As we know, it's common for PHP developers to use all uppercase letters for constant names. This convention is followed by the PHP language itself. Secondly, the name of the constant starts with PHP, which is commonly used by the PHP language. Just to make sure, let's read the descriptions of these parameters. According to the description of the precision parameter, this parameter allows us to configure the number of digits that can be present in the number. If we look back at the function definition, the precision is set to 0. Therefore, all decimal values are removed from the result. We can override this behavior by passing in a value for this parameter. Moving along, The mode parameter allows us to configure the rounding behavior. Should the number be rounded down or up when the number is at the halfway point? By default, the number goes up. We can change this behavior by using one of the constants listed on the documentation page. Alright, so we've gotten an overview of this function. Let's try using it. Head back to Replit. Currently, we're rounding the number with the ceil function. Let's replace it with the round function. We get the number 5 in the preview. Despite having additional parameters, they are completely optional. Therefore, we can skip adding those into the function. When you're working with currencies, you may want to include decimals. For example, most currencies allow 2 digits in a decimal value. In this case, we have 3. According to the documentation, the precision can be configured by passing in an integer with the exact number of decimals we'd like. Let's pass in 2. Just like that, we've got a fine-tuned rounded value. Let's take it a step further by changing the number to 4.455. Naturally, PHP rounds the number to 4.46. But what if we want to round the number down when the last number is 5? That can be configured with the third parameter. We can pass in a constant called PHP round half down. This time, the number changes to 4.45. So, as you can see, the round function is much more powerful than the floor or ceil functions. I recommend using it whenever you need to round numbers with better precision. I know I spent a lot of time reading the documentation with you. However, it's an invaluable skill for a developer to understand how to read the documentation. You're not going to know every function in existence. In these cases, deciphering a function's documentation page will make you a better developer. In the next lecture, let's move on to conditional statements. In this lecture, we're going to look at an alternative syntax for writing conditional statements. PHP introduces a different solution for writing conditional statements for readability. In our script, let's say we wanted to welcome a user based on their permission. Let's replace the current code with a variable called permission. Set the value to 1. I'll add a comment to describe this variable. If the number is 1, the user is an administrator. If the number is 2, they're a moderator. Any other number will be considered a guest. Below the variable, add an if statement with the following condition. Permission equals 1. Next, inside the block of code, let's echo an h1 tag that says the following. Hello admin. Echoing HTML is completely valid. Unfortunately, there's one huge flaw with doing so. It's difficult to read the string without syntax highlighting. Every character in the string is a single color. I really like syntax highlighting for readability. Luckily, we don't have to echo the element. An alternative solution is to exit and re-enter PHP mode. For example, I'll replace the echo keyword with a closing PHP tag. Next, after the closing h1 tag, I'll add an opening PHP tag. Unlike before, we get syntax highlighting. In my opinion, it's easier to read. Let's continue adding more conditions. Add an else if condition with the following condition. Permission equals 2. Next, let's output another h1 tag with the following message. Hello mod. Lastly, let's add an else block. This block outputs another h1 tag with the following message. Hello guest. So, we've got a working series of conditional statements. There's just one problem I have with it. Reading this code is slightly difficult. It's not uncommon to conditionally render HTML. For this reason, PHP has a different syntax for writing conditional statements. First, let's put the variable definition on a single line with opening and closing PHP tags. Next, let's replace our conditional statements. I'll add the if statement with the same condition. However, this time, instead of using curly brackets, I'll add a colon character after the parentheses. Be sure to wrap the condition with opening and closing PHP tags. After these tags, add another pair of tags with a keyword called endIf. The alternative syntax doesn't require opening and closing curly brackets. Instead, we can denote the beginning of the block of code by using a colon character. The end of the block can be denoted with the endIf keyword. In between these PHP tags, we can write our HTML. Let's greet the admin again. What about the else if and else blocks? It's the same as before. After the h1 tag, add a pair of PHP tags with the else if keyword. Two things worth noting. Firstly, the else if condition is written before the endIf keyword. This keyword acts as the ending for the entire chain of conditional statements, not just the if statement. If we introduce the else if keyword after the if keyword, PHP assumes this is the end of the first if keyword. Secondly, the else if keyword cannot be written with a space between the words. Previously, we had the option of adding a space between the else and if keywords, but this syntax does not support that option. They must be written as one word. Alright, let's write the condition. Next, let's output an h1 tag to greet the moderator. Lastly, let's add the else block in another pair of PHP tags. Greet the guest. We have the same result as before. PHP introduces the syntax for readability. The conditional statements work the exact same. If you don't like this syntax, that's perfectly fine. The other solution works just as well. Generally, it's recommended to use curly brackets when you're only writing PHP code. If you need to write HTML, this syntax is considered to be superior for its readability. That's how most developers decide when to use which syntax. In the next lecture, let's talk about another topic related to conditional statements. In this lecture, we're going to talk about optimizing our code. It's never too early to talk about optimization. So, what exactly are we going to optimize? Not all functions are created equal. Some functions can be executed within an instant. Other functions may take a while to finish. You're never guaranteed how long your code will take to run. In these cases, we should take every opportunity to optimize our code. For example, let's say the user's permission was outsourced in a function. Replace the permission variable with a function called getPermission. From within this function, return 1. Lastly, let's update our conditions to use this function instead of the permission variable. So, what we're doing is returning the permission from the function. The same result occurs in our page, but let's say that this function takes a while to execute. Believe it or not, our code is inefficient. To find out why, let's try extending the duration of our function. Before returning a number, let's run a function called sleep. The sleep function instructs PHP to pause its execution. We can set the duration by passing in a number. Let's wait 2 seconds. After making that change, we can refresh the page. This time, the result takes a while to appear. Until 2 seconds have passed, the welcome message won't appear. So far, it isn't that bad. However, what if our function returned 2 instead of 1? Things become even slower. Upon refreshing the page, we're going to be waiting 4 seconds. But why? Let's look at our code to understand the problem. In the if condition, PHP executes the getPermission function. At this point, we're waiting 2 seconds. Once the function returns a value, PHP compares the numbers, which don't match. PHP moves on to the next condition. Once again, we're calling the getPermission function. Just like before, we must wait 2 seconds before the values can be compared. This is why our page is taking a while to load. Imagine if we had multiple conditions with the getPermission function. Users would be waiting forever. It's perfectly fine to call functions from within your conditions. However, if you decide to do so, you should realize that PHP must wait for your function to finish executing before completing the comparison. Otherwise, Your machine may occupy too many resources. There are two ways of resolving this issue. The first solution is to outsource the value returned by our function in a variable. Above the conditional statements, add a variable called permission with the getPermission function as the value. Next, let's use the variable instead of the function. This is so much better. Now we're only executing the function once instead of for each condition. So, what about the second solution? Instead of using if statements, we can use switch statements. I'm going to quickly convert this solution into a switch statement. You don't have to follow along, just watch. In this solution, we're calling the getPermission function from within the switch statement. I'm adding a case for each type of user, followed by a message to greet the user. It's the same thing as before. Interestingly, the page does not take 4 seconds to load. Switch statements execute the expression passed into the switch statement once. Therefore, the getPermission function runs once. If the first case fails, PHP does not execute the function again. It just uses the value from before to compare with the next case. We never have to worry about a function being called repeatedly, thus saving us the trouble of storing the value in a separate variable. Either solution is valid. Use whatever you prefer. This problem can also plague loops. For example, let's say we wanted to grab an array of users from a database. Communicating with a database can take time. Let's create a function called getUsers. From within this function, call the sleep function for 2 seconds. Next, return an array with random names. Now that we have our function, let's try creating a for loop. Add this loop below the function. Let's quickly add the following. I equals 0, I less than count getUsers, I++. Lastly, let's echo the I variable. Overall, most of this loop is familiar to us. I'm introducing a new function called count. We don't want the loop to run forever. We only want the loop to run for as many items as there are in the loop. The count function can be used for counting the items in an array. It'll return the size as an integer. That's why we're calling it in this example. Similar to before, we're going to be waiting 4 seconds for the page to render. This is because PHP waits 2 seconds for the condition to finish. It'll execute the block of code and then check the condition again. This process involves calling the getUsers function, which takes 2 seconds to finish. To avoid this scenario, we can outsource the value from counting the array into a separate variable like so. I'm using a variable called userCount to get this information. This time, the page takes less time to load. Unlike before, the function gets called once, unlike calling it every time the loop checks the condition. Once again, storing the results of a function in a variable is the best way to go sometimes, especially if you're using the results in conditions or loops. Just something to consider when working on your application. In the future, when we start working on the master project, we'll get plenty of practice optimizing our code with this technique. In the next lecture, let's continue exploring other topics of PHP. In this lecture, we're going to start adding additional files to our project. Realistically, most projects require developers to write hundreds of lines of code. With so much code, it can be difficult to maintain a project when everything is written within a single file. For this reason, PHP allows us to split our codebase into multiple files. Let's look at an example. In our project, we have 2 files called index.php and about.php. At the moment, users have to type the file name from within the address bar to view each page. I don't think that provides for a good user experience. The most common solution to this problem is to create a navigation menu. So, let's do that. In the index.php file, clear the contents of the file. In the file's place, add a navigation element. Inside the navigation element, Add two anchor elements linking to the home page and about page. Below the navigation, let's add some text to identify the home page. In the preview, the navigation appears as expected. Everything we've done so far is with pure HTML. However, there's just one problem. If I were to click on the About link, I'm taken to the About page. The navigation menu is completely missing. This issue can be resolved by copying and pasting the navigation over to the About file. Seems simple, right? Not so fast. What if we need to add, remove, or change the links in the navigation menu? What if we had more than 2 pages? Sites can have hundreds of pages. Copying and pasting the menu is not scalable. If we copied the menu to each page, we would have to modify every file that has the navigation menu. Ideally, the navigation menu should be easy to modify. Rather than creating copies of the navigation menu, let's have a single copy in a separate file. Inside our project, create a file called nav.php. Next, I'm going to move the navigation element from the index file to the navigation file. The question becomes, how can we load the navigation file from both the index and about files? PHP has a keyword called include, which instructs the language to load a different file. The include keyword accepts a path to a file. Let's give it a try. Back in the index file, try adding a pair of PHP tags. Inside these tags, add the include keyword. The path to the file must be written as a string. Let's set the path to nav.php. Just like that, we've loaded the navigation menu with a single line of code. PHP handles loading the file for us. As you can imagine, this feature is incredibly helpful for splitting a page into separate sections. You can create separate files for the header, footer, and sidebar. Let's try loading the navigation for the About file. In this file, I'm going to add the include statement again. You can copy and paste the line of code we had in the previous file. Great! Now we can try clicking on the links to test our navigation. If we switch between pages, we're able to view the respective page's content. Best of all, we can update the navigation menu once, and all pages will be reflected with those changes. We've just scratched the surface. There's more we can do. Back in the index file, PHP allows us to include files multiple times. For example, add the include keyword again for the navigation file. This time, we get 2 navigation menus. That's great and all, but this may be a mistake. What if our navigation file had PHP code for creating a constant? Let me show you an example. In the navigation file, add a pair of PHP tags above the menu. Inside these tags, create a constant called foo with a value of 1. You can use either the defined function or const keyword. It doesn't really matter. After adding the constant, PHP throws an error. The error states that the constant has already been created. The reason we get this error is because we're including the navigation file twice. Every time we include a file, PHP executes the code inside that file. As a result, we're attempting to define the same constant twice. We can resolve this issue by not including the file twice. However, mistakes can happen. If we have a large project, it's possible that we may accidentally include a file twice. To get around this dilemma, we can use an alternative keyword. Back in the index file, update the include keyword to include once. After swapping the keywords, the error goes away. The include once keyword is similar to the include keyword. It'll embed the code from another file into the current file. The main difference is that the code is only executed once. If we accidentally include the same file twice, PHP will make sure that the code only runs once, thus avoiding the error encountered earlier. I'm going to remove the second line of code. It's not necessary to keep it around. In addition to the include keyword, there's another keyword available for including files called require. Let's replace the include once keyword with the require keyword. Similar to before, we get the same result. Just like the include keyword, the require keyword has an alternative variation called require once. So, you may be wondering, what are the differences between the include and require keywords? Both keywords can be used for adding files to the current file. The main difference is how they handle errors. For example, let's try changing the file from nav.php to example.php. This time, an error gets thrown. There's a lot of information, but the portion we should focus on is the type of error. PHP has thrown a fatal error. Whenever PHP throws fatal errors, the rest of the script does not execute. It doesn't matter if we have more code to execute. PHP stops running altogether. This is proven by the fact that the message after the require keyword is missing. Let's replace this keyword with the include keyword. Once again, we get an error. This time, the home page message appears after the error. Looking closely at the error, PHP marks the error as a warning, not a fatal error. Unlike fatal errors, warnings do not stop a script from execution. PHP continues to run the next line of code after the warning has been thrown. Understanding the differences is crucial. Not every function or keyword produces the same type of error. Warnings do not stop a script from execution. PHP simply outputs a message, and then proceeds to the next line of code, whereas fatal errors completely stop the script from running after the errors have been rendered on the page. So, which keyword should you use? Well, that depends on if the file is necessary. If the file is necessary, use the require keyword. However, if your application can function fine without the file, use the include keyword. Throughout the course, you'll see plenty of examples. There's one more thing I want to show you before moving on. Believe it or not, files that are included can return data. For example, let's create a new file in our project called example.php. Inside this file, add an opening PHP tag. We're going to use the return keyword to return the number 2. The return keyword is not exclusive to functions. We can add it outside of a function to return data from the overall file. Back on the index.php file, we can store the data returned by our file in a variable like we would with any other type of value. Let's store the result in a variable called data. Lastly, let's echo the variable. In the preview, the number appears. That's great. This feature can be handy whenever you outsource the data in a separate file, instead of just outsourcing HTML. Keep in mind, the same behavior applies to files as it does functions. If we return data, the rest of the file does not execute. For example, let's head back to the example file. Before returning a number, let's return 1. After the return statement, echo the number 3. In the preview, the numbers 1 are rendered on the screen. However, the number 3 is completely missing. That's expected since the value is echoed after the return statement. PHP does not bother executing the rest of the file after a value is returned. Remember, this behavior only applies to the file that was included. The file that performs the inclusion can continue executing more code. That's about it for including files with PHP. In the next lecture, let's start diving into features about functions. In this lecture, we're going to make our functions more flexible by using the spread operator in our functions. To understand why this operator can be useful, let's look at a scenario where it can be useful. In our script, let's replace the current code with a function called sum. The goal of this function will be to calculate the sum of two numbers. Let's add two parameters called a and b. Their data types will be a union type of the integer and float types. Next, inside the function, return a plus b. Lastly, let's use our new function by echoing the function with the numbers 5 and 2. Our function is working as expected. It's possible to improve upon the existing functionality. Sometimes we may want to calculate the sum of 3 numbers or 7 numbers. At the moment, our function is limited to 2 numbers. One solution would be to add more parameters. That would work, but it would be tedious. It would be ridiculous to have 20 parameters. An alternative solution would be to create a variadic function. A variadic function is a function that accepts an unlimited number of parameters. It's easy to create. In the parameter list, replace the parameters with a parameter called numbers. Next, before the parameter's name, we can add 3 dots, also known as the spread operator. Actually, there isn't an official name for this operator. Some developers refer to it as the splat operator. Either way, adding this operator to a parameter instructs PHP to accept unlimited arguments. Arguments passed into the function are stored as an array, which we can access via the parameter. Type hinting is still supported. Before the argument, add the integer and float data types. Just to verify that the values are an array of integers, let's call the variable dump function with the numbers parameters. We do get a warning, but let's ignore that for the time being. At the top of the page, the variable dump function outputs an array with the numbers passed in. By using the spread operator, we've created a variadic function. It can accept multiple numbers. The next step is to loop through the array to add the numbers together. Fortunately, PHP has a function for performing this exact operator. Let's return the following: array sum numbers. The array sum function loops through an array of numbers and calculates the sum. We don't have to create a custom loop to achieve the same behavior. After returning the value, the preview displays the same result as before. This time, we can pass in additional numbers to the function. Our function will be able to handle any number of arguments. There is one thing to keep in mind when using variadic functions. The variadic argument must always be the last parameter. For example, let's say we wanted to add the option to dump the array before returning the value. Add a Boolean parameter called dump array. At the top of the function, add a conditional statement with the dump array parameter as the condition. Next, inside the conditional block of code, call the variable dump function with the numbers parameter. Lastly, let's pass in false as the first argument to the sum function. So far, everything is working as intended. We can pass in true or false to affect the behavior of the function. However, what if we switch the parameters? Let's find out. After doing so, PHP throws a fatal error. The message is cut and clear. It's informing us that our variadic parameter must be last, which makes sense, right? After all, the dump array parameter can never be assigned a value if the numbers array takes in all the values. So, keep this in mind when using variadic functions. In the next lecture, let's keep exploring functions. In this lecture, we're going to add named arguments to our function. Named arguments are a new feature of PHP 8. If you're using an older version of PHP, this feature won't work. Named arguments are a feature for passing a value to a specific parameter. Let's look at an example by simplifying our function. First, we should update our function to accept 3 parameters. Instead of creating a variadic function, let's revert the function to its original solution, which was to accept 2 numbers called a and b. The dump array parameter can be removed along with the conditional statements. Afterward, update the return statement to add the a and b parameters. Lastly, let's update our echo statement by passing in 5 and 2. Awesome! We've got something similar to what we had before. So, how do named arguments work? Currently, PHP assigns the values to our parameters based on the order of the values passed in. The number 5 is assigned to the a parameter, and the number 2 is assigned to the b parameter. What if we want to reverse those assignments? Well, that's possible with named arguments. Before the values, we can add the name of the parameters like so. b colon and a colon. By writing the name of the parameters before the values, PHP handles assigning each value to the correct parameter, regardless of the order. We can prove this further by dumping both parameters from within the function. As you can see, the b parameter holds the number 2, and the a parameter holds the number 5. In our example, using named arguments is redundant. The result is going to be the same. So, why would you want to use named arguments? In the resource section of this lecture, I provide a link to a function called setCookies. PHP has a few functions with more than 5 parameters. Sometimes, you may have custom functions with a lot of parameters. Looking closely at the definition, some parameters are optional. Let's imagine that we wanted to call this function, but we only needed to set the name and HTTP only parameters. If we want to set the HTTP only parameter, we must provide values for the other parameters, even if it's their default values. By using named arguments, we can skip setting values for the other parameters and only focus on what we want to set. Named arguments improve readability in our code by allowing us to configure specific parameters and forget the rest. So, that's how named arguments work. We'll be using them from time to time in our projects. In this lecture, we're going to talk about global variables. Before doing so, we should talk about the concept of scope. Scope affects the way we write programs. So, what is scope? Scope refers to the accessibility of your variables based on their location. The location of where your variables are defined matters a lot. If you define a variable from within a function, it'll be inaccessible outside of the function. Vice versa, variables defined outside of a function are inaccessible from within a function unless we use a keyword called global. Let's look at an example. In our script, let's replace the current example with a variable called x with a value of 5. By defining the variable outside of a function, it's accessible everywhere. This includes other files. For example, let's open the example.php file. Inside this file, let's increment the x variable with the increment operator. Next, let's echo the variable. Technically, this variable doesn't exist within the file. Therefore, we'll get an error if we visit the file directly. However, it can become available if we include this file from the index file. Back in the index file, add the include keyword to load the example.php file. Be sure to add this statement after the variable has been created. If we look in the preview, the number 6 has been outputted. Despite the variable being defined in another file, PHP exposes our variables to other files. They just have to be defined before they're accessed. This is why we must include the file after declaring the variable. Let's take it a step further by using the function from within a function. After the include statement, define a function called foo. Inside this function, let's echo the x variable. Lastly, let's call the foo function. After doing so, PHP throws an error at us. It's saying that the x variable is undefined, which is strange. However, it's not strange once you consider scope. Functions have a local scope. They don't acknowledge variables defined from outside the function. This is why we're receiving an error. There is a solution to override this behavior. At the top of the function, we can include the global keyword. This keyword instructs PHP to look in the global scope, which is where variables exist when defined outside functions. We can provide a list of variables to grab from the global scope by typing their name after this keyword. Let's grab the x variable. If we had multiple variables, we would separate them with commas. After adding this variable to the list, the error goes away. One thing to keep in mind is that the function can be modified. If we modify it from within the function, it'll affect other uses of the variable. For example, let's use the increment operator on the variable after echoing the value. Next, let's echo the variable one more time after calling the foo function. In the output, the number 6 gets outputted twice because we're echoing the value from within the example file and foo function. Next, the numbers get outputted one more time, but it's been changed to 7 because the value was incremented from within the foo function. A lot of developers don't like global variables for this reason. Variables that are accessible to every file and function means that the value can change at any time. Therefore, variables become less reliable. But what if we need to update a variable? The recommended solution is to use parameters and return values. By passing in the variable as an argument to the function will be able to modify the value and then return the result. The result can then be stored in the variable. Throughout the course, I'm going to be using parameters and return values to update variables. Global variables are not something I'm fond of either. However, you may come across global variables from time to time on existing projects. They were popular once upon a time ago. It's good to know how they work. In the next lecture, let's keep talking about variables. In this lecture, we're going to discuss static variables. One thing to understand about functions is that variables are deleted after the function finishes running. Let's look at an example. In our script, replace the current example with a function called foo. Inside this function, let's create a variable called a with an initial value of 1. Lastly, let's return the variable with the increment operator. After defining the function, let's call it 3 times with a break element. In the preview, the number appears 3 times. However, it's the same number. In our function, the variable's initial value is 1. After the value gets returned, the number should update by 1, resulting in the variable changing its value to 2. Here's the thing. PHP destroys the variable after the function is finished running. As a result, calling the function again resets the variable. This is why we're getting the same output. This behavior is beneficial. Most of the time, we don't need the variable to stay around after the function is finished running. It's nice that PHP performs some cleanup for us. In some cases, you may want to keep the variable around after the function is finished running. This feature is especially useful when you're writing code that requires a lot of resources. Creating variables can easily become an expensive operation. The more data you have, the longer it can take to run a script. To avoid wasting resources, we can use static variables. Static variables are variables inside functions that retain their value after the function is finished running. We can create a static variable by adding the static keyword before the variable name like so. After adding this keyword, the output changes. Instead of the same number, the number slowly increments to 3. Using the static keyword is incredibly powerful for keeping our programs efficient. I'm sure you'll find it useful. In the next lecture, let's get into a discussion on anonymous functions. In this lecture, we're going to explore a strange topic that may be hard to wrap your head around. I'll try my best to explain it. So, what am I talking about? I'm referring to a feature called anonymous functions. An anonymous function is just a function that doesn't have a name. As always, let's look at an example. In our script, replace the contents with a function called multiply. This function will accept a parameter called num. Inside the function, let's return the num parameter multiplied by 2. Lastly, let's invoke the function with a random number. The function is pretty straightforward. We're multiplying a number by 2. Nothing fancy so far. Believe it or not, PHP allows us to store a function from within a variable. Doing so is very simple. First, we must convert the function into an anonymous function by removing the name. After removing the name, the preview generates an error. The reason is simple. Anonymous functions are considered to be expressions. Like most expressions, we must end the line of code with a semicolon character. Typically, this character can be omitted when using curly brackets for blocks of code. However, this is the exception to the rule. Since we have an expression, it's perfectly acceptable to store the function from within a variable. Let's set the function to a variable called multiply. We can invoke the function like any other function. However, we must include the $sign character at the beginning of the function name. After applying those changes, our code works like before. We're able to reference a function from a variable. But why would we want to store a function in a variable to begin with? There are two advantages to doing so. Firstly, the function can be swappable. Previously, we weren't allowed to define a function twice. If we had two functions with the same name, PHP would throw an error. However, since variables can have their values updated, we can easily swap this function with another function. For example, after defining the multiply variable, let's try updating its value to another anonymous function. It's going to have the same parameters and return value. However, we're going to multiply the num parameter by 3 instead of 2. In the preview, the page outputs a different value than before. This is because it's using our new anonymous function instead of the previous function. Replacing functions is a powerful feature. It allows us to alter the behavior of our application at a moment's notice. The second reason this feature is useful is because it implies that a function can be passed onto another function as an argument. Let's look at an example. First, I'm going to remove the second anonymous function. It isn't necessary anymore. Next, define a function called sum. It's a function we've defined before. It'll accept two parameters called a and b. Lastly, we'll return the result by adding them together. It's a pretty standard function. We can expand on this function by allowing developers to pass in an additional function to modify the result. In the parameter list, add a parameter called callback. Before going any further, let's talk about the idea of a callback. The idea of a callback is not specific to PHP. It can be applied to various programming languages. A callback is a function passed into another function that can be called later. It's like if you gave your phone number to someone so that they can call you at a later time. It's the same idea, but with functions. You're passing in a function that will be called at a later time, hence why it's called a callback function. If you ever define a function that accepts a callback, it's standard practice to name the parameter callback. A lot of developers adopt this practice. We'll be following it too. After adding this parameter, let's wrap our calculation with this function. Next, let's update our echo statement to pass in another function. It just so happens that we have a function called multiply that we can use. Now, if we look at the page, a new number gets produced. We're adding the numbers passed into the function and multiplying the result by 2. Best of all, we're able to swap callback functions with different functions. One moment we may want to multiply the result. Another moment we may want to divide the result. Since we're not tied to a specific function, we can easily change the result without directly modifying the original function. Using anonymous functions gives us this power. There's another advantage to using anonymous functions. They can access global variables without directly modifying the original value. Let me show you what I mean. Above the multiply function, define a variable called multiplier with an initial value of 2. Next, let's replace the number that gets multiplied against the number parameter with the multiplier variable. Now we have a variable for changing the number that gets multiplied against the parameter. This makes things more flexible. However, as we know, variables defined outside of the function can't be used. One solution would be to use the global keyword, but there's an even better solution. After the parameter list, add the use keyword. The use keyword provides access to variables outside of the function. We can add a pair of parentheses, followed by a list of variables to grab, separated by commas. Let's include the multiplier variable. You may be wondering, how is this any better? Here's the interesting thing. PHP creates a copy of the variable instead of directly giving us access to the original variable. For example, in the anonymous function, let's change the multiplier variable to 5. If we look at the preview, the code is working. Unlike before, the number is even higher. This is because we're modifying the multiplier variable to a larger value. However, the multiplier variable is just a copy of the original. At the end of our code, let's add a line break element and echo the multiplier variable. As you can see, the multiplier variable retains its original value. We don't suffer from the problems of a global variable, where the value does get modified after the function finishes running. It's much safer to use anonymous functions. There's one last thing I want to show you before moving on. In PHP 7.4, arrow functions were introduced. They're a shorter way of writing anonymous functions. Let's convert our anonymous function into an arrow function. It's very easy to do. First, change the keyword from function to fn. Next, replace the use keyword with a fat arrow. Fat arrows are written with equals greater than characters. Afterward, we can remove the curly brackets and return keyword. That leaves us with the expression. Arrow functions are just one line of code. To the right of the arrow, the code must be an expression. This is because arrow functions must always return a value. We don't have to include the return keyword because PHP already returns the value. In addition, the use keyword does not need to be included. Unlike regular or the other version of anonymous functions, arrow functions have access to variables from the parent scope. If we look at the preview, we get the same result as before. Arrow functions are shorter and easier to write, but there are some caveats. Firstly, we must always return a value. Anonymous functions don't have to return a value, but arrow functions do. Secondly, arrow functions can only contain an expression. We can't add curly brackets to add additional logic. We're restricted to a single line of code. As long as you keep these points in mind, I think you'll be fine. In the next lecture, let's keep talking about functions. In this lecture, let's talk about the callable type, which is a type we avoided during our discussion of data types. The callable data type is a data type you can use for callback functions. Let's keep working on our example from the previous lecture. We have a function called sum with 3 parameters. The first 2 parameters can be annotated with the integer and float types as a union type. But what about the callback parameter? In this case, we can use the callable type. By using this type, we're telling PHP that this parameter will store a function. Looking at the preview, everything is working as it did before. There are different ways of passing in a function. The first approach is to store the function in a variable, and then pass it in like we're doing currently. Another way of doing it is by just passing the function directly from the function invocation. For example, let's copy and paste the value of the multiply function into the sum function like so. This time, we're directly passing on the function. It's common practice to write the function directly from within the function call. If you don't plan on using the function elsewhere, it can be convenient to just write it here. In the preview, our code is still working. The last approach would be to just pass in a regular function. Regular functions are accepted too. Below the multiply variable, let's define a regular function called another multiply. It's going to have the exact same logic as the first multiply function. In this example, I'm not using the multiplier variable for the sake of simplicity. Next, in the echo statement, we can replace the arrow function with a string that contains the name of the another multiply function. If we plan on using a regular function, we can pass in the name as a string. PHP handles finding and calling the correct function. In the preview, everything is working as it did before. Overall, the callable type is the correct type for parameters that store functions. In the next lecture, let's get into a discussion on references and values. In this lecture, we're going to learn how to pass on a value by reference. This concept tends to be confusing for beginners. It can be difficult to wrap your head around, Before we get into a code example, let's look at a common analogy that I think perfectly explains passing by references. First, let's talk about how a regular parameter works. Throughout this course, we've defined a few functions with parameters. Every time we pass a value to the function, PHP creates a copy of the value that gets stored in the parameter. If we modify the parameter, only the parameter's copy of the value gets modified. The original value remains unaffected. In this example, let's imagine we had a variable called cup defined outside of a function. Next, we may have a function called fillCup. If we pass the cup variable to this function, the fillCup function is going to store a copy of the cup. If the function fills the cup with coffee, only the copy gets affected. The original cup variable remains empty. This is the default behavior for parameters. We refer to this behavior as pass-by-value. On the other hand, pass-by-reference works differently. Passing a variable by reference changes the default behavior. Instead of creating a copy of a variable, we have direct access to the original variable. In this example, the cup variable gets passed into the fillCup function. If the fillCup function affects the cup variable, the original copy gets affected. Hopefully, this gives you a better idea of how passing by reference and passing by value work. Let's start looking at a code example. In our script, let's replace the current code with a fresh example. Actually, let's try recreating the example from the image I just showed you. Define a variable called cup. Its initial value will be a string that says empty. Next, define a function called fillCup with a parameter called cupParameter. Inside the function, let's update the cupParameter variable to filled. After defining the function, call the fillCup function with the cup variable. Lastly, let's echo the cup variable. As expected, the cup remains empty. This is because the cupParameter variable is a unique copy of our cup variable. Modifying this parameter only affects the variable inside the function. The original cup variable retains its original value. What if we don't want to create a unique copy? We may want to continue using the original copy. In this case, we can add the ampersand character before the parameter name like so. This time, if we look at the preview, the cup has been filled. PHP is no longer creating a unique copy of the variable. The function can directly modify the original variable. So, you may be wondering, how is this any better than global variables? Isn't modifying variables outside of a function bad? One difference between global variables and variable references is the flexibility offered by references. Let's say that I was out dining with friends. Each of my friends can have a cup, so I'll change the variable name to my cup. Next, I'll create another variable called my friend's cup with the same value. Now we have two cups. In the function, if we were to use global variables, I would have to list out every cup that I want to modify. As you can imagine, this is not scalable. What if we had 20 cups? Listing each variable is not efficient. Instead of using global variables, references are much easier to work with. We can call the function for each variable. Even better, we don't have to call the function for each cup. Some cups can just remain unfilled. Alternatively, we may have another function for filling the cup with juice instead of coffee. Overall, passing by reference gives us the flexibility to pass in any variable instead of passing in a specific variable. Hopefully, that makes sense. In the next lecture, let's start using our newfound knowledge of functions to talk about arrays. In this lecture, let's explore the various functions for arrays. Arrays are extremely popular in PHP development. If you think about it, almost everything is a collection of data. We can have a list of posts, products, users, transactions, etc. So many of the sites we visit present at least one list. You're very likely to work with arrays on almost every page you create. In the resource section of this lecture, I provide a link to an official list of functions for arrays. Arrays are so popular, PHP offers dozens of functions for working with them. Almost any type of action you'd like to perform on an array can be performed with PHP's functions. I said this before, but it bears repeating. You won't be able to memorize every function offered by PHP. However, there are some functions that you'll likely use more than others. This lecture covers some of the most common functions for working with arrays. Let's get started. Switch over to Replit. Replace the current codebase with a variable called users. This variable will be an array of names. I'll add the following names: John, Jane, and Bob. One of the most common scenarios is to check for an existing item in an array. As we know, PHP throws errors if we attempt to access an item in an array that doesn't exist. To avoid this issue, it's common practice to check that an item exists before doing anything else. PHP offers two functions for this scenario. The most common function to use is called isSet. Below the variable, add a conditional statement with the isSet function. This function checks that a variable has a value. It's not exclusive to arrays. We can use it to check for strings, integers, floats, and booleans. Let's check if the first item in the users array has a value by passing in users0. Inside the conditional block, let's echo a message that says user found. In the preview, the user was found. The isSet function returns a Boolean value based on whether the user could be found. Everything works, but there is one thing we need to be aware of. What if we change the index from 0 to 3? As expected, nothing appears because there isn't an item in the third index. Let's try adding null to the array. Despite adding a new item to the array, a user hasn't been found. Technically, there's an item in the third index. However, the isSet function considers null and false values to be the same thing as not having a value in that index. You may disagree with that behavior. For this reason, PHP introduces a completely different function for performing a similar task as the isSet function called ArrayKeyExists. Unlike the isSet function, this function is designed for arrays only. Let's replace the condition with this function. This function has two parameters. The first parameter is the index, which can be a string or integer. Let's pass in 3. Next, we must pass in the array itself. Let's pass in the users array. This time, the user has been found. The ArrayKeyExists function allows for null or false values. As long as there's a value in a specific index, the function returns true. Let's move on to another function. In our array, we have a null value. It's not uncommon to have values in your array that you don't want to keep around. PHP has a function called ArrayFilter for filtering items out of an array. Let's replace the conditional statement with a reassignment of the user's variable. Set the variable to the ArrayFilter function. This function accepts the array to filter. Let's pass in the user's array. Lastly, let's print the contents of the array by using the printr function. For a cleaner output, I recommend echoing pre-tags around the printr function like so. They're incredibly useful for formatting arrays onto the page. Instead of the entire array being printed on a single line, each item gets put on a single line. Looking closely, the null value is absent from the array. By default, the ArrayFilter function removes items with empty values like null or false. However, we may want to customize this behavior. In the resource section of this lecture, I provide a link to this function. If we look at the function definition, this function has a few parameters. I want to focus on the second parameter. Let's take a close look at the data type. It's set to callable. As we know, the callable data type is a data type for callback functions. PHP uses callback functions to allow other developers to customize the behavior of its own functions. If you were to read through the documentation, the callback function can be used for customizing the filtering behavior. Let's give it a try. Back in our script, pass in an arrow function as the second argument to the array filter function. In this example, let's try removing Bob from the array. In some cases, we may want to exclude specific users. So, filtering a specific user isn't out of the question. Behind the scenes, PHP loops through our array. Our callback function will be called on each iteration, during which we can accept the user as a parameter. Let's call the parameter user. Our callback function must return a Boolean value. If true is returned, the item stays in the array. Otherwise, it'll get removed. Let's return the following. User does not equal Bob. As long as the value is not equal to Bob, the value can stay in the array. Looking at the preview, Bob was successfully removed. One thing you'll notice is that the index between 1 and 3 is skipped. PHP does not reindex the array. As a mini exercise, I'll let you try to fix this problem. We already talked about a function that can be used for reindexing values. Let's move on to another function. Sometimes we may not want to filter values. However, we may want to make adjustments to each value in an array. The array map function allows us to do just that. Let's replace the array filter function with the array map function. Next, the array map function accepts the array as the second argument. So, let's swap the parameters by moving the user's array as the second argument. Afterward, change the expression to the following, string to upper user. Similar to the array filter function, the array map function accepts a callback function. Every value in the array will be looped through. On each iteration, our callback function will be called with each value in the array. We can use this opportunity to modify the value. In this example, we're using a new function called string to upper. It'll convert lowercase letters into uppercase. In the preview, the names have been updated to all uppercase letters. Perfect. We're able to modify the values instead of filtering them. In some scenarios, we may want to merge two or more arrays. For example, let's say we were creating an application for tracking expenses. You may allow users to upload documents with their expense reports. Since multiple reports can be uploaded, you may have multiple arrays of data. Dealing with multiple arrays can be a hassle, so merging them into a single array is the best way to go. PHP offers a function for merging arrays called ArrayMerge. Let's replace the ArrayMap function with this function. Next, we must pass in our arrays. In the resource section of this lecture, I provide a link to the ArrayMerge function. Take a close look at the definition. Notice anything significant? The ArrayMerge function is a variadic function. It has a single parameter with the spread operator, meaning that the function can accept an unlimited number of arrays. Let's head back to our editors. Pass in the user's array. Next, let's create an array on the spot. In this array, insert two users called Sam and Jessica. In the preview, Sam and Jessica have been added. Perfect. There's one last thing I want to show you. Sorting arrays is another task we may want to perform. In the resource section of this lecture, I provide a link to a function called sort. The sort function does exactly as it sounds. It'll sort the contents of an array. Before using this function, there's one thing worth highlighting. Thus far, every function has returned a brand new array. This time, the function definition tells us otherwise. Unlike before, this function returns a Boolean value. So, how are we expected to grab the sorted array? Taking another look, the first parameter gives us our answer. There's an ampersand character before the name. This character tells us that the parameter accepts a reference to the variable. We can safely assume that this function modifies an existing array directly. It does not store a copy of our array. This is important to understand. Not all of PHP's functions return a new value. Some of them may want to modify an existing variable. The only way to know is to read the documentation and function definition. Let's give this function a try. Back in our script, call the sort function after merging the arrays. Pass in the user's array. In the preview, the array has been sorted alphabetically. In addition, the names can be found under new indexes. Previously, Jessica's index was 5 because she was the last name to appear in the array. This time, her index is 3. Not only were the values rearranged, but the indexes were affected too. You may not find this behavior desirable. What if we had an associative array? Our named indexes would be thrown away. In the resource section of this lecture, I provide a link to a documentation page with an official list of sorting functions. Sorting is a common action. PHP does not assume how you want to sort your values. For this reason, dozens of functions are offered for sorting arrays differently. If we scroll through the page, we'll come across a table of these functions. Some functions can sort by using the value or the key. Other functions can maintain the original key of the value or reindex the array. Lastly, functions can sort in ascending or descending order. If a function doesn't satisfy what you're looking for, PHP offers an alternative solution. We're looking for a function that sorts an array by its value in ascending order while maintaining the original key. According to the table, the asort function seems like a perfect fit. Keep in mind, the table only provides a summary of what each function does. I highly recommend checking out the individual documentation pages for each function to truly understand what it can and can't do. Let's try using the asort function. Back in the script, replace the sort function with the asort function. The preview generates the same array as before. The names are sorted alphabetically. The main difference is the keys. Jessica retains her original index, which was 5. Everything is working as intended. Hopefully, this gives you an idea of what can be done with arrays. We can't cover every function, but we can go over the most common ones. As we progress through the course, I'll be sure to introduce additional functions. For now, these functions should suffice. In the next lecture, let's explore another feature of arrays. In this lecture, we're going to explore a feature to help us improve readability. Arrays can have dozens of values. It's common to extract a single value from an array and store it in a variable. This is known as destructuring. Let's look at an example. In our script, let's replace the current code with an array called numbers. Fill the array with random numbers. Next, let's write the following. List A equals numbers. The list keyword can be used for grabbing items from an array. PHP will store them with the variable names written inside the list keyword. The order does matter. The first variable gets assigned the first value in the array. We can add more variables by separating them with commas. For example, I'll add a variable called B. This variable will store the second value in the array, so on and so forth. It's not required to provide a variable for each item. Let's echo the A variable. As you can see, we get the first number from the array. There's an alternative syntax for destructuring an array. Rather than wrapping the variable with the list keyword, we can use a pair of square brackets. This shorthand syntax produces the same results. The last thing I want to show you is destructuring arrays with key names. Let's update the array by setting the index of the first variable to example. Next, in our destructuring, we can grab the variable by referencing the key name followed by a fat arrow and variable name. If we decide to destructure variables by specific keys, all variables in the destructuring must also use specific keys. So, for the B variable, set the key to 0. In the preview, the variable continues to work. Destructuring can be handy because it allows us to assign a specific variable name to a value in an array. It makes our code readable and concise. In the next lecture, let's discuss one final topic for this section. In this lecture, let's talk about the file system. In the resource section of this lecture, I provide a link to PHP's official list of file system functions. PHP offers dozens of functions for interacting with the file system. You can perform operations from reading the file size to creating new files. Let's give some of these functions a try. Switch over to Replit. Replace the contents of the file with a variable called directory. Its value will be a function called scan directory. Typically, you're going to want to scan a directory for a list of files. The scan directory function performs this exact action. There's one argument, which is the directory to scan. Luckily, we don't have to guess the directory we're currently in. We can use the directory magic constant we learned about in an earlier lecture. As a reminder, this constant points to the directory of the file it's being used in. The return value of this function is an array. So, let's print the contents of the directory variable with the printr function. In the preview, we're given a list of files. You should see most of our files, including the hidden files created by Replit. There are two items in the array that may be mysterious. Looking closely, the first two items of the array are a dot and two dots. Every time you scan a directory, every directory is going to have these two items. A single dot refers to the current directory, whereas the two dots refer to the parent directory. Keep this in mind, as you're not just going to be presented with the files in a directory. These items will always appear in your array. Moving along, let's try creating a new directory. Replace the current code with a function called mkDirectory. The letters mk are short for make. This function accepts the name of the directory as a string. Let's set the name to foo. If we run the file, nothing appears in the preview. However, if we look at the file tree from the sidebar, a new folder has been created called foo. Next, let's try replacing the function with a function called rmDirectory. rm being short for remove. After refreshing the page, the foo directory disappears. We can use this function for deleting directories. There is one thing to keep in mind when deleting directories. The directory must be empty before being deleted. If we attempt to delete a directory with files, PHP throws an error. So, keep that in mind when deleting directories. Let's start exploring functions for interacting with files. Before working with a file, you should check that it exists. Otherwise, any action you perform may not work as expected. In our script, replace the function with a conditional statement. The condition will be a function called fileExists. The fileExists function can be used to check for the existence of a file. We must pass in the name of the file as a string. Unlike before, we don't need to provide a full system path. It's perfectly fine to write a path relative to the current directory. For example, let's try checking if a file called example.txt exists. If it does, we'll echo a message saying file found. In the preview, nothing appears because we don't have a file called example.txt. Let's try creating this file from within our project. Make sure it's in the same directory as the index.php file. Next, if we refresh the page, the message appears. Great! We're able to verify that a file exists. Let's try checking the file size. Replace the expression for the echo statement with the file size function. As you might expect, this function returns the size of a file. Let's pass in the example.txt file. In the preview, the number 0 gets rendered. That's to be expected since I didn't write anything inside the text file. Let's try writing content into the file. PHP has a simple function to perform this task. After the echo statement, run a function called FilePutContents. Two pieces of information must be passed in. Firstly, we must provide the file name, which is example.txt. Next, we must provide the contents we'd like to insert into the file. Let's write Hello World. Lastly, just to verify that our function worked, let's echo the file size again. If we refresh the page, everything seems to have worked, but there's just one problem. The number 0 gets outputted twice. At first glance, it can seem like PHP didn't update the example.php file. Let's take a peek inside the example.txt file. Surprisingly, the value has passed into our function. So, why is PHP saying that the file size is 0 bytes? The reason is simple. Behind the scenes, PHP caches the results returned by some of the file system functions. By calling the file size function before updating the file's contents, the result gets cached. If we attempt to call the file size function again, we're going to get the previous result. PHP does not bother rechecking the file for a new file size. Checking file data can be an expensive action. For performance reasons, PHP reuses the original result. This behavior is beneficial to us, but in this case, it's a problem. Luckily, we can reset the results. In the text file, clear the contents. Back in the PHP file, after updating the file's contents, call the clearStatCache function. The clearStatCache function clears the cache. Therefore, PHP attempts to reread the file size. In the preview, 0 gets rendered in the output, followed by 11, thus indicating that the file size was updated. Perfect. This is something to keep in mind. If you're constantly reading file data, you may be returned older results instead of newer results. You can avoid this behavior by calling the clearStatCache function. Let's explore one more function. Instead of outputting file size, let's grab the contents of the file. For the second echo statement, replace the file size function with the FileGetContents function. In the preview, the text from the file appears. It's as simple as that. The FileGetContents function just accepts the name of the file. It'll return the file contents as a string. Hopefully, this gives you a better idea of how we can work with files in PHP. That concludes this section. We've explored dozens of PHP's features. Now that we have a solid grasp of PHP, it's time to take things to the next level. We're going to start talking about object-oriented programming. Before we do, I have a few challenges for you to take on to reinforce what we've learned. So, when you're ready, I'll see you in the next section. In this lecture, I want to give you some tips and tricks for the next set of challenges. I won't lie to you. These challenges are going to be tougher than the previous challenges. There's one big reason for that. In order to solve these exercises, you're going to have to use functions we haven't gone over. I know that seems unfair, but I did it for a specific reason. There isn't a course or book on this planet that can go over every function or solution. You're going to have to take the time to look up solutions online to solve specific problems. With that being said, most of these challenges can be solved with a few lines of code and a bit of research. Hopefully, you paid attention to the lectures where I talked about reading PHP's documentation. Those skills are going to come in handy. However, I know that not everyone feels confident with their skills. Don't worry, I decided to add hints to these exercises. If you don't want to be spoiled, I recommend heading on to the next challenge. For the rest of you, let's go over what you can expect to find in the hints. On Udemy, the hints can be found on the left sidebar under a section called Hints. If you're watching this on YouTube, the gist that contains the exercise has a section with a similar name that you can check out. Currently, I'm viewing the next exercise, which is the robot name exercise. The overall goal of this exercise is to write a function that generates a robot name with a specific format. I'll let you read the description when you get to it. Under the Hints section, I provide a list of steps and functions that you can use to tackle this challenge. Keep in mind, there's more than one way to solve a problem. If you end up using a different solution, that's fine. The steps outlined in the exercise are what I would do. So, be sure to check out the documentation for each of these functions and learn how they work. You can expect similar hints for the other exercises. However, the last exercise has a bit of a curveball. Let's take a look at the series exercise. If we click on the Hints section, one of the hints I provide is an instruction to search for a function. Rather than giving you the function's name, I provide a search query you can use to search for that function. Realistically, you're not going to be able to remember every function name. Learning how to search for functions is an invaluable skill you can pick up. When you get to this exercise, I want you to search for a function with this phrase. The function that pops up in the results will be useful. It'll be up to you to look through the results to learn what the function is. One of the most important things worth highlighting about this search query is the word PHP. PHP is not exactly a unique programming language. A lot of its features can be found across multiple programming languages. If you were to search online how to count the number of characters in a string, you might get results related to another programming language. I always recommend including the name of the programming language whenever searching for a solution. Alright, that's all I have to say. If you have trouble with the exercises, don't worry. They're meant to be challenging. I'll be sure to walk through each exercise with my solution. All I want you to do is try your best. When you're ready, I'll see you in the next lecture. Good luck. In this lecture, let's review the solution for the robot name exercise. According to the description, our job is to generate a name for robots in a factory. Their names must follow a specific format. The first two characters of the name must be uppercase letters followed by a 3-digit number. The most important step is to generate completely random names each time the function is called. Let's look at the Hints section. I've outlined the steps you should take to complete the exercise. First things first, we must generate an array of valid letters. Before generating a random letter, we must have a list of possible letters to randomize. One solution is to create an array with each letter. In the code, we have a single function called getNewName. Inside the function, define a variable called letters with an initial value of an array. In this array, we can start adding individual letters like so. This is a completely valid solution. If you created an array like this, that's great. However, the one thing I don't like about this approach is manually inputting the letters. It also looks cluttered. In the future, we may want to include lowercase letters. Rather than manually writing each letter in an array, we can use a function called range. In the Hints section, I've provided a link to this function. Let's check it out. According to the description, this function can generate an array containing a range of values. The range of values can be configured through the parameters. Let's scroll to the Examples section of the documentation page. I find that by looking at the examples, it's possible that a solution is already available for what I want to do. Looking closely, the third example has something similar to what we're trying to do. The range function generates an array of letters ranging from A to I. It's not uncommon to tweak examples specific to your needs. In this case, this example can be adjusted to uppercase letters and extend the range from A to Z. Let's give it a try. Back in our editors, replace the array assigned to the letters variable with the range function. This function accepts the starting and ending range. Let's pass in A and Z. Just like that, we have an array of letters. The next step is to randomize the letters. Currently, the range function produces an array in alphabetical order. Before we can grab a random letter, the value should be moved around in a random order. Luckily, there's a function for performing this exact action. In the list of functions, click on the Shuffle function. The Shuffle function performs shuffling, which is another way of saying randomizing the values in an array. If we look at the function definition, there's one piece of information worth noticing. The array parameter is passed in by reference. If we pass in the letters array, our array will be automatically updated. We don't need to reassign the value. Let's try using this function. Back in our script, call the Shuffle function with the letters array. We're almost finished. According to the outline, the next step is to generate a random number containing 3 digits. Unlike before, we don't need an array of possible numbers. PHP has a function for generating random numbers called mtrandom. After the shuffle function, create a variable called number with the following value, mtrandom 100,999. The mtrandom function accepts 2 numbers, which are the minimum and maximum threshold. Once we've got the random number, the last step is to return our results. I'm going to be using string interpolation, but string concatenation works just as well. Let's return the following: letters 0, letters 1, number. In this example, we're grabbing the first 2 letters from the array. Lastly, we're adding the number. That's it. Let's try running the tests to see if our function passes. After a few moments, the test passed. Great! We've got a function for generating a random name for a robot. If you would like, you can try improving the current implementation. For example, you can try adding support for lowercase letters. Alternatively, you can allow duplicate letters to appear in the name. Lastly, you can prevent the function from generating the same name twice. It's unnecessary to do these things, but it can be a good way to challenge yourself. In the next lecture, let's jump into another exercise. In this lecture, let's work on solving the Armstrong numbers challenge. An Armstrong number is a number that is the sum of its digits, each raised to the power of the number of digits. In the description, I give a few examples as well as a link to more information. The code snippet contains a single function with one parameter, which is the number to check if it's an Armstrong number. Our function must return a Boolean. If the number is an Armstrong number, the function should return true, otherwise false. To accomplish this task, we must begin by splitting the given number passed into an array. In the array, each number should be inserted as an individual item. Therefore, we must convert the integer into an array. For this portion of the exercise, we can use a function called string split. In the function, create a variable called digits with the value set to string split. This function takes in a string and splits the string by each character into an array. Let's pass in the number parameter. There's just one problem with our line of code. Let's look at the documentation for the string split function. In the documentation, the string parameter is annotated with the string data type. However, we're passing along an integer. Typically, PHP would perform type juggling, but that's not going to work in our script. Back in the editor, strict typing is enabled. PHP is going to throw an error at us for passing in an integer when the function expects a string. To get around this dilemma, let's typecast the number parameter into a string like so. As we know, integers are casted into strings as is. PHP simply wraps the value with quotes. The original number does not get lost, so it shouldn't be a problem to typecast the parameter into a string. This is important to keep in mind. If you're going to be using PHP's function while enabling strict typing, it's always worthwhile to check the parameter's data types to avoid errors. It's time to start looping through the array. We must perform exponentiation on each of the digits with the number of digits in the array. At the same time, we must store an array of results. I think this is the perfect opportunity to use the array map function. Set the digits variable to the array map function. Next, pass in an anonymous function. Technically, we could use an arrow function to solve this exercise. However, Udemy doesn't support arrow functions, so if you tried to use an arrow function and encountered errors, that's why. The callback function will be called on each iteration of the loop. We can accept the value from the current iteration as an argument to our anonymous function. Let's refer to it as digits. Next, we need to calculate the exponentiation. Return the following: digit exponent count digits. This solution works, but can be improved. Let's take a moment to think about this solution. Every time PHP loops through our array, it's going to perform this expression. Before a value can be exponentiated, PHP must wait for the count function to return a value. If we consider it, the count function always returns the same value. After all, the digits array doesn't change. It would be better if we outsource the value returned by the count function into a variable outside of our array map function. Let's give that a try. Below the digits variable, define another variable called digitCount. Its value will be the count function from the array map function. Next, let's use our digitCount variable in the return statement. Lastly, we must add the use keyword to access variables defined outside our anonymous function. Inside the parentheses, add the digitCount variable. The results will be the same, but this solution is much more efficient. With a simple adjustment, our anonymous function doesn't have to wait for the count function to finish running. It's a small optimization, but an optimization nevertheless. Afterward, let's pass in the digits array to the array map function as the second argument. There's one last step. We must verify the sum of the digits is equal to the number passed into the function. At the end of our function, return the following: array sum digits equals number. The array sum function loops through an array, calculating the sum of all the numbers. Now, hold on a moment. Isn't our array an array of strings? Initially, yes, because of the string split function. However, in the array map function, we're using the exponentiation operator, which produces an integer. Therefore, all numbers are converted back into integers. Just like that, we've got a working function. Let's try running the script. Udemy has passed our function. Awesome! We've successfully created a function for checking an Armstrong number. If your solution looks like mine, that's great. If you did something else, that's also fine. As long as you got something working, that's what matters. In the next lecture, let's tackle one more exercise before learning more PHP. In this lecture, we're going to walk through the final challenge of this section. The goal of our function is to create an array of numbers based on a single number. In the description, I've provided an example. Let's imagine we had the number 49142. I may want to grab portions of the number. Let's say I wanted numbers in groups of 3. 491 would be the first group. 914 would be the second group. Lastly, 142 would be the last group. I'm simply grabbing the first 3 numbers. Next, I'm moving over 1 to grab the next 3 numbers. I continue to do so until I reach the end. If I wanted to grab numbers in groups of 4, the same group of numbers would give me 2 numbers. Our function has 2 parameters, which is the initial number and the size of each group. Let's get started. Click on the Hints section from the exercise. As always, I've provided instructions for writing a solution. Unlike before, I decided not to include every function that you'll need. Instead, I've provided a search term to help you search for a function you'll need. We'll talk about it in a moment. In our function, the first step is to validate the data passed into the function. As noted in the description, if the size is larger than the number itself, we should return an empty array, since we can't produce results when the size is too big. Vice versa, if the size is less than 1, we'll also return an empty array. Before we can check the size, we must grab the length of the number. In the hints, you must search for how to get the number of characters in a string in PHP. Here's what you should be presented with. You may get different search results based on when and which search engine you're using. All the search results are unanimous. We must use a function called string length. Feel free to read each page listed in this search. Most importantly, you should check out the documentation page for the functions recommended by the search results. Let's give the string length function a try. Back in the editor, add a conditional statement. The condition will be the following: size greater than string length series, or size less than 1. There are two conditions. The first condition we've written checks if the size parameter exceeds the number of characters in the series parameter. The other condition checks if the size parameter is less than 1. If either condition evaluates to true, let's proceed to return an empty array. Otherwise, we can proceed with grabbing groups of numbers from the original number. Below the conditional statement, create a variable called results with an initial value of an empty array. This array will be responsible for storing the results. The next step is to start populating the results by looping through the number. The question is, which loop should we use? Well, since we don't have an array of values to loop through, I think we should use a loop that runs based on a condition. Add a for loop. First, let's initialize a variable called I with an initial value of 0. Next, write the following condition: I less than equals string length series minus size. The condition we've written checks if the I variable is less than or equal to the length of the series parameter minus the size parameter. We're going to use the I variable to help us set the starting position of where to grab a number from the string. As long as the I variable is smaller than the expression on the right, there's room for grabbing numbers. Once we exceed this point, there aren't enough numbers left to grab. Lastly, let's increment the I variable. Our next step is to start adding a group of numbers to the results array. A portion of a string is known as a substring. This concept is not specific to PHP, but can be found in most programming languages. PHP has a function for grabbing portions of a string called substring. Let's add a new item to the array by adding a pair of empty square brackets. Set the value to the substring function. This function has 3 arguments. The first argument is the original string. In our case, this would be the series string. Next, we must pass in a starting position. Where should PHP start grabbing the string? Keep in mind, the first character has an index of 0. The second character has an index of 1. We always want to start from the beginning when the loop runs for the first time. During the second iteration, it should start from the second character, so on and so forth. It just so happens that we have a variable that slowly increments, which is the I variable. Let's pass that in. Lastly, we must provide how many characters to grab from the starting position. This information is available via the size parameter. That should do it. The last thing to do is to return the results array. Before testing our code, there's one more thing we should do. You may have noticed it already, but we're calling the string length function twice. Actually, we're calling it from multiple times from our loop. If you were screaming at me from behind your screen, don't worry, I wasn't going to let this mistake slide. This is a good opportunity to point out that your code may not always be optimized the first time around. When you're trying to solve a problem, it's important to just solve the problem. If, along the way, you write unoptimized code, that's perfectly fine. The most important thing is to revisit your solutions before shipping code to production. This is more common than you think. If you optimize too early, you may find yourself disappointed because the solution you thought of isn't suitable for the problem you're trying to tackle. As a result, you've wasted time optimizing code that wouldn't have worked to begin with. Above the conditional statements, define a variable called series length. Its value will be the string length function with the series variable. Next, update our conditions to use this variable instead of calling the string length function directly. There's another optimization that we made without realizing it. It's not optimized for performance, but for readability. Technically, we could wrap this portion of the code with an else block. It's completely valid to do so. However, it's considered good practice to avoid adding an else block if you don't need to. In our case, we don't need an else block since our code produces the same result. By not using an else block, We don't have to indent our code, which can improve readability. Let's try running our script through the test. As you can see, our code works. Awesome. We've successfully completed the exercise. Hopefully, these exercises helped improve your problem-solving skills. In the next section, let's get back to learning PHP. In this section of the course, we're going to get into Object-Oriented Programming, or OOP for short. Object-oriented programming can be a difficult topic to comprehend. It takes everything we've learned so far to another level. So, what is OOP, and why should we learn it? To kick this discussion off, we should discuss the idea of a programming paradigm. It's a big word, but it's just fancy talk to describe a programming style. Programming has been around for decades. Developers have developed styles for how applications should be written over the years. Programming paradigms provide a clear and concise way for how applications can be organized. You can think of them as guidelines for writing a program. Paradigms apply to programming in general. They're not specific to PHP. With that being said, there are 5 popular paradigms you'll come across. They're imperative programming, procedural programming, functional programming, declarative programming, and last but not least, object-oriented programming. For the sake of brevity, we're going to focus on 3 of these paradigms, which are procedural programming, functional programming, and object-oriented programming. Let's start with procedural programming. Believe it or not, we've been following procedural programming for a while now. The idea of procedural programming is to subdivide a program into functions. For example, let's say we were baking a cake. We can divide each step of the process into functions. After defining those functions, we can invoke each function in the order we'd like to perform those steps. The idea of procedural programming is to treat our program as a series of steps. Code is executed from top to bottom. Initially, procedural programming might seem like a great paradigm to follow. However, the biggest flaw with this approach is reusability. Typically, procedural programming leads to duplicating the same functions over and over again. That's something we should avoid to boost productivity. Let's step away from programming paradigms to talk about a concept known as the separation of concerns. This principle is not specific to PHP. We can apply it to any programming language or framework. In fact, we can apply this principle to the real world. Hospitals can employ hundreds of people. There are surgeons, nurses, techs, chefs, janitors, etc. Each person is given a specialized job. Not a single employee performs all jobs. You can apply this concept to almost any industry. Businesses always assign specific responsibilities to each employee. This principle can be applied to programming. The separation of concerns principle states that we should split our logic by responsibility. This principle keeps our code base clean and organized. Object-oriented programming is a style of programming for implementing separation of concerns. I know you can't understand what's going on in the code snippet from this slide. However, the main point I'm trying to convey is that object-oriented programming allows us to split our code by responsibility by using something called objects. An object is a generic term to describe code grouped by responsibility or feature. It's code that shares a relationship with each other. I know that doesn't make much sense. Don't worry. In the next lecture, we're going to start creating objects. The most important thing to understand is object-oriented programming is a style of programming that emphasizes breaking our application into objects. By using objects, we can easily reuse code along with other great features found in object-oriented programming. This entire section is going to be dedicated to object-oriented programming. As we go along, you'll slowly understand why it's a popular programming paradigm. There's one more paradigm I should briefly mention called functional programming. It's similar to procedural programming, with one exception. Functional programming focuses on using functions to build an application. However, functions must be treated as first-class citizens. This is another way of saying that functions can be assigned to variables, passed as arguments, or be returned by other functions. It basically takes functions to the next level. In recent years, functional programming has become more popular thanks to languages like JavaScript. However, for PHP developers, most developers prefer object-oriented programming, so that's what we're going to focus on. In the next lecture, let's get started by writing a class. In this lecture, we're going to create a class. Before we do, we must answer one crucial question. What is a class? A class is a set of instructions for creating an object. You can think of it as a blueprint for building a house. A blueprint contains instructions on how a house is built by providing details on the layout and dimensions. You can't live in a blueprint. It's just a piece of paper with information on building a house. Interestingly, we can build multiple houses based on a single blueprint. But what exactly is an object? Well, if classes are blueprints, then objects would be the physical houses themselves. In the programming world, objects can be anything we want. We can use an object to represent a button on a page, or a user on our site. We have complete control over what an object represents and how it works. Before creating an object, we must define a class. In our project, let's create a new file for containing our class. Create a file called account.php. Inside this file, let's add a keyword called class. As you might suspect, this keyword allows us to create a class. Following this keyword, we must provide a name for our class. Similar to functions, class names must be unique. Let's set the name to account. Lastly, add a pair of curly brackets. There are a few things worth mentioning before moving further. Firstly, the name of the class matches the name of the file. This step is not required. We can freely use any name we wish. However, it's common practice for a class to have the same name as the file for consistency. But why? Most developers agree that a single class should occupy a file, one file per class. Technically, we could add additional logic or define another class. It's not against the rules, but keeps our project maintainable if we know where to find specific portions of code. Secondly, the name of the class uses Pascal casing. Previously, variable and function names were camel-cased. On the other hand, classes are Pascal-cased to help developers identify a class from a function. You don't have to follow these naming conventions, but it's what most developers follow and what you're likely to encounter when opening new projects. Moving along, we have a pair of curly brackets to act as the body of the class. Anything written inside the class belongs to it. For now, we're going to leave the class empty. Our class is ready to be instantiated. One word you're going to come across is instantiate, which describes the process of creating an object from a class. Oftentimes, you may hear developers refer to an object as an instance. The words object and instance are interchangeable terms. However, there is a difference. The copies generated by a class are considered to be objects, whereas a specific copy of a class is considered to be an instance. But, once again, they can be interchangeable terms from time to time. Let's open the index.php file. I'm going to clear the contents of the file for the purposes of this lecture. Next, let's load the account.php file by using the require once keyword. Since the class definition exists in a different file, we must load the file before creating an instance. After the file has been loaded, we can proceed with the instantiation. Define a variable called myAccount, set to the following value, new account. I'm introducing a new keyword called new. This keyword allows us to create a new instance of a class. The class name can be specified after the keyword. Most importantly, the keyword returns the instance, which can be stored in a variable. After storing the instance, we can reference that instance through the variable. Let's give that a try. Below the variable, call the variable dump function with the myAccount variable. In the preview, the variable dump function outputs the contents of the object. Since we didn't include anything in our class, the object is empty. Take notice of the data type. PHP assigns the object data type to instances of our class. This data type gets applied regardless of what class we're using. So, that's how we can create a class. Nothing fantastical, but it's a start. There's one more thing I want to mention before moving on. We're not limited to a single instance of a class. Multiple instances can exist within an application. For example, let's create a variable called John's account, set to a new instance of the account class. We're going to dump the contents of the John's account variable with the variable dump function. In the preview, we're given two copies of the account class. They look similar, but PHP recognizes them as two completely different instances. But why would we want two instances of the same class? Well, classes can contain data, which is unique to each instance. If our account class had data, these instances would have unique copies of that data. Changing data in one instance does not affect the other. This is what makes object-oriented programming powerful. We're able to reuse classes without worrying about affecting other instances of that class. In the next lecture, let's start adding data to our classes to showcase this feature. In this lecture, we're going to start adding data to our classes. Data inside a class is referred to as properties. They're dead simple to add. Let's continue working on the account class from the previous lecture. Inside the class, add the following with me: public name. Two things worth examining. Firstly, properties are really just variables in a class. If we define a variable outside of a class, it's treated as a regular variable. On the other hand, variables defined inside a class are referred to as properties. It's all semantics. Secondly, I'm introducing a new keyword called public. Properties must have something called an access modifier. An access modifier refers to how accessible a variable is from a class. As we know, defining variables outside of a class makes them accessible everywhere. Our variables can be updated from functions or from different files. We don't really have control over where the variable can be updated. That can be problematic. Variables can easily have their values overridden. For this reason, properties, which are variables defined in a class, can limit access as to where a property can be updated. In the resource section of this lecture, I provide a link to the documentation page for access modifiers. We're going to dive deeper into each access modifier. For now, I want to focus on a single access modifier, which is public. If you're interested in more information, check out this documentation page. Head back to our editors. The public keyword instructs PHP that the property can be accessed and updated from anywhere. It's similar to defining a regular global variable. Access modifiers must always be added to our properties. Let's add another property called balance. Unless I state otherwise, you should always assume that a property should be public. After adding those properties, we can refresh the page to view the result. This time, both instances have the properties from our class. Since both properties don't have a value, PHP defaults to null. However, PHP uses a different default value when our properties have data types. At the top of the file, let's enable strict typing with the declare statement. Just in case, let's add the same statement to the index.php file. Great. Back in the account file, let's add data types to our properties. Data type must be added after the access modifier. Let's set the name to string and balance to float. After making those changes, the default values have been set to uninitialized. The uninitialized data type is a special type for properties. If we think about it, our properties cannot be set to null since the data type has been explicitly set. For this reason, PHP sets the value to uninitialized to inform us of a property without a value. With that being said, we are allowed to set a default value. For example, let's set the balance property to 5.5. We're not limited to using simple values. Simple expressions can be used as the value. Instead of using a floating number, let's add 5 plus 5. As you can see, the expression works. However, there are limitations. PHP does not allow us to call functions. For example, Let's set the value to a function called integerValue with a value of 5.5. The integerValue function is defined by PHP for converting a data type into an integer. It's the same as typecasting with the int data type. Typically, this line of code would work for regular variables. However, if we look at the preview, PHP throws an error. Functions cannot be used from within the property definitions. I'll revert the value to a simple number. So, we have a property. The question is, how can we access the value? Let's head back to the index file. In the first variable dump function, add the following after the myAccount variable: minus greater than balance. In the preview, the property gets rendered. We can access a property from within an instance by using an arrow followed by the name of the property. Since our property is public, it's perfectly acceptable to read or update the value. In addition, the property can be referenced without the $sign character at the beginning of the name. It only needs to be included with the reference to the instance. Before logging the value, let's set the balance property on the myAccount instance to a different value. As you can see, our property gets updated. More importantly, take a look at the second object. We only updated the first instance. The second instance retains its original value. This is important to understand. Instances contain unique copies of their data. If we change data in one instance, other instances of the same class remain unaffected. This behavior is the beauty of object-oriented programming. In the next lecture, let's learn of an alternative solution for modifying the default values of a class. In this lecture, we're going to learn about methods. A method is a function defined inside a class. Similar to how variables defined in a class are referred to as properties, functions defined from within a class get referred to as a method. Custom methods are going to be a topic explored in another lecture. For this lecture, I want to focus on magic methods. In the resource section of this lecture, I provide a link to a list of magic methods. A magic method is a function automatically called by PHP. Typically, we're responsible for calling functions after defining them. PHP never executes a method by itself. However, magic methods are different. PHP is capable of calling a function from within our class during specific events. For example, let's explore a magic method called construct. Head over to your editor. In the account class, let's define a function from inside the class. The name of the function must be called the following: __construct. All magic methods start with 2 underscore characters. For this reason, PHP recommends avoiding naming your methods and functions with 2 underscore characters to reduce confusion. After defining the function, add the public keyword. Similar to properties, we can restrict the access of methods with access modifiers. Going forward, we're always going to set our methods to public whenever we define them. So, why did we define the construct method? Well, it turns out that PHP calls this method whenever a class is instantiated. This event gives us the opportunity to set up our class before other methods are called. Interestingly, like any other function, we can add parameters. Let's add 2 parameters called newName and newBalance. Their data types will be string and float, respectively. We're going to use these parameters to update our properties. Inside the function, set the thisName property to newName. Out of nowhere, I've introduced a new keyword called this. You heard that right. The this variable is actually not a variable, but a keyword. As we know, instances contain unique copies of the properties from a class. Since multiple classes can have the same properties, how does PHP know which property to update from which class? This problem compounds even further when we account for global variables. To avoid updating incorrect properties, we can refer to the current instance via the this keyword. The this keyword represents the current instance. As a result, we can access properties like we would any other method. In this example, we're updating the name property. Let's do the same for the balance property by setting it to the newBalance parameter. Next, let's remove the default value for the balance property from the top of the class. There isn't a point in setting a value for this property if we're going to update it when the class is instantiated. After making those changes, we're going to receive an error from PHP. It's stating that we're providing too few arguments to the construct method. As I mentioned before, PHP automatically calls the magic method for you. It's calling the construct method when the instance is created. Whenever receiving the argument count error, the error indicates a function is being called with missing arguments. Despite PHP being the one calling the construct method, it's our job to supply arguments to this method. Let's go back to the index file. So, how do we pass on data while the instance is being created? It's simple. We can add parentheses after the name of the class like so. The parentheses are optional if your construct function doesn't have parameters. For the rest of this course, I'm always going to add the parentheses during instantiation, especially if the construct method doesn't have parameters. It's my personal preference. PHP is not the only language I use. While parentheses are optional in PHP, they're not optional in other languages. Therefore, to be consistent, I'm used to adding them when there isn't data to pass on. Alright, let's pass on data. From my account instance, I'll pass in a random name and number. While we're here, let's remove the second instance, variable dump function, and update for the balance property for the myAccount variable. In the preview, both the name and balance was updated with the values passed into the construct function. By using the construct function, we're able to change the default values of our properties during instantiation. This feature allows us to configure our classes to our specific needs. The construct method is probably the most popular magic method. You're going to be using it frequently. As for the other magic methods, we're not going to be diving too deep into them for this lecture. I'll introduce additional magic methods as we need them. For now, knowledge of this method will suffice. In the next lecture, let's keep exploring the construct method. In this lecture, we're going to look at an alternative solution to setting the values of a property from the construct function. A new feature called Constructor Property Promotion was introduced in PHP 8. It's a shorthand syntax for performing the exact same logic we're performing in the construct method. In our construct method, I'm going to add the public keyword to the parameters of the construct method. For readability, I'll put these parameters on new lines. By adding the access modifier to the method, PHP does two things. Firstly, these are not just parameters anymore. PHP treats these parameters as properties for the class. Secondly, the values for these properties are set with the values passed into the construct method. As a result, we don't need to define the properties at the top of the class. Nor do we need to set the properties from within the construct method's body. We can rename the parameters to name and balance. If we refresh the page, our code works as before. There are three things to keep in mind. Firstly, this feature is only available in PHP 8 and above. If you're using an older version of PHP, you cannot use this feature. Secondly, you must add the access modifier to the property. Otherwise, PHP treats the parameter as a regular parameter. Lastly, you don't always have to use this shorthand syntax. There are cases when you'll want to define the properties but don't want them to be modified through the construct method. If that's the case, you can define additional properties at the top of the class. Not every property needs to be configurable. Alright, that's it for now. In the next lecture, let's start talking about custom methods. In this lecture, we're going to define custom methods for our class. Magic methods are not the only type of functions that can be defined in a class. Custom methods can be created from our class. But why would we want to define a custom function from within a class instead of outside of a class? Let's find out why. In the account class, let's add a function for depositing money into our accounts. At the bottom of the class, define a public function called deposit. Similar to magic methods, Custom methods must have an access modifier. Since the goal of this function is to update the balance, we must accept the amount to deposit. In the parameter list, add a float parameter called amount. Next, inside the function, update the balance property with the amount parameter. For this example, I'm using the shorthand syntax of adding a value to an existing number with the addition assignment operator. As a reminder, we must use the this keyword. This leads us to the reason why we would want to define a function inside a class. Being able to access an instance's properties is probably the biggest advantage of defining a function from within a class. We never have to worry about affecting other instances. Let's try calling this function. Head back to the index.php file. Before dumping the balance, let's call the myAccountDeposit method. Calling a method is similar to accessing a property. The arrow can be used for accessing properties or methods. Let's pass in a random number to the deposit method. In the preview, our balance gets updated. Perfect! We've got a custom method for updating the balance. We can take things a step further with a feature called method chaining. Let me show you an example. What if we want to perform multiple deposits to the same account? After the deposit method, call the same method again with a different value. This solution works, but it can be improved. Typing the variable, followed by the method, can be tedious. It's not uncommon to call multiple methods from the same class. Rather than accessing the instance over and over again, it would be nice if we could call the deposit method immediately after the first invocation. Well, that's possible with method chaining. Head back to the account class. Inside the deposit method, return the this keyword. By returning the this keyword, we can access the instance's properties and methods again after calling a method. Back in the index file, we can shorten our code like so. Here's what's happening. First, PHP calls the deposit function, which increases our balance. Afterward, the instance gets returned from our function. So, we can immediately chain another function since the return value is the instance. In the preview, our balance reflects our actions. Method chaining is a convenient feature for calling multiple methods from the same class. It's not required, but can make your code readable. There's one thing to keep in mind. You should never forcefully return the instance from all your methods. Initially, it might seem tempting since it gives you readable code. However, it can prove to be a problem if your function needs to return other types of data. Generally, you should only return the instance if it's easy to do so. Forcing your functions to return the instance is just a lot of hassle. In the next lecture, let's talk about an operator related to objects. In this lecture, let's talk about the Null-safe Operator to help us avoid errors. Not all variables are going to have an initial value. For example, the myAccount variable may not contain an instance of an account until a later point in our application. So, the initial value of our variable can be null. Unfortunately, that can cause issues. If we attempt to access a method or property on a variable containing null, PHP throws an error. The error states the following: call to a member function on null. Whenever encountering this error, PHP is attempting to tell you that the object you're trying to access doesn't exist. One solution would be to use a conditional statement with the isSet function. If our variable contains a null value, PHP returns false. As a result, the deposit function never gets called, thus avoiding the error. This is a completely valid solution that you may see from time to time in older projects. However, it can be cumbersome to repeatedly type conditional statements. For a while, this was our only solution. Luckily, the PHP team has introduced an alternative, shorter solution for performing the same action. In PHP 8, the Null-safe Operator was introduced. It's easy to use. In our code, before the arrow, add the question mark character to all cases where we access the myAccount variable. By adding the null-safe operator, PHP checks the value on the left for a null value. If the variable is null, PHP does not execute the code on the right. Looking at the preview, the error has gone away. If we attempt to output a variable with this operator, PHP returns null. Keep in mind, this operator is only applicable to objects. We can't use it on variables with other data types, such as strings or arrays. In my opinion, it's easier to read and write code with the null-safe operator instead of using a conditional statement. We'll be using it often in our script. In the next lecture, let's take a moment to talk about namespaces. In this lecture, let's talk about one of the most crucial features of PHP, which are namespaces. Namespaces are entirely optional. You can create an application without ever using custom namespaces. On the other hand, you might want to consider using a namespace to keep your project organized. Let's explore why. First, let's understand the concept of a namespace. Namespaces are a common feature in most programming languages. Therefore, they're not specific to PHP. You can carry this knowledge to other areas. A namespace can be thought of as a virtual folder for your code. Code organization is considered to be a huge priority for developers. If you've ever spoken with an experienced developer, one of the pain points of development is organization. Unorganized code is difficult to work with. If you're creating a small application, it might not seem like a big deal. Once you start working on medium to large size applications, it can become a nightmare to manage thousands of lines of code. To understand why, let's talk about folders. On your system, you may have folders for music, pictures, and videos. Technically, you can store various file types from within a single directory, but that would be inefficient. Finding files would take a while. Most people organize their files into folders. The most significant advantage of using folders is reusing file names. For example, let's say we are wedding photographers. Every wedding has a cake. To keep our project organized, each wedding may have a folder with a file called cake.jpg. These are duplicate file names. If these images existed within the same folder, our system would not allow them to have the same file name. However, since they're in separate directories, we can repeat file names without conflicts. This is the advantage of using folders. Without folders, we would have to be creative with our file names. This same idea applies to programming. Namespaces are the solution for organizing the names in our code. You can think of them as virtual folders for your code. In some cases, you may want to repeat class names. For example, what if we want to create a class for user accounts and bank accounts? Unfortunately, most programming languages do not allow duplicate names, which can force us to be creative with our names. By using namespaces, we can avoid these types of conflicts. Namespaces are an optional feature of PHP. In general, they're heavily adopted within PHP and the programming community. It's in our best interest to start creating namespaces. In the next lecture, let's create a namespace. In this lecture, we're going to create a namespace for the account class. A namespace can be created with a single keyword. We must define a namespace at the top of the PHP file. However, if we have strict typing enabled, it's perfectly fine to define the namespace after the declare statement. Let's add the namespace keyword. Next, we must provide a name for our namespace. The rules for naming functions or classes apply to namespaces. It's considered standard practice to use Pascal casing for your namespaces. Let's set the name to app. Just like that, we've created a namespace. Behind the scenes, PHP puts our class in a virtual folder. It's not a folder you can navigate to with your file system. It's more like a folder temporarily created in memory for your class. We're not limited to a single folder or namespace. If you're working on a larger application, you may want to consider nested namespaces. For example, let's change the namespace to app\bank. I'm using a backslash character, not a / character. Frequently, I find beginners use the incorrect character in namespaces. Whenever we use namespaces, we must always use the backslash character. There isn't a limit as to how many levels we can go. Generally, Most developers never exceed more than 2 levels of namespace. It's like if you had a complicated folder structure on your system. Managing your code is easier when you have 1 or 2 layers. For this example, I will keep it simple with the app namespace. Now that our namespace is ready, how does it affect our code? To find out, let's modify the index file. Previously, we updated the myAccount variable to be null. Let's change the value to a new instance of the account class. I'm going to pass on random values to both arguments of the class. After doing so, we get an error. Our class isn't working like it did before. To understand why, we must look closely at the error. It says the account class was not found, which might seem strange. Technically, we're including the account file with the require once keyword. The reason has to do with the namespace. It's not enough to just include the file. We must also reference the class through its namespace. Before creating the instance, include the namespace. Voila! The error has gone away. By placing a class inside a namespace, the namespace must be included during instantiation. Now you may be thinking, this is kind of annoying. It's extra code to write. Luckily, we can import a class with the use keyword. Below the require statement, add the following: use app \account. The use keyword allows us to import a specific class from a namespace. By doing so, we don't have to fully type the path to the class whenever we create a new instance. Whenever accessing a class, PHP checks if the class exists within the imported namespace. If it does, it'll grab the class from that location. So, we can remove the app from the instantiation. Our code continues to work. PHP can create an instance without a problem. Great! There are a few more things I want to mention about namespaces, but we're running short on time. So, let's talk about it in the next lecture. In this lecture, we're going to continue our discussion of namespaces. There are some gotchas and good practices you should be aware of when using them. First and foremost, the account class is defined in the root directory of the project. If we were to look at the file tree, our project is starting to get cluttered. For the best developer experience possible, we should try using folders. In our project, create a folder called app. Next, move the account file into this folder. Lastly, in the index file, we must update the require statement to load the file from the corresponding directory. The application should continue to work. You may have noticed, but the name of the directory and namespace match. This step is not required. Namespaces and directories don't have to have matching names. However, it's considered good practice. Let's say you opened a file that imports a class from a namespace. It's possible that the class may be producing errors. Naturally, you may want to open the file with the class to fix the errors. Large applications may have dozens of directories, which can make it harder to find files. To make it easier to find a class from a specific namespace, developers will keep the namespace and directory names consistent with each other. It's a practice we'll be following as well. So, that's the first thing I wanted to cover. Another key concept you should know is that importing classes from the same namespace are not necessary. Let me show you an example. Nowadays, most applications allow you to tie your social media accounts to your main accounts. I think it would be a good idea to dedicate a class to that feature. In the app folder, create a file called socialmedia.php. Next, add the app namespace to the file. Multiple classes are allowed to occupy the same namespace. However, it's important to note that duplicate class names are not allowed unless they're in different namespaces. Let's define a class called Social Media. Our class is ready. Let's load it before using it. Switch over to the index file. Below the other require statement, add another require once statement for the social media file. Great. The last step is to use this class. Typically, we would create a variable in the index file for storing the instance. However, Since social media accounts are associated with an account, I think it would make sense to store that information as a property of the account class. In the account class, let's define a property for storing an instance of the social media class. The property will be called social media. Next, set the data type to social media. It's perfectly valid to use a class as the data type. By doing so, PHP can restrict the value assigned to the variable to instances of the class. If we attempt to assign a different value, an error would be thrown. In addition, we're not including the namespace. Normally, the namespace would have to be included. However, since the social media class occupies the same namespace as the account class, PHP is able to resolve the class. Whenever we use a class, PHP checks the current namespace for the class. As a result, we don't have to specify the full path. Let's create a new instance. Inside the construct method, set the thisSocialMedia property to a new instance of the social media class. As you can see, our application continues to work. Resolving namespaces can be a tricky business. In the resource section of this lecture, I provide a link to a documentation page with more information on this topic. PHP goes through many rules to check where a class is defined. I'm not going to be able to go through every rule, so I highly recommend checking out this page for a complete breakdown of this feature. If you need more examples, PHP has a FAQ on namespaces. I also provided a link to this page in the resource section. If you look through the questions, you'll come across examples of how PHP resolves different namespaces. They're worth checking out too. With that being said, there are a few more things worth mentioning about namespaces. Let's head back to the index file from our project. Below the myAccount variable, I'm going to create a new instance of a class called datetime. PHP doesn't just provide us with predefined functions. There are a set of predefined classes available to us. If we are interested in working with dates and time, we can use a class called datetime. In most cases, PHP doesn't place its classes inside a namespace. Classes that aren't in a namespace are considered to be in a global namespace, which is why we don't have to add the use keyword. In the preview, the app continues to work despite not assigning the instance to a variable. PHP creates the instance and then destroys it. However, watch what happens when we create an instance in the account file. I'll move this line of code to the account file, below the namespace statement. This time, PHP is unhappy. Looking at the error, PHP states the class can't be found, which is strange. The class is defined by PHP, so shouldn't it be available? The answer to our question lies in the quotes from the error message. PHP is attempting to search for the class from the app namespace. By being in a namespace, we're no longer in the global namespace. PHP doesn't bother checking the global namespace since we're in a custom namespace. The datetime class does not exist. To fix this error, we must tell PHP to search for this class from the global namespace. That's simpler than you can imagine. Before the name of the class, add a / character. Adding this character resolves our issue. If we were to add this character without a namespace before it, PHP automatically resolves the class to the global namespace. An alternative solution is to use the use keyword. Above the instance, add the use keyword with the datetime class. Next, we can safely remove the / character. This works too. The use character can be used for resolving classes to the global namespace, not just our custom namespaces. One thing you'll notice is that we're adding the use keyword from the account file, but not the index file. Importing classes must be performed from the file where they're being used. Since we're using the datetime class from the account file, we must add the use keyword to this file. Let's see what happens when we don't do that. I'll move this line of code over to the index file. As you can see, PHP throws an error. Despite loading the index and account files, PHP does not recognize our import statement. The date-time class gets resolved to the app namespace, not the global namespace. I'll revert these changes to fix this error. Another cool feature of namespaces is aliases. Aliases are a feature for renaming a class after importing it. You may want to use an alias for two reasons. Firstly, if you're importing classes with the same name, using an alias can prevent PHP from throwing an error. Secondly, some classes can have really long names. It can be annoying to type out the entire name, so creating a shorter name can help with readability. Let's apply an alias for the date-time class. An alias can be applied by adding the as keyword to the import statement. Following this keyword, we must add a name for the class. Let's use the letters DT. Next, we can use DT instead of date-time like so. This works just as well. Aliases are an optional but handy feature. Alright, one more thing before we move on. Switch over to the index file. Currently, we're importing the account class. But what if we would like to import the social media class? Well, we can add a use statement for this class like so. This works, but there's a shorter way of importing multiple classes from the same namespace. Let's remove the second use statement. We can import multiple classes by wrapping the class with a pair of curly brackets. Inside these brackets, we can provide a list of classes by separating them with commas. So, if we want to import the social media class, we can import it like so. You may prefer this syntax instead of repeatedly typing the entire namespace for each class. So, that's about it for namespaces. In the next lecture, let's make some improvements to our code by using autoloading. In this lecture, we're going to begin auto-loading our classes. Let's take a look at the index.php file. Currently, we are requiring each class. It's only 2 classes, so it doesn't seem like that big of a deal. The thing is, once you start working on larger projects, continuously loading files can become tedious. Before you know it, you can have a large file filled with require statements. Since object-oriented programming is popular with PHP developers, there's a function for automating this process. Let's give it a shot. First, apply a comment to the require statements. Alternatively, you can completely remove them from your script. We're not going to need them anymore. Next, invoke a function called SPL Autoload Register. This function is defined by PHP. It has a few parameters, but we're only going to focus on the first parameter, which is a function to execute. Let's pass in an anonymous function. Whenever we use a class, PHP searches for the class definition. If it can't find the class, it'll execute the function passed into the SPL Autoload Register function. This behavior gives us the opportunity to load a class required by our program. Before doing so, we must know what class to load. This information is passed on to our function. In the parameter list, add a parameter called class. Next, call the variable dump function with this parameter. In the preview, an error gets thrown. This is because we aren't loading the account class. PHP is not able to create an instance of our class until we've loaded the file with the class definition. However, there's another thing worth noticing. The class parameter gets rendered before the error gets displayed. This result tells us that our anonymous function gets executed before PHP throws an error, which is a good thing. We have an opportunity to avoid disaster before PHP stops executing the script. Let's use this opportunity to load our file. Looking closely at the output, PHP is rendering the class with the namespace. This is not the system path to the file. If we had a different namespace, we would get a different result. This is another reason why developers prefer to keep the namespace and directories consistent with each other. It makes auto-loading easier. However, there is one problem with the class. PHP does not allow backward slash characters in the require statement. The first step is to replace the backward slash character with a forward slash character. Inside the function, define a variable called formatted class with an initial value of a function called string replace. The string replace function allows us to replace a portion of a string with another string. The first argument is the string to replace. Let's pass in a string with two backward slash characters. Throughout this course, I've told you that any type of character can be inserted into a string without consequence. There is one exception to this rule. If we type a backward slash character, PHP performs something called escaping. Escaping is the process of instructing PHP to ignore a closing quote. As we know, by typing another quote, PHP closes the string. What if we want to write a double quote from within a string like so? Since the string begins with a double quote, the string must end with a double quote. However, that means that we have a third double quote hanging around, which causes an error. If we want the second double quote to be included in the string, we have two options. The first option is to switch to single quotes. The second option is to apply a backward slash character before the second double quote. By adding this character, we're escaping a string. It's another way of telling PHP that the second double quote does not end the string. So, back to our original value. If we were to write a single backslash character, PHP does not end the string. That's not what we want. To avoid this issue, we can write two backslash characters to override that behavior. As a result, PHP treats this as a single backslash character. Moving along, let's pass in a forward slash character as the second argument to the string replace function. If PHP finds a backslash character, it'll get replaced with the string passed into the second argument. The last argument is the string to search through. Let's pass in the class parameter. Great! Our next step is to generate a full system path to the file. Define another variable called path. Set it to the following value, formattedclass.php. All we're doing is appending the extension to the path. Now that we have our path, we can load the file with the require keyword. If we refresh the page, the errors have gone away. We've successfully auto-loaded the class. If we have more files with classes, we can completely avoid requiring each file. Keep in mind, this behavior only applies to classes. If we have regular functions inside separate files, those files must be manually loaded. Alright, in the next lecture, let's keep exploring topics related to object-oriented programming. In this lecture, we're going to quickly talk about constants in classes. Classes can have constants, but only with the const keyword. PHP provides two solutions for defining constants, which are the const keyword and define function. However, the define function cannot be used in a class. We may only use the const keyword. For example, let's add a constant to the account class. In this class, define a constant called interest rate. Its value will be 2. Constants can have an access modifier. If we don't apply an access modifier to a constant, the modifier defaults to public. This doesn't just apply to constants, but properties and methods. However, it's always recommended to add an access modifier for extra clarity. Let's add the public modifier. Now, the question is, how can we access the constant's value? It's not the same as accessing a property or method. PHP has a special operator for accessing constants from within a class. Let's switch over to the index file. Previously, we called the variable dump function to view the balance. Let's replace it with the following, myaccount, : interest rate. The two colon characters are known as the scope resolution operator. This operator can be used to read constants from the class. In the preview, the constant's value gets rendered. Awesome! Now here's where things get interesting. PHP allows developers to access constants without an instance. Replace the myAccount variable with the account class. This produces the same result as before. So, what are the differences? Truthfully, there aren't any differences. It's just a different way to access a constant. In most cases, developers prefer to access constants without an instance. This way, if the variable disappears, our code continues to work since the class can still exist. So, that's how we can use constants in a class. In this lecture, we're going to learn about different ways of defining properties or methods. From a previous section, we talked about static variables. As a reminder, static variables are variables that can be defined in functions without losing their value. Once a function finishes running, PHP removes the variable from memory. On the other hand, static variables stay alive after a function finishes running. We're not limited to using static variables from within functions. Static properties and methods can be used from within a class. In our account class, let's create a static property by typing the following: public static integer count equals 0. By adding the static keyword, we've created a static property. The static keyword can be positioned before or after the access modifier. If you decide to add it before the modifier, that's fine. The most important thing is to be consistent. Static properties are similar to constants. They can be accessed without an instance. The main difference is that we're allowed to modify the value of a static property anytime we want. For example, let's update the count property whenever an instance of the account class gets created. In the construct method, type in the following: self-scope resolution operator count ++. I'm introducing a new keyword called self. Like I said before, an instance of the class does not need to exist to access the class. Typically, we would use the this keyword. However, the this keyword can only be used when referring to a specific instance. Since an instance is not guaranteed, we must use a different keyword for static properties called self. The self keyword points to the class. It gives us access to the static properties. Let's try accessing the static property. Switch over to the index file. In the variable dump function, let's replace the value passed in with the account scope resolution operator $count property. When accessing properties with this operator, we must include the $sign character. If we look in the preview, the property has been updated to 1. Alternatively, we can also access the static property through an instance. Instead of using the account class, let's replace it with the myAccount variable. That works just as well. Overall, static properties can be used for storing global data. However, many developers don't like static properties for the same reason. Global variables are considered to be dangerous since they can be changed anywhere in our program. Generally, it's ill-advised to use them unless you absolutely have to. With that being said, static methods can be more useful than static properties. Let me show you an example. In the app folder, add a file called utility.php. Next, add the app namespace. Afterward, let's define a class called utility. It's common for developers to have a class or two dedicated to utility functions. These are functions that are generic and can be used in a variety of scenarios. They're not functions that need to be tied to a specific class or instance. But why would we use a class if they're just regular functions? Well, as a reminder, we have autoloading enabled. If we had regular functions, PHP would not autoload those functions. We must manually include them. However, if those functions exist in a class, we can benefit from autoloading. At the same time, we don't want to create an instance of this class. This class should contain static methods only. Similar to static properties, static methods don't require an instance of the class to be accessible. In this class, define a public function called printArray. Next, add the static keyword after the access modifier. Just like that, we've got a static method. The goal of this method will be to neatly print an array. Let's accept the array as a parameter called array. Be sure to set the data type to array. Next, echo a pair of pre-formatted tags. In between these tags, call the printr function with the array parameter. Great, our function is ready. Let's give it a try. Back in the index file, let's import this namespace in the use statement by including the utility class. Lastly, let's call the utility print array method with the scope operator. In this method, let's pass in an array of random numbers. Just like that, we've got a simple utility method for neatly printing an array of values. This is how I usually use static methods. I rarely ever use static properties, but you may come across them from time to time in other projects. In the next lecture, let's move on to another topic of object-oriented programming. In this lecture, we're going to get into a discussion on object-oriented programming principles. So far, we've explored the various features of classes. That's great and all, but how do we properly write classes? There are 4 principles of object-oriented programming to adhere to during development. They're encapsulation, abstraction, inheritance, and polymorphism. Honestly, it sounds intimidating. No worries, I'll try my best to break down each concept throughout the course. Let's start with encapsulation. Encapsulation is the idea of restricting data and methods to a single class or object. Take the following example. We have a variable called amount. This variable gets updated from the foo function. This flexibility seems great at first, but can cause issues. Since our variable is available globally, it can be updated from anywhere. That's not something we may want. It can be difficult to debug variables that can be updated anywhere. If a variable has an incorrect value, we must track down where it was updated to fix the bug. The larger your code base, the longer it'll take to track down the bug. Encapsulation resolves these issues. By defining a variable from within a class, we can restrict the variable's access. This feature is known as encapsulation. Implementing encapsulation is easier than you think. Let's take a look at the account class. In the construct method, we have 2 properties called name and balance. Thus far, we've been setting the modifier to public. Let's try changing it to private. By using the public modifier, a property or method is accessible inside the class and outside of the class. Technically, we don't have to use the deposit method to update our amounts. We could have directly updated the balance property from our instance. In that case, public properties are just as vulnerable to problems as global variables. Changing the modifier to private prevents the property from being accessed outside of the class. We won't be able to read or update the value. It's only accessible to the current class. So, our deposit method will continue to work as before. This is the power of encapsulation. If the balance property has an invalid value, we know exactly where the problem can possibly be, which is the deposit method. As a result, it's much easier to debug our program. But what if we want to access the value from outside the class? That's possible with something called getters and setters. First, let me show you what happens when you try to access a private property. Open the index file. Below the myAccount variable, let's remove the clutter below the code. Next, try echoing the myAccountBalance property. In the preview, the interpreter tells us that we can't access a private property. To get around this issue, we can create a getter or setter function. A getter function is a function for returning a specific property from a class. Let's try creating one. Back in the account class, define a public method called getBalance. Getter functions can have any type of name. It's common practice to prefix the function name with the word get, followed by the name of the property that'll be returned by the function. We'll be following this convention. Inside this function, let's return the thisBalance property. Back in the index file, let's echo the value returned by the getBalance method. As you can see, the balance can be read from our class. Now, you may be thinking, what's the point of using a getter when using a public modifier works just as well? Getters give us the ability to format the value before it gets returned. Back in the account class, let's update our getBalance method by adding a $sign character before the balance. This is one of the reasons why you would want to use getters. We can take things a step further by verifying if the user has permission to view this property before returning anything. Alternatively, we can perform a query to a database to retrieve the value. Getter methods give us more flexibility with the value we can return. On the other side of the spectrum, we can define setter methods, which are functions for updating a specific property. Let's create a setter for our balance property. Below our getter method, define a function called setBalance. Similar to getters, it's common practice to use the word set followed by the property name. In the parameter list, add a float parameter called newBalance. Next, let's add a conditional statement to check if the newBalance parameter is less than 0. Preventing a negative balance is a common use case for using a setter. If the newBalance is less than 0, return the method to prevent further execution. Otherwise, we can safely proceed to set the thisBalance property to the newBalance parameter. We've successfully created a setter. Encapsulation is considered to be good practice. By limiting the accessibility of a property, we can constrain how a property can be read or updated. With that being said, there are some problems that can arise with getters and setters. First and foremost, for every property in our class, we may need to define a getter and a setter. As you can imagine, our classes can quickly become bloated. The best way to avoid bloat is to consider if a getter or setter is necessary. You shouldn't automatically create a getter or setter just because a property is private. The only time you should define them is when you actually need to. As long as you define getters and setters as needed, bloated classes can be avoided. There's one last thing I want to mention before moving on. Properties are not the only things that can be private. Methods can be private too. For example, let's define a function called sendEmail with the private modifier. Not all your methods should be public. For example, let's say the user's balance changes. If that's the case, we should send an email. However, that should only happen if the balance is successfully updated. If this method were public, it would be possible to send an email for other occasions, which is something we may not want. By defining private methods, only our class can call this method. For example, let's call this method after updating the balance in the setBalance method. Technically, our method doesn't send an email, but let's pretend that it did for the sake of this example. Now, if our balance gets updated, users will be notified of these changes. Overall, access modifiers are a powerful feature for limiting what can and can't be accessed from our class. In the next lecture, let's get into a discussion on the next principle, which is abstraction.